Are aliens headed for Earth right now, today? A theoretical physicist says the answer is maybe. He suggests a Manhattan-sized object known as 3I Atlas could actually be a mysterious alien spaceship.
At this very moment, somewhere between the planet Mars and the Sun, an object the size of Manhattan, an object from an entirely different star system, is engaged in an act never before documented in the entirety of human history. It is growing a tail, and according to one scientist from Harvard, this tail might be the very evidence of controlled maneuvering. You are watching as 3I Atlas, the third confirmed interstellar visitor to our solar system, has just entered a phase that could rewrite everything you thought you knew about these cosmic wanderers. Because what you are witnessing is different from any comet humanity has ever tracked. This object, you see, already possessed what scientists call an anti-tail, a forward-facing plume that seemed to defy the normal laws of physics. Now, as it barrels toward its closest approach to the Sun on the 29th of October, it has developed a traditional tail, one streaming behind it. The anti-tail-to-tail transition. It sounds technical, perhaps even mundane, but if the Harvard astrophysicist Avi Loeb is right, you might be watching the first documented evidence of an alien spacecraft completing a braking maneuver and beginning its acceleration phase. Let us be absolutely clear about what we are dealing with here. This is not speculation built upon grainy photographs or misinterpreted data. We have multiple observatories tracking this object in real time at this very moment. The Nordic Optical Telescope in the Canary Islands captured the transition in September. The Gemini South Telescope in Chile has provided the clearest images you have ever seen of an interstellar object. NASA's high-rise camera, riding aboard the Mars orbiter, grabbed shots when 3 Atlas passed within 12 million miles of the red planet earlier this month. Those images from Mars, by the way, would be the highest resolution photos of an interstellar object in human history. NASA has not released them. A government shutdown is the reason. So you sit here, waiting for images that could fundamentally alter our understanding of what is visiting our solar system, and they are locked behind bureaucratic delays. But even without those photos, what you are seeing is unprecedented, and it is happening with incredible speed. In just 4 days, on the 29th of October, 3I Atlas will reach perihelion, its closest point to the Sun, coming within 130 million miles of our star. That is 1.4 astronomical units, almost 1.5 times the distance between the Earth and the Sun. For reference, most comets go wild when they get that close. The ice sublimates, jets of gas and dust explode from the surface, tails grow millions of miles long. It is a spectacle, and 3I Atlas is putting on that show right now. But it is the sequence of events that has scientists intrigued and, frankly, a little unsettled. First came the anti-tail, not a tail streaming behind the object as solar radiation pushes material away from the Sun. An anti-tail, a plume shooting forward in the direction of travel. Analysis of that plume revealed something that set off alarms across the astronomical community. It contained materials that included a nickel alloy never before seen in nature. An alloy only known from human manufacturing. Water, carbon dioxide, cyanide, those you would expect from a comet. But a manufactured nickel alloy, that is not natural, that is engineered. Now, before you spiral into science fiction, let us acknowledge the conventional explanation. Perhaps, under extreme and unknown conditions in some distant star system billions of years ago, natural processes created this alloy. Maybe there are formation mechanisms we do not yet understand. Maybe, but here is where it gets interesting. That anti-tail, which Loeb described as potentially indicative of a braking thrust, has now transitioned into a traditional tail. The images from the Nordic Optical Telescope show material being stripped off the rear of the object as it accelerates toward the Sun, getting hammered by up to 33 gigawatts of solar radiation. If you are piloting a spacecraft from another star and you need to slow down as you enter a solar system, you would fire your engines forward, creating thrust that opposes your direction of travel. That would produce a forward-facing plume, an anti-tail. Then, once you have shed enough velocity, you would reorient, possibly to adjust course or accelerate toward your target. That would produce a tail streaming behind you. That is the sequence we have just observed. So is 3I Atlas an alien spacecraft performing a controlled maneuver through our solar system, or is it an ancient comet, 7 to 10 billion years old, reacting to solar radiation in ways we are still struggling to understand? The answer matters, because if it is the former, you are living through one of the most significant moments in human history, and most people have no idea it is H. Appending, this is where the International Asteroid Warning Network enters the picture. Earlier this week, they added 3I Atlas to their official target list, not because it poses a collision threat, it does not, but because this object represents an unprecedented scientific opportunity. They wrote on their website, while it poses no threat, Comet 3I Atlas presents a great opportunity for the IAWN community to perform an observing exercise due to its prolonged observability from Earth and its high interest to the scientific community. Prolonged observability. That is key, unlike Oumuamua, which zipped through the inner solar system in 2017 before we could barely get our instruments pointed at it. 3I Atlas has been visible for months. You have had time to study, time to analyze, time to watch it evolve. And what you have watched is something behaving in ways that keep defying expectations. Let us talk about what should be happening versus what is happening. At 1.4 astronomical units from the Sun, a typical comet would be active, sure, but not violently so. Water ice does not sublimate aggressively at that distance. You need to get closer, inside about 1 astronomical unit, before water really starts outgassing in large quantities. But 3I Atlas has been spewing water for months, 40 kilograms per second, like a fire hose on full blast at distances where that should not be possible. The composition offers a clue. This comet is extraordinarily rich in carbon dioxide with an 8-to-1 ratio of carbon dioxide to water. Carbon dioxide sublimates at much greater distances from the Sun than water ice. So the carbon dioxide has been outgassing for a while, and it is that outgassing that is driving the activity. But here is the thing. As 3I Atlas gets closer to the Sun and temperatures rise, the water is going to start sublimating more aggressively. The tail you are seeing now is about to grow dramatically. When this thing emerges from behind the Sun in early November and becomes visible again, it could look completely different, bigger, brighter, more active. Scientists are preparing for that moment. Telescopes on the ground, in orbit, even instruments on spacecraft en route to Jupiter are being redirected to capture what happens next. Because whatever 3I Atlas is, comet or craft, it is about to give us the show of a lifetime, and you have a front row seat. The question is, what will you see when it reappears? Let us rewind for a second. How did we even spot this thing in the first place? On the 1st of July, 2025, the Atlas Survey Telescope in Chile, an automated system designed to scan the sky for asteroids and comets, flagged a faint object moving against the background stars. In isolation, not unusual, Atlas finds objects all the time. But as data accumulated over the following days and weeks, astronomers realized something was off. The trajectory was not elliptical, it was hyperbolic. That is the signature of an interstellar object, something not bound by the Sun's gravity, something just passing through. Confirmation came quickly. Within weeks, observatories around the world had locked onto 3I Atlas and verified its interstellar origin. It was traveling at 210,000 kilometers per hour relative to the Sun. Fast, but not absurdly so for an object in interstellar space. Its trajectory could be traced back through the galaxy, and when astronomers ran the numbers, the results were staggering. This object is ancient, 7 to 10 billion years old. It formed billions of years before our Sun even existed, in a star system that might not even exist anymore. Think about that for a second. You are looking at an object that witnessed the early universe. It formed when galaxies were still young, when star formation rates were at their peak, when the cosmos was a very different place. And it has been wandering the galaxy ever since, surviving radiation, cold, cosmic rays, collisions with interstellar dust. And now, by sheer chance, it is here, passing through our neighborhood, giving us a glimpse of a world you will never visit. Except it is not behaving like a passive chunk of ice drifting through space. It is active. It is shedding material. It is changing. The Gemini South Telescope image from the 27th of August is stunning. You see 3I Atlas streaking through the frame, a faint coma surrounding the nucleus, the tail just beginning to form. The stars in the background are smeared into lines because the exposure tracked the comet's movement. It is a snapshot of motion, of something journeying. But zoom in on that coma, the glowing cloud of gas and dust surrounding the nucleus, and you see structure, jets, plumes, material being ejected in specific directions, not uniformly. That is not random. That suggests active regions on the surface, areas where sublimation is concentrated. On a natural comet, those active regions are usually associated with surface composition variations. Maybe one area has more ice, another more dust. As the sun heats the surface, the ice-rich regions outgas more aggressively, creating jets. But on a spacecraft, active regions could be thrusters, vents, controlled releases of propellant. This is the ambiguity we are stuck in. Every observation that could support the "it's just a comet" hypothesis can also be interpreted through the "it's something else" lens. Avi Loeb has been vocal about this. In his recent paper, he laid out the case for why the anti-tail-to-tail transition could indicate controlled maneuvering. He is not saying it is a spacecraft. He is saying we cannot rule it out. And given the stakes, you should be taking that possibility seriously, because if there is even a 1% chance that 3 Atlas is artificial, then observing it becomes the most important scientific endeavor of our time. But let us ground ourselves in what we know for certain. We know the object is roughly 2 to 6 kilometers across. Estimates vary because we cannot resolve the nucleus directly. It is too far, too small, surrounded by a coma that obscures the surface. But based on brightness and activity levels, 2 to 6 kilometers is the range. For comparison, that is about the size of Manhattan or Mount Everest. It is massive. 33 billion tons of material moving at interstellar speeds. We know its composition is dominated by carbon dioxide with water, cyanide, and trace amounts of other volatiles. The nickel alloy is the wild card. No one expected that. No one has a fully satisfying explanation for it, but it is there, documented in spectroscopic data. We know it is old. The trajectory backtracking and isotopic analysis, if we had samples, which we do not, suggest formation in the early universe. This is a relic, a fossil from a time when our galaxy looked completely different. We know it has been active since at least early August, when the first outgassing was detected. That is unusual. Most comets do not turn on until they are much closer to the sun. But 3I Atlas was already spewing material at 3 astronomical units, 3 times the Earth's sun distance. And we know it is about to get more active, a lot more. When 3I Atlas swings around the sun on the 29th of October, it will be subjected to intense heat and radiation. The surface temperature will spike, sublimation rates will increase, the tail will grow, and depending on how much volatile material is left on the surface, you could see dramatic outbursts. NASA's SOHO spacecraft, which monitors the sun, might catch glimpses of 3 Atlas as it makes its closest approach. The images would be low resolution, but they would give us a sense of the comet's behavior in the most extreme environment it will encounter during this pass. Then in early November, 3I Atlas will reappear in the pre-dawn sky, having survived its solar encounter. Telescopes will be watching, cameras will be rolling, and you will see what it looks like on the other side. Will the tail be longer? Will the brightness have increased? Will there be signs of fragmentation, chunks breaking off due to thermal stress? Or will it look more or less the same, suggesting a resilient structure capable of withstanding extreme conditions? That resilience, by the way, is another point in favor of the something unusual hypothesis. Natural comets, especially ancient ones, tend to be fragile. They break apart, they shed layers, they disintegrate. 3I Atlas has been traveling through interstellar space for billions of years, getting bombarded by cosmic rays and high-energy particles. The surface should be heavily damaged, eroded, and yet it is still intact, still active, still shedding material in a controlled manner. How one possibility. It has been dormant for most of its journey, frozen solid in the deep cold of interstellar space where temperatures hover just above absolute zero. In that state, chemical processes essentially stop. There is no weathering, no erosion. The comet becomes a time capsule preserved for eons. Only when it enters a solar system and begins warming up does it become active again. The ice starts sublimating, jets form, tails grow, it wakes up. If that is the case, then 3I Atlas might have passed through dozens, hundreds, maybe even thousands of star systems over its lifetime, activating briefly each time before returning to dormancy as it drifts back into interstellar space. A wanderer, a cosmic nomad, traveling the galaxy, visiting stars, moving on. There is something poetic about that, and also slightly eerie. Because if that is true, then interstellar space is filled with these ancient, dormant objects just waiting for the next star to wake them up. And occasionally one of them finds its way here. Now here is where things get genuinely strange. And I mean strange in a way that makes scientists uncomfortable. The transit. Iron from antitail to tail is not just visually dramatic. It represents a fundamental change in how material is being ejected from the object. And the timing is suspicious. When 3 Atlas first developed its antitail back in August, the plume was pointing forward in the direction of travel. Material was being expelled ahead of the object. For a natural comet, this can happen under specific circumstances. If the comet is rotating in a particular way, or if solar radiation pressure is interacting with the coma in unusual ways, you can get forward-directed jets. But those explanations require very specific conditions, and they do not account for the composition of the plume. That nickel alloy, the one that has never been seen in nature. Loeb's hypothesis is straightforward. If you are trying to slow down a massive object traveling at interstellar speeds, you need thrust opposing your direction of motion. Fire your engines forward and you create a plume of exhaust ahead of you. That is the antitail. Once you have shed enough velocity, you either shut down the engines or reorient the craft. At that point, natural outgassing takes over or you switch to a different propulsion mode. Solar radiation starts stripping material off the rear of the object. That is when you get the traditional tail. The sequence matches almost perfectly, but here is the counter-argument, and it is a strong one. Space is weird. Comets do unexpected things. We have seen comets fragment for no apparent reason. We have seen them brighten suddenly, dim unexpectedly, develop multiple tails, split into pieces, and defy predictions. 3 Atlas could just be another example of how little we truly understand about comet behavior, especially for objects from other star systems where formation conditions might be radically different from anything in our solar system. Except we have now studied 3 interstellar visitors, and all 3 have been bizarre in completely different ways. Oumuamua accelerated as it left the solar system. No visible outgassing, no tail, no coma, just acceleration. Scientists eventually settled on the explanation that it was outgassing something we could not detect, maybe hydrogen, which is invisible to most telescopes. But that explanation required some creative physics. The acceleration was real. The cause remains debated. 2I Borisov, the second visitor, was the normal one. It looked like a comet, acted like a comet, had a composition similar to comets from our own Oort cloud. High carbon monoxide content, sure, but within the range of what we would expect. 2I Borisov was reassuring. It suggested that interstellar comets were not all going to be weirdos. And then came 3I Atlas, ancient, carbon dioxide rich, spewing water where it should not, sporting a manufactured nickel alloy, and now transitioning from an anti-tail to a tail in a sequence that looks suspiciously like a spacecraft maneuver. 3 visitors, 3 wildly different profiles, and the statistical implication is staggering. If you have detected 3 interstellar objects in just 8 years, and all 3 are this diverse, then our galaxy must be absolutely teeming with these things. Thousands, maybe millions, passing through the solar system every year, most of them too faint or too fast for us to detect. You are only seeing the tip of the iceberg, and here is the unsettling part. You have no idea what most of them are. You catch the bright ones, the active ones, the ones that happen to pass close enough to Earth that our telescopes can spot them. But the dark ones, the inactive ones, the ones moving at different angles or speeds, they are invisible to us, which raises an obvious question. How many artificial objects could be slipping through our solar system completely undetected? If a civilization wanted to send probes to neighboring star systems, the logical design would be something that blends in. Something that looks like a natural object, a comet, an asteroid, maybe even a cloud of dust. You would not send a shiny metallic spacecraft broadcasting radio signals. You would send something quiet, something camouflaged. And if you wanted it to be autonomous, capable of navigating between stars without constant communication, you would give it decision-making ability, the ability to adjust course, to slow down, to investigate points of interest like planets, or more specifically, planets with atmospheres, planets with water, planets with biosignatures, planets like Earth. Now, before anyone accuses me of going full conspiracy theory, let me be clear. There is currently no evidence that 3 Atlas is targeting Earth or has any interest in our planet. its trajectory takes it nowhere near us. After perihelion, it will head back out into interstellar space, and you will never see it again. But the fact that we are even having this conversation, the fact that serious scientists are publishing papers discussing the possibility of artificial interers. Teleobjects tells you how much the paradigm has shifted. 10 years ago, suggesting that an asteroid or comet might be an alien probe would have been career suicide. You would be laughed out of the room. But Oumuamua changed that. The weirdness of that object, the inability to fully explain its behavior with conventional models opened a door. And now with 3 Atlas, that door is opening wider. The International Asteroid Warning Network's involvement is significant. This is a group coordinated by NASA and other space agencies specifically to track near-Earth objects that could pose impact threats. They monitor asteroids, calculate orbits, run simulations, and prepare response plans. For them to add 3 Atlas to their target list, not because it is dangerous, but because it is scientifically important, signals that the scientific community recognizes this object as something extraordinary. Their statement is carefully worded. While it poses no threat, Comet 3I Atlas presents a great opportunity for the IAWN community to perform an observing exercise. An observing exercise, that is the official language, but read between the lines. They are mobilizing international resources to track this thing. They are coordinating observations across multiple observatories. They are treating it like a high-priority target. Why? Because opportunities like this are rare. You might not see another interstellar visitor this well positioned for observation for decades. And if there is any chance at all that this object is more than just a comet, then every data point matters. So what happens next? In 4 days, 3 Atlas reaches perihelion. It will be closer to the Sun than it has been at any point in its multi-billion-year journey. The surface will heat up, volatiles will sublimate, the tail will grow, and you will be watching. NASA's Solar and Heliospheric Observatory, SOHO, will likely capture images as the comet passes through its field of view. The resolution will not be great. SOHO is designed to study the Sun, not comets, but it will give us a sense of how active 3I Atlas becomes under maximum solar heating. Ground-based telescopes will be tracking it right up until it disappears behind the Sun. And then for a few weeks, you will lose sight of it entirely. It will be on the far side of our star, hidden from view. That period when we cannot observe it is going to be agonizing for scientists because anything could happen. The comet could fragment, it could have a massive outburst, it could change trajectory, and you will not know until it reappears. Early November, that is when 3I Atlas will become visible again, emerging from behind the Sun in the pre-dawn sky. Telescopes will lock on immediately, cameras will start recording, spectrometers will analyze the light, and you will see what it looks like after its solar encounter. If it is just a comet, you would expect to see changes. Maybe the tail is longer, brighter. Maybe there is evidence of fragmentation, smaller pieces trailing behind the main nucleus. Maybe the activity level has increased or decreased depending on how much volatile material was lost during perihelion. But if it is something else, if there is any truth to the artificial object hypothesis, then what you see might be completely unexpected. Maybe the tail disappears. Maybe the object reorients. Maybe it changes velocity in a way that cannot be explained by solar radiation or outgassing. You will not know until it happens, and that is the hook. That is what has the scientific community on edge. We are in a holding pattern, waiting for an object we do not fully understand to do something we cannot predict. Meanwhile, those high-rise images from the Mars orbiter remain unreleased, locked away due to government shutdown. The highest resolution images of an interstellar object ever captured by human technology, and you cannot see them. The frustration in the scientific community is palpable. Researchers have been waiting for those images for weeks. They were supposed to provide clarity, details about the surface structure, the nucleus size, the activity patterns. Instead, they are sitting in a database somewhere, inaccessible. It is a reminder of how fragile our infrastructure for this kind of research really is. You have billion-dollar telescopes and spacecraft capable of incredible observations, but if the people managing the data cannot release it due to bureaucratic issues, then all that technology is useless. Assuming the shutdown ends and the images are eventually released, what might they show? At 12 million miles, HiRISE would have been able to resolve features on 3 Atlas down to maybe a few dozen meters. Not enough to see fine details, but enough to get a sense of the object's shape, surface texture, and activity. If it is a typical comet nucleus, you would expect to see an irregular shape, maybe elongated or lumpy with active regions where jets are erupting. The surface would be dark, covered in a layer of dust and organic compounds that have been baked by cosmic rays over billions of years. But if the shape is too regular, too smooth, or if there are structures that look artificial, linear features, geometric patterns, things that do not fit natural formation processes, then you would have a problem. A good problem in the sense that it would confirm you are dealing with something extraordinary, but also a terrifying problem because it would mean you have been visited by technology from another civilization and you have no idea what it is doing here or where it came from. Let us talk about the composition again, because it is crucial to understanding what 3I Atlas might be. The 8:1 ratio of carbon dioxide to water is extreme. In our solar system, comets typically have much higher water content. Water is the dominant volatile. Carbon dioxide is present, sure, but usually in smaller amounts. For 3I Atlas to be so carbon dioxide rich suggests it formed in a very different environment. Possibly a star system with a cooler star where temperatures at the comet formation zone were low enough that carbon dioxide ice could condense more readily than water ice. Or this is the alternative explanation: it formed in a molecular cloud, the dense interstellar regions where stars are born. In those environments, carbon dioxide can be more abundant than water depending on the chemistry. If 3I Atlas is a rogue object ejected from its birth star system billions of years ago and wandering the galaxy ever since, then it might carry the chemical signature of that ancient molecular cloud. Either way, the composition tells a story. A story of a place very different from here, a place where the rules, the temperatures, the chemical processes were alien to us, and that manufactured nickel alloy sits in the middle of that story like a glitch in the matrix. There are natural nickel-iron alloys. Meteorites contain them, but the specific composition detected in 3I Atlas's anti-tail does not match any known natural formation process. It is a blend that on Earth we produce intentionally for specific purposes. High-strength applications, aerospace materials, things like that. Could nature produce it under extreme, unknown conditions? Maybe, you cannot rule it out, but the burden of proof is starting to shift. The more anomalies stack up, the harder it becomes to keep invoking unknown natural processes as an explanation. At some point, the simpler explanation becomes, it is artificial. Occam's razor cuts both ways. Yes, you should prefer natural explanations when possible. When the natural explanation requires multiple layers of improbable coincidences and unknown physics, and the artificial explanation fits the data more cleanly, then which is really simpler? This is the debate happening right now in astronomy departments and research institutions around the world. And it is not a fringe debate anymore. It is mainstream. People are taking it seriously. Because here is the thing about science. It evolves. What seemed impossible yesterday becomes routine tomorrow. Continental drift was laughed at. Meteorites from space were considered peasant superstition. Black holes were mathematical curiosities that could not possibly exist until they did. And now you are in a new phase of that evolution. The idea that you might detect evidence of extraterrestrial technology, not through radio signals from distant stars, but through physical objects passing through our solar system. That is no longer science fiction. It is a legitimate scientific hypothesis that deserves investigation. The term for this is technosignatures, evidence of technology created by non-human intelligence. SETI, the search for extraterrestrial intelligence, has been scanning the skies for radio signals for decades. That is one type of technosignature. But physical artifacts, probes, spacecraft, those would be technosignatures too. And if you are going to send a probe across interstellar distances, you are not going to make it obvious. You are going to make it robust, self-sufficient, and probably indistinguishable from natural objects to anyone who is not looking closely. That is what makes 3 Atlas so unsettling. It looks almost natural, almost. But there are these little details, these anomalies that do not quite fit. The nickel alloy, the anti-tail-to-tail transition, the extreme carbon dioxide dominance, the water production at impossible distances, the structural integrity over billions of years. Individually, maybe you can explain each one away, but together they form a pattern, and patterns demand attention. Now, let us talk about what this object is actually doing as it moves through our solar system. Its trajectory is well mapped at this point. It came from the direction of the constellation Ursa Major, the Great Bear, traveling at about 58 kilometers per second relati. V to the local standard of rest. That is the average velocity of stars in our galactic neighborhood, not particularly fast for an interstellar object. Oumuamua was faster. It entered the solar system from above the ecliptic plane, that is the flat disk where most planets orbit, coming in at an angle like that is actually pretty common for interstellar visitors. They are not bound by our solar system's geometry. They approach from whatever direction their galactic orbit happened to carry them. As it got closer to the Sun, gravity bent its trajectory into the hyperbolic arc you are tracking now. It swung past Mars in early October, close enough for the high-rise camera to grab those images you still have not seen. Then it continued inward toward perihelion. After the 29th of October, after it rounds the Sun, the trajectory will carry it back out of the inner solar system at a different angle. It will cross the orbit of Mars again in late November, but much farther from the planet this time. Then it will pass through the asteroid belt, cross Jupiter's orbital path sometime in early 2026, and eventually leave the solar system entirely. The exit trajectory will take it toward the constellation Lyra, a different direction than it came from, because the Sun's gravity altered its path. That is normal. What would not be normal is if the trajectory changes in ways that cannot be explained by gravitational interactions. And that is what scientists will be watching for after perihelion. Any deviation, any course correction, any acceleration that does not match the expected physics. That would be significant because if this thing is artificial, if it has any kind of propulsion system, then it might use the perihelion passage as cover to make adjustments. While it is behind the Sun, while you cannot observe it, it could fire engines, change velocity, alter course, and by the time you see it again in November, it could be on a completely different trajectory. You will not know if that happened until you get fresh observations, and even then, small changes might be hard to detect. But if there is a significant deviation, if 3I Atlas emerges from perihelion moving faster or slower than expected or heading in a direction that does not match gravitational predictions, then you will have your answer. Not proof, maybe, but strong evidence. The challenge is that space is complicated. There are a lot of factors that can influence an object's trajectory. Solar radiation pressure, outgassing forces, even the gravitational influence of planets millions of miles away can have subtle effects. Calculating the expected trajectory requires accounting for all of those variables, but that is what astronomers do. They model these systems, they run simulations, they predict where an object should be based on the known physics, and then they compare those predictions to observations. If the observations match the predictions, great. The object is behaving as expected, but if there are discrepancies, unexplained deviations, then you start asking why. With 3 Atlas, there has already been one unexplained deviation. Back in August, some researchers noted that the object's brightness changed in ways that were not fully consistent with a simple rotation model. Comets often vary in brightness as they rotate because different sides of the nucleus reflect different amounts of light, but 3I Atlas's brightness variations did not follow the pattern you would expect from a uniformly rotating irregular object. It could be that the nucleus has an unusual shape, or that the active regions are distributed asymmetrically, causing brightness spikes when jets are pointed toward Earth. Or it could be that the object is not rotating uniformly. Maybe it is tumbling in a complex way. Or, and this is the uncomfortable possibility, it could be that the brightness variations are related to something other than rotation, like orientation changes, like active maneuvering. Again, you are in this frustrating space where every observation can be interpreted multiple ways. And without more data, without those high-rise images, without high-resolution spectroscopy from multiple angles, you cannot definitively rule anything out. But here is what you can say. 3 Atlas is behaving differently from any comet you have studied in detail, and it is doing so in ways that are at least consistent with the artificial object hypothesis. That does not mean it is artificial. It means you cannot exclude the possibility, and given the implications, that is enough to warrant serious attention. So, what would it mean if 3I Atlas actually is some form of alien technology? First, it would confirm that you are not alone in the universe. That is the big one. The question that humanity has been asking for millennia would finally have an answer. There is other intelligent life out there, or at least there was. Because remember, This object is billions of years old. The civilization that built it, if it was built, might not exist anymore. Second, it would tell us that interstellar travel is possible, not just theoretically possible, but actually achievable. Some civilization figured out how to send objects between stars and did so on a scale where those objects are reaching us with measurable frequency. Third, it would raise massive questions about intent and capability. Why send probes to other star systems? What are they looking for? What are they designed to do? Are they autonomous or are they reporting back somehow? And if they are reporting back, to where, to whom? And fourth, it would fundamentally change our approach to astronomy. Every asteroid, every comet, every interstellar visitor would need to be scrutinized not just as a natural object, but as a potential artifact. You would need new protocols, new observational strategies, new ways of thinking about what you are seeing in the sky. The implications are staggering, which is why most scientists are hesitant to embrace the artificial object hypothesis without overwhelming evidence. The bar is high, and it should be. Extraordinary claims require extraordinary evidence, but the evidence is starting to accumulate. And with each new observation, each new anomaly, the question becomes harder to dismiss. Let us circle back to the tail for a moment, because the timing of its appearance is worth examining more closely. The antitail was first documented in early August, when 3I Atlas was still relatively far from the Sun, around 2.5 astronomical units. At that distance, the object was already active, already outgassing, and the material was being expelled forward. Fast forward to September, and the Nordic Optical Telescope captures images showing a traditional tail streaming behind the object. The transition happened somewhere in that window, probably late August or early September. That is roughly when 3I Atlas was passing through the 2 astronomical unit mark, twice the Earth-Sun distance. The solar radiation at that point is about 4 times less intense than what Earth receives, but still significant enough to drive sublimation of volatile materials like carbon dioxide. The question is, why did the anti-tail stop and the regular tail start at that specific distance? If it is purely natural processes, then maybe there is a threshold. Maybe at greater distances the rotation and outgassing dynamics favor forward-directed jets. And as the object gets closer and solar radiation increases, those dynamics shift and the tail starts forming in the traditional manner. Possible, but it requires a pretty specific set of conditions to work out that way. If it is artificial, then maybe 2 astronomical units was the target distance for completing the braking maneuver. Maybe the propulsion system was designed to fire until the object reached a certain distance from the Sun and then shut down. At that point, natural outgassing takes over and the tail forms normally, also possible. And honestly, from an engineering standpoint, it makes sense. If you are trying to slow down an interstellar object as it enters a solar system, you would want to complete the maneuver before you get too close to the star where thermal stresses and radiation could interfere with your systems. 2 astronomical units seems like a reasonable distance to aim for, far enough to avoid the worst of the solar environment, close enough that you have captured into a trajectory that will take you through the inner system for observation purposes. But this is speculation, informed speculation, based on what we know about orbital mechanics and spacecraft design, but speculation nonetheless. What is not speculation is that the transition happened. It is documented in multiple independent observations. The anti-tail was there, and now it is not. The regular tail is there, and it is growing. Something changed. The object's behavior shifted at a specific point in its approach to the Sun, and that shift is either a coincidence, an artifact of comet physics you do not fully understand, or evidence of deliberate action. Scientists are going to be analyzing this transition for years. They will model every possible natural mechanism, test every hypothesis, run simulations, compare 3 Atlas to other comets, and eventually you will get closer to an answer. But for now, you are left with uncertainty. And uncertainty in a case like this is almost more fascinating than a definitive answer because it means the door is still open. The possibility is still live. Let me give you another detail that has not gotten as much attention, but is equally strange: the cyanide. Yes, cyanide is found in comets. It is a common byproduct of organic chemistry in space, but the amount of cyanide 3I Atlas is producing is unusually high. Spectroscopic observations show strong emission lines corresponding to Cn, the cyanide radical. In typical comets, cyanide I is present but not dominant, You see it, but it is not a major component of the coma. With 3 Atlas, it is prominent, which suggests either that the comet's interior is unusually rich in cyanide-bearing compounds or that something about the outgassing process is preferentially releasing cyanide. Why does this matter? Because cyanide chemistry is complex. It is involved in the formation of amino acids, the building blocks of proteins. It is part of the prebiotic chemistry that might have led to life on Earth. Finding high concentrations of cyanide in an interstellar object is scientifically interesting from an astrobiology perspective, but it is also interesting from another angle. Cyanide compounds can be used as propellants. In chemical propulsion systems, you need materials that release energy when they decompose or react. Cyanide-based compounds fit that bill. They are not the most efficient propellants we use on Earth, but they are effective and they are composed of elements that are abundant in space. Could 3I Atlas be using cyanide chemistry as part of a propulsion system? Could that explain the high CN concentrations? It is a stretch. It really is. But it is the kind of detail that when combined with everything else makes you wonder. And that is the position you are in with this object. Wondering, questioning, trying to fit together pieces of a puzzle that might not even be complete yet. The 29th of October is going to be a critical day. Telescopes around the world will be locked onto 3I Atlas, recording every photon of light reflected or emitted from the object. Spectrometers will break down that light into its component wavelengths, revealing which molecules are present and in what quantities. Photometric instruments will measure brightness changes down to tiny fractions of a percent, and then the object will disappear behind the sun and you will wait. The waiting is going to be difficult, not just for scientists, but for anyone paying attention to this story, because you will know that something extraordinary is happening just 100 million miles away, and you will not be able to see it. It is like watching a thriller and having the screen go black right at the climax. You are left in suspense, forced to imagine what is happening, unable to do anything but wait for the next scene. And when 3I Atlas reappears in early November, that is when the real analysis begins. That is when you will see if it survived perihelion intact, if it fragmented, if it changed. That is when you will measure its new trajectory and compare it to the predictions. That is when you will start getting answers. Or more likely, that is when you will get more questions. Because objects like this, they do not tend to provide clean, simple answers. They raise complexity, they challenge assumptions, they force us to expand our understanding, and maybe that is the point. Maybe the universe is trying to tell us that we do not know as much as we think we do, that there is still mystery out there, still wonder, still things that defy easy explanation. 3I Atlas, whether it is a comet or something else, is a reminder of that. A reminder that you are still explorers, still discoverers, still students of a cosmos that is far stranger than you ever imagined. Think about the timing of all this. You are living in a unique moment in human history. For the first time, we have the technology to detect and study interstellar visitors in detail. 50 years ago, 3 Atlas would have passed through the solar system completely unnoticed. 100 years ago, we did not even know other galaxies existed, let alone that objects could travel between star systems. But now, you have automated survey telescopes scanning the sky every night. You have space-based observatories with capabilities that would have seemed like science fiction a generation ago. You have international networks coordinating observations across continents. You have the tools to see these visitors, to track them, to analyze them. And what you are finding is that the universe is far more dynamic, far more populated with wandering objects than you ever suspected. The solar system is not a closed box. It is permeable. Things come through all the time. And occasionally, one of those things is strange enough to make us question everything. There is another aspect to this that is worth considering. The public reaction, or rather, the lack of it. Right now, as I am speaking, a potentially alien spacecraft is racing toward the sun, and most people have no idea. It is not leading the news. It is not dominating social media. It is a niche story covered by science outlets and space enthusiasts, but largely invisible to the mainstream. Why? Part of it is fatigue. You have been teased with the possibility of alien life for so long that people have become desensitized. Every few months, there is a new headline about possible biosignatures on Mars or mysterious signals from space or anomalous objects, and every time the story fizzles, the biosignature turns out to be geology. The signal is interference. The anomaly is explained. People have learned not to get excited until there is definitive proof. And with 3 Atlas, you do not have that. You have anomalies, yes, you have questions, absolutely, but you do not have proof. And maybe that is appropriate. Maybe we should not be jumping to conclusions. Maybe the scientific approach, the careful analysis, the insistence on extraordinary evidence is exactly the right way to handle this. But there is a part of me that wonders if you are being too cautious, if you are so afraid of being wrong, so afraid of looking foolish, that you are not allowing yourselves to seriously consider the possibility that you are witnessing something historic. Because here is the reality. If 3I Atlas is artificial, you are living through first contact. Not the Hollywood version, not aliens landing on the White House lawn, but the real version, an artifact from another civilization passing through our neighborhood, potentially observing us, and you are observing it right back. First contact might not be a conversation. It might be this. 2 intelligent species separated by billions of years and trillions of miles, briefly sharing the same cubic light year of space. One of us leaving behind technology that survives long enough to be detected by the other. It is not dramatic. It is not explosive. It is quiet, subtle, easily missed if you are not paying attention. And that might be the most profound version of contact you could hope for, because it does not require the aliens to still exist. It does not require them to be interested in us specifically. It just requires that they at some point in the deep past figured out how to send objects between stars, and we now have figured out how to see those objects when they pass through. That is a kind of dialogue, a dialogue across time and space mediated by physics and technology. And if that is what is happening here, if 3 Atlas really is an artifact, then the fact that most people do not know or do not care is both tragic and oddly fitting, because this is how the universe works. It does not announce itself. It does not make things easy. You have to look closely. You have to pay attention. You have to be willing to ask uncomfortable questions. Now let us bring this back to the immediate future. What should you be watching for in the coming weeks? First, the perihelion passage on the 29th of October. Any unusual activity, any unexpected changes in brightness or tail structure, those would be significant. If 3 Atlas suddenly brightens by orders of magnitude, that could indicate a massive outburst or fragmentation event. If it dims unexpectedly, that could suggest that the active regions have shut down or that the object has reoriented. Second, the high-rise images, if and when they are released. Those images could provide visual confirmation of the object's structure. Is it irregular and lumpy like a natural comet? Or is there something about the shape that does not fit natural formation, linear features, symmetry, structures that look engineered? Third, the November re-emergence. When 3 Atlas becomes visible again after perihelion, the first observations will be critical. Measure the brightness, the tail length, the spectroscopic signature. Compare everything to the pre-perihelion data. Look for changes, look for anomalies. And fourth, the trajectory. This is the big one. After perihelion, astronomers will calculate the object's new trajectory with high precision. They will compare it to the predictions based on gravitational modeling. If there are discrepancies, if the object is moving faster or slower than expected, if it is heading in a direction that does not match the predictions, that would be evidence of propulsion, evidence of maneuvering. That is what you are waiting for. 4 key data points that could shift this story from interesting comet with unusual properties to potentially artificial object requiring immediate further investigation. And if the trajectory shows evidence of propulsion, then what? Then the entire scientific community mobilizes. Every major telescope gets redirected. Space agencies start planning missions. Governments get involved, because at that point you are not just observing a curiosity. You are observing evidence of extraterrestrial technology, and the questions multiply. Where is it going? What is it doing? Can we communicate with it? Should we try? What protocols do we have for this kind of situation? The answer to that last one, by the way, is not many. There are some frameworks, some guidelines developed by SETI researchers and space policy experts, but they are not comprehensive. They are not legally binding, and they certainly were not designed for a scenario like this, where the evidence is ambiguous and the object is already leaving. You would be making it up as you go, which is both terrifying and exciting, but let us not get ahead of ourselves. Right now, the most likely explanation is still that 3I Atlas is a natural object with some unusual but ultimately explainable properties. Occam's razor still applies. even if the razor is getting a bit dull from all the anomalies you are trying to shave off. The scientific consensus, if you can call it that, is cautious optimism. Optimism that you are studying something truly unique and scientifically valuable. Caution about jumping to extraordinary conclusions without extraordinary proof. Avi Loeb is an outlier in this regard. He is willing to publicly entertain the artificial object hypothesis in a way that many of his colleagues are not, and he has been criticized for it, accused of seeking publicity, of being too quick to invoke aliens, of damaging his scientific credibility. But here is the thing. Someone has to be willing to ask the uncomfortable questions. Someone has to be willing to look at the data and say, this doesn't fit our models. And maybe that is because our models are incomplete. Someone has to push the boundaries. And if Loeb is wrong, if 3I Atlas turns out to be entirely natural, well, you will have learned something anyway. You will have better data, better models, better understanding of cometary behavior. Science progresses through questions, not just answers. But if he is right, if there is even a kernel of truth to the artificial object hypothesis, then Avi Loeb will go down in history as the person who first seriously proposed that we detected alien technology, and the rest of us will be scrambling to catch up. There is one more thing I want to touch on before we wrap this up. The emotional dimension. How should you feel about 3I Atlas? If it is a comet, you should feel wonder. This is a 7-billion-year-old relic from the early universe, carrying chemical signatures from a star system that might not even exist anymore. It is a message in a bottle from the distant past, delivered to our doorstep by the currents of the galaxy. That is extraordinary. If it is artificial, then wonder is not enough. You would need a new emotion entirely. A mix of awe, humility, excitement, and maybe a little fear, because it would mean you are not alone. It would mean that intelligence arises elsewhere in the universe, and that it can create things that endure for billions of years. It would mean that somewhere out there, or someone out there, another species looked up at the stars and decided to reach out, to send something, to make their presence known, even if only as a fading echo in the vast darkness. And you would be hearing that echo now, across billions of years and light years of space. You would be connected to them not through conversation, not through understanding, but through the simple fact that you both exist, that you both wondered, that you both tried. That is what 3I Atlas might represent, and whether it is a comet or a craft, that is worth paying attention to. So here is where we are. In 4 days, 3I Atlas reaches perihelion and disappears behind the sun. For 2 weeks you wait, and then in early November it reappears. You measure, you analyze, you compare, and you find out if you are living through one of the most significant moments in human history, or if you are just observing another fascinating chapter in the story of comets. Either way, you will know soon enough. Until then, somewhere between Mars and the Sun, a Manhattan-sized object from another star system is putting on a show, growing a tail, racing toward its closest approach to our star, potentially maneuvering, potentially just being a comet. The telescopes are watching, the data is accumulating, the questions are multiplying, and the universe, as always, keeps its secrets just a little. Something just happened behind the sun where you could not see. On the 29th of October, 2025, at 7 hours and 47 minutes in the morning, Eastern Time, the interstellar comet 3I Atlas reached perihelion, its closest approach to our star, 203 million kilometers from the sun's surface. For the first time in 10 billion years, this object felt the warmth of another star system's furnace, and then it went silent. For 8 days, 3 Atlas was hidden from Earth's view, positioned directly behind the sun. Our most powerful telescopes, blind, ground-based observatories, useless. The Manhattan-sized visitor from beyond our solar system performed its maneuver in complete privacy. But here is what makes your spine tingle. During those final hours before disappearing behind the sun, something changed. The comet began brightening rapidly, its glow intensifying at a rate that far exceeds any natural comet you have ever observed. And its color, it turned bluer than the sun itself. Let that detail sink in for a moment. This object's surface should be freezing hundreds of degrees colder than our star. Yet somehow, impossibly, it is emitting light with a color temperature hotter than the photosphere of the sun. Today, on the 30th of October, the Punch satellite constellation captured the first images of 3I Atlas emerging from behind the solar glare. And according to NASA's automatic tracking systems, the comet maintained its expected trajectory. No deviation, no sudden course correction, no Oberth maneuver using the sun's gravity to redirect toward Earth. At least that is what the public data shows. But there are gaps, significant gaps. NASA allegedly has high-resolution images from the Mars Reconnaissance Orbiter taken when 3I Atlas passed within 30 million kilometers of the red planet on the 2nd of October. Harvard astrophysicist Avi Loeb requested those images. The response: silence. China's Purple Mountain Observatory, which tracked the object intensively through August and early September, stopped publishing data immediately after the Mars flyby. Their official reason: scheduling conflicts with lunar missions. The timing is curious, is it not? This is not speculation designed to fuel paranoia. This is about missing pieces in a puzzle that already does not fit. Because even without those hidden images, what you can see defies comfortable explanation. Let me walk you through what happened during perihelion, what changed, what did not change, and what still makes absolutely no sense. But first, you need to understand where this thing came from, and I am not talking about another star system. I am talking about something much stranger. The data suggests 3I Atlas is 10 billion years old. Our entire solar system is only 4.5 billion years old. This object existed before our sun ignited, before Earth formed, before anything you see in our cosmic neighborhood came into being. It is not just visiting from another star. It is visiting from another era of the universe. Think about that timeline. When 3 Atlas formed, the universe was less than half its current age. The first generation of massive stars had lived and died. The galaxy was still being shaped by violent mergers and collisions. And somewhere in that ancient cosmos, this object took shape. What kind of conditions create a comet that survives for 10 billion years? How does something remain intact through that much time, through gravitational encounters with countless stars, through the radiation of multiple stellar environments, through the vast emptiness of interstellar space? The answer should be, it does not. Natural comets are fragile. They are dirty snowballs held together by weak forces. Time destroys them. Radiation erodes them. Gravitational perturbations tear them apart. Yet here is 3I Atlas, ancient beyond measure, intact, functional and actively venting gas as if it were freshly formed. Now let us talk about what makes this object truly bizarre. Not the speculation, not the theories, just the raw, peer-reviewed, published scientific data, the facts that professional astronomers cannot explain away with comfortable answers. Anomaly 1, its trajectory. 3 Atlas is not just passing through our solar system at a random angle. Its path aligns with the ecliptic plane, the flat disk where all our planets orbit, to within 5 degrees. The statistical probability of this happening by chance, 0.2%, 1 in 500. But it gets weirder. Its arrival time was perfectly calibrated to bring it within tens of millions of kilometers of Mars, Venus, and Jupiter, and to position it directly behind the Sun, invisible from Earth during perihelion. The probability of all those alignments occurring naturally, 5 in 100,000. You could argue coincidence. The universe is vast. Strange things happen, fair enough. Let us keep going. Anomaly 2, the sunward jet. Between July and August, multiple observatories, including the Hubble Space Telescope, documented something unprecedented. 3 Atlas was venting material directly toward the Sun, not away from it like every normal comet, toward it. Comets develop tails because solar radiation pressure pushes gas and dust away from the Sun. It is fundamental physics. The tail always points away from the heat source, except when it does not. This was not an optical illusion caused by viewing angle. Multiple telescopes from different positions confirmed it. The sunward jet, what astronomers call an anti-tail, persisted for weeks. Then sometime in October it disappeared. The comet's plume shifted direction. Now it behaves normally, venting away from the Sun like it is supposed to. What kind of mechanism allows a comet to reverse the fundamental direction of its gas emission? What changed? Anomaly 3, the composition. When astronomers analyzed the spectral signature of 3 Atlas's gas cloud, they found nickel. Lots of nickel. 4 grams per second, continuously venting into space. TH. That is not unusual by itself. Some comets contain metal compounds, but here is the problem. There is almost no iron. The nickel-to-iron ratio is completely wrong. In natural cosmic objects, iron dominates. Nickel appears as a trace element. The ratio found in 3 Atlas's plume matches industrial nickel alloys, human-made materials, not natural stellar chemistry. The probability of this ratio occurring naturally, less than 1%. And the nickel-to-cyanide ratio, orders of magnitude higher than any known comet, including Borisov, the other confirmed interstellar comet. The likelihood of that also less than 1%. Anomaly 4, water content. Normal comets are ice balls. Water dominates their composition, typically 70 to 80% by mass. 3I Atlas 4% water, 4%. It is venting water vapor. Yes, that is how we detected its activity. But the actual water content is absurdly low compared to every comet you have studied. What kind of comet barely contains water? Anomaly 5. Extreme negative polarization. When light bounces off 3I Atlas, it exhibits a polarization signature never seen before in any comet, including Borisov. The measurement is so far outside the normal range that the statistical likelihood is once again less than 1%. Anomaly 6. The WOW signal connection. In 1977, the Big Ear radio telescope detected a powerful narrowband radio signal from space. It lasted 72 seconds. The signal was so strong, so clearly artificial-looking that astronomer Jerry Amon wrote, "Wow," in the margins of the data printout. No one ever found the source. But here is the thing. 3 Atlas arrived from a direction in the sky that aligns with the WOW signal's origin point to within 9 degrees. The probability of that, 0.6%. Could be coincidence, another dice roll in an infinite universe, or maybe not. When you multiply all these individual probabilities together, the trajectory alignment, the arrival timing, the sunward jet, the nickel ratio, the water content, the polarization, the WOW signal direction, you get a cumulative likelihood of less than 1 part in 10 quadrillion. 1 in 10 quadrillion. For context, the odds of winning the Powerball lottery are 1 in 292 million. You would have to win the Powerball jackpot 34 million times in a row to match these odds. So either 3 Atlas is the luckiest coincidence in astronomical history, or something else is happening. Now, let us be clear. Extraordinary claims require extraordinary evidence. The scientific method demands skepticism. And the vast majority of astronomers believe 3I Atlas is a natural object, a comet formed in another star system, ejected into interstellar space, now passing through our cosmic neighborhood by chance. That is probably correct. Nature is creative. The universe contains phenomena you have not imagined. Absence of precedent does not equal impossibility, but ignoring anomalies does not make them disappear. What happened during perihelion made those anomalies more pronounced, not less. Let me show you what I mean. Space-based solar observatories captured something extraordinary. During 3 Atlas's final approach to the Sun, multiple instruments operating independently recorded the same phenomenon. The comet brightened at an exponential rate, not the gradual brightening you would expect from increased solar heating, not the steady ramp-up of sublimation as volatile ices warm and vaporize. This was different, aggressive, unprecedented. The brightness increased inversely with distance to the power of 7.5. Let me translate that into plain language. As 3I Atlas got closer to the Sun, it did not just get brighter linearly. The relationship was exponential, far steeper than any Oort cloud comet at similar distances. And remember, Oort cloud comets are fresh. They have spent billions of years in the deep freeze at the edge of our solar system. When they fall sunward for the first time, they contain pristine volatiles, maximum ice content. They should outgas dramatically. 3I Atlas has 4% water content. It is ancient, depleted. It should not be capable of dramatic outbursting, yet there it was, blazing brighter with each passing hour. Stereo A, a solar observation spacecraft, captured images with 2 different instruments. The HI-1 heliospheric imager and the Core 2 coronagraph both showed the comet developing an extended halo. The glow stretched 300,000 kilometers outward from the nucleus. 300,000 kilometers. That is almost the distance from Earth to the Moon. That is not a typical cometary coma. That is something else entirely. The SOHO spacecraft orbiting the Sun-Earth L1 Lagrange point confirmed the observation with its LASCO coronagraph. Independent verification, multiple instruments, same result. And then there was GOES-19, the newest weather satellite equipped with the CCOR-1 compact coronagraph. It resolved details the others missed. The structure of that 300,000-kilometer halo was not uniform. It showed layering, complexity, organization. But here is where things get truly strange. The color. When astronomers analyzed the spectral data from LASCO and CCOR-1, they found something that should not be possible. The light coming from 3I Atlas was bluer than the Sun. Pause on that, think about what it means. When sunlight reflects off a comet, it should be the same color as the sun, maybe slightly reddened by dust. When a comet heats up and glows from thermal emission, it should be red or infrared, cooler than the sun, not hotter. The surface temperature of 3 Atlas, even at perihelion, should be hundreds of degrees Kelvin colder than the sun's photosphere. The sun's surface temperature is 5,800 Kelvin. That is what produces its yellowish-white color. For 3 Atlas to appear bluer than the sun, its emission source would need to be hotter, significantly hotter. You are talking about temperatures that do not occur on natural comet surfaces. So where is the blue light coming from? The research paper published on the 28th of October by Zhang and Datani states, quote, "The reason for 3 Atlas's rapid brightening, which far exceeds the brightening rate of most Oort cloud comets at similar distances from the sun, remains unclear." And regarding the blue color, they note it suggests emission contributes a substantial fraction of the overall visible brightness. Emission, not reflection. Something on or inside 3 Atlas is generating light at high temperatures. What kind of natural process does that? What kind of comet contains an internal heat source hot enough to emit blue light? The authors do not offer an explanation because there is not a comfortable one. Now you might be thinking, could this not be fluorescent gas molecules excited by solar ultraviolet radiation, then ray-emitting light at shorter wavelengths? Possible. Some cometary gases do fluoresce. Cyanide compounds, for example, can produce blue-green emission, but the scale is wrong. Fluorescence produces faint glows, not brightness that dominates the overall spectrum, and the observed blue shift was too pronounced for fluorescence alone to explain. You could argue for reflected light from an unusually bright, pristine, icy surface, but again, the scale does not work. And 3I Atlas is ancient. Its surface should be weathered, darkened by cosmic ray exposure over billions of years, not mirror bright. The data does not fit the models. And when data does not fit models, you have 3 options. 1. The data is wrong. 2. The model is wrong. 3. Something genuinely unexpected is happening. Let us assume the data is correct. Multiple independent instruments, different teams, same results. Hard to dismiss as measurement error. So either our understanding of cometary physics is fundamentally incomplete, or 3I Atlas is doing something comets are not supposed to do, like operating an internal power source. I'm not saying it is. I am saying the observations would be consistent with that hypothesis. An engine generating heat, technology maintaining functionality over 10 billion years of operation. A craft designed to use solar flybys for energy replenishment. Pure speculation? Absolutely. But let us follow the thought experiment. If you were sending a probe on an interstellar journey lasting billions of years, how would you design it? You would need extreme durability, redundant systems, and periodic energy replenishment, because even the most efficient power source degrades over geological timescales. Stars are convenient refueling stations, predictable, powerful. A close approach to a stellar photosphere dumps massive amounts of energy into any absorbing surface. If 3I Atlas were technological, a perihelion pass would be the perfect opportunity to recharge, absorb solar radiation, convert it to usable power, maybe even use the gravitational well for a trajectory adjustment if needed. But that is not what happened. According to NASA's automatic tracking data, 3I Atlas maintained its expected trajectory. No maneuver, no course correction. It came in, looped around, and continued outbound exactly where gravity predicted. So if it is a probe, it is not interested in Earth. It is not altering course to investigate our planet. It is following its programmed route, passing through the solar system, gathering data perhaps, then continuing its eternal voyage through the galaxy. Or much more likely, it is just a really weird comet. But that blue light though, that keeps nagging at me. And there is another detail that does not fit comfortably into the natural comet narrative. The timing of when things changed. Remember the sunward jet, the anti-tail that persisted for weeks during July and August, violating Basie. See cometary physics. That jet disappeared sometime in October, right around the time 3 Atlas passed Mars, right before it went behind the sun. When it re-emerged on the 30th of October, the plume had normalized. Now it behaves like a standard comet tail, pointing away from the sun. The anomaly corrected itself, or was corrected. Here is where you run into the information blackout. China's tracking data stopped after the Mars flyby. NASA has not released the high-rise images from Mars Reconnaissance Orbiter. The object was hidden behind the sun during its most critical phase. What you have is before and after. Before perihelion, anomalous behavior, sunward jet, strange composition. After perihelion, normalized tail, continued outgassing, maintained trajectory. What happened in between? According to Congresswoman Anna Paulina Luna, she is working to get those high-rise images released. Avi Loeb has been vocal about the need for transparency. Radio observatories are now monitoring 3 Atlas for any electromagnetic emissions following Loeb's request to search for artificial signals. So far, nothing. No radio transmissions, no obvious signs of technology. Just a comet doing comet things, albeit in ways we have never quite seen before. The JUICE spacecraft, currently en route to Jupiter, will observe 3 Atlas on the 2nd of November and again on the 25th of November. It is equipped with 5 instruments: a camera, a near-infrared imager, a UV spectrometer, a sub-millimeter instrument, and a sensor for detecting neutral atoms. JUICE is half an astronomical unit away from the comet. That is 75 million kilometers. Too far for close-up imaging, but close enough for spectroscopy and compositional analysis. The data will not be downloaded until February of 2026 because JUICE's position relative to Earth results in extremely slow data transmission rates. So you wait again, more gaps in the story. What we do know is that 3I Atlas survived perihelion intact. Some astronomers predicted it might fragment. Comets are fragile. The thermal stress of a close solar pass can tear them apart, especially if they are loosely bound rubble piles. 3 Atlas did not break. Despite being heated to 770 watts per square meter at perihelion, despite the enormous gravitational forces near the Sun, despite being 10 billion years old and presumably weakened by eons of cosmic weathering, it held together. That tells us something about its internal structure. It is not a loosely bound rubble pile. It has structural integrity, strength, cohesion. You could argue this is evidence of natural formation processes. Some comets are indeed monolithic, formed as single frozen bodies rather than accreted from smaller pieces. Perfectly normal. Or you could note that 10 billion years is a hell of a long time for any natural structure to remain coherent. Micrometeorite bombardment alone should have eroded and fractured the surface over that timescale. Cosmic ray damage should have weakened the internal structure. Yet here it is, intact, functional, venting gas like a fresh comet despite having 4% water content. Let me give you another piece of the puzzle, one that Avi Loeb discussed on the Joe Rogan podcast. The nickel emission, 4 grams per second, continuously for months. Do the math. From discovery in July to perihelion in late October, that is roughly 4 months. 120 days, 10 million seconds. 4 grams per second times 10 million seconds equals 40 million grams. 40,000 kilograms, 40 metric tons of nickel vented into space from an object that is 5 kilometers in diameter with a total mass of 30 billion kilograms. 40 tons of nickel is roughly 1/1,000,000th of its total mass. Does not sound like much, but remember this is pure nickel, not nickel-bearing minerals, not trace amounts embedded in rock. This is gaseous nickel, ionized, free in the plume. Where is it coming from? How is it being liberated from the surface or interior? Normal sublimation does not work. Nickel has a boiling point of almost 3,000 degrees Celsius. The surface of 3I Atlas, even at perihelion, does not reach temperatures high enough to vaporize metallic nickel. You need energy input, lots of it, either from an internal source or from some exotic surface chemistry you do not understand. And again, that nickel to iron ratio, it is cosmically wrong. The universe makes iron and nickel together in specific proportions through stellar nucleosynthesis. Finding nickel without corresponding iron is like finding smoke without fire, unless the nickel is not coming from natural ore, unless it is coming from manufactured components, alloys, structural materials designed for specific properties. I know how this sounds. I do. You are pattern matching, seeing design where randomness might exist. It is a cognitive bias humans cannot escape. You are wired to see intention behind unusual events, but sometimes unusual events do have intention behind them. The challenge is distinguishing between the two, and right now with missing data, hidden observations, and gaps in the timeline, you are operating with incomplete information. Which brings me to the elephant in the room that I have been dancing around. What if it is artificial? What would that mean? Let us think about scale for a moment. Our most ambitious spacecraft, SpaceX's Starship, stands 120 meters tall. It can carry 100 tons to low Earth orbit. It is the pinnacle of human rocket engineering. 3I Atlas is 5,000 meters across, maybe larger. Its mass is 30 billion kilograms. That is 300 million times heavier than Starship's payload capacity. If 3I Atlas were technological, its builders would have mastered capabilities so far beyond our current level that comparison becomes meaningless. You are talking about a civilization that can construct objects the size of mountains, accelerate them to interstellar velocities, and keep them operational for 10 billion years. 10 billion years. Human civilization is roughly 10,000 years old. Recorded history spans maybe 5,000 years. Our entire species, Homo sapiens, has existed for only 300,000 years. 10 billion years ago, Earth did not exist. The Sun did not exist. The molecular cloud that would eventually collapse to form our solar system had not even begun to condense. Any civilization capable of building 3I Atlas would have emerged in a younger, stranger universe. They would have witnessed cosmic evolution on scales we can barely imagine. They would have solved problems we have not conceived of yet, and if they sent probes, why would not those probes be designed to last, to observe, to gather data across geological timescales? Avi Loeb makes a compelling point. The discovery of technological artifacts from other civilizations would be the most profound revelation in human history. It would answer the fundamental question, are we alone? The implications extend beyond philosophy. If interstellar probes exist, if they are common enough that one passes through our solar system every few decades, then the galaxy might be filled with them. Ancient observers quietly mapping the cosmos, reporting back to civilizations that may no longer exist or still do. Think about that possibility. Right now, as you process these words, there might be billions of probes scattered throughout the Milky Way, silent witnesses to stellar birth and death, to planet formation, to the emergence of life. Some of them might be watching us, but let us pull back from speculation and return to what we know, what we can measure, what we can test. The International Asteroid Warning Network has initiated a formal campaign to monitor 3 Atlas. Starting the 27th of November and continuing through the 27th of January 2026, multiple observatories will coordinate observations. Campaign will include workshops on astrometry, the precise measurement of celestial positions and motions. Why? Because tracking potentially hazardous objects requires accuracy, and 3 Atlas, while not hazardous to Earth, serves as a perfect test case. It is large, it is bright enough to observe, and its interstellar trajectory provides unique challenges for tracking algorithms. But there is another reason, an unstated one. If 3I Atlas were to maneuver, even slightly, you would detect it. Any deviation from its gravitational trajectory would be immediately obvious to the coordinated network of observatories. So far, nothing. The object continues on its predicted path. Pure ballistic motion, no thrust, no course corrections, just gravity doing its thing. That is evidence against the artificial hypothesis, a strong data point. Probes maneuver, they adjust, they react to their environment. 3 Atlas is not doing any of that, or perhaps it already did. Perhaps the trajectory you are observing is the result of a maneuver performed centuries or millennia ago. Once you are on the right path through interstellar space, why waste energy on further corrections? Coast, observe, record. The upcoming observations in December will be critical. On the 19th of December, 3I Atlas reaches its closest approach to Earth, 269 million kilometers. That is almost twice the distance from Earth to the Sun, but it is the closest you will get. Ground-based telescopes will have optimal viewing conditions. The Hubble Space Telescope will observe it. The James Webb Space Telescope will observe it. Every major observatory on the planet will point their instruments at this object. They will analyze its spectrum in unprecedented detail, map its surface features, measure its rotation, look for any signs of internal structure, search for heat signatures that do not match solar heating patterns. And they why? Listen, radio telescopes around the world will monitor 3I Atlas for electromagnetic emissions. Any signal, any pattern, any deviation from random noise. If it is a probe, December might reveal it. If it is transmitting data back to its origin point, you might intercept that transmission. If it is using active sensors to scan Earth, you might detect the radar or LiDAR pulses. But here is the uncomfortable possibility. What if it is designed not to be detected? What if it has been engineered to masquerade as a natural object? Passive observation, minimal emissions, camouflage indistinguishable from a real comet. How would you even test for that? How do you prove the absence of artificiality when the artificial could be designed to mimic the natural perfectly? You cannot, not definitively. You can only accumulate evidence, look for inconsistencies, find the places where the disguise fails. And 3i Atlas has inconsistencies, 9 of them. Now if you add the blue light emission to the list, 9 anomalies that do not fit comfortable explanations. But 9 anomalies do not equal proof, they equal mystery, and mysteries can have mundane solutions. Let me offer a natural explanation that accommodates most of the observations. Suppose 3 Atlas is not a typical comet. Suppose it is something rarer, a fragment of a disrupted planet. A shard of a world torn apart by tidal forces during a close stellar encounter billions of years ago. Planetary fragments would have different compositions than comets. They would contain metals, core material, nickel-iron alloys from the planet's interior. If 3i Atlas was such a fragment, the nickel emission makes sense. It is venting material from deep inside, exposed when the parent body shattered. The low water content explained. Planetary interiors are dry compared to comets. The structural integrity explained. Solid rock and metal, not fluffy ice. The age explained. Planets form early. Fragments could be 10 billion years old. What about the blue light? If the fragment contains radioactive isotopes, internal heat from radioactive decay could drive chemical reactions on the surface. Exotic chemistry producing emission lines you do not typically see in comets. The sunward jet may be related to localized venting from specific surface features. Geysers triggered by internal pressure, aimed in directions determined by the fragment's rotation and structural weaknesses. See, you can construct a natural narrative. It requires a specific set of circumstances, sure, but those circumstances are not impossible. Unlikely, perhaps, but not impossible. The question becomes which is more likely, a rare natural object with multiple unusual properties or artificial technology from an extinct civilization. Most scientists would say the natural explanation, however unlikely, is still more probable than the artificial one because you have 0 confirmed examples of alien technology. But you have billions of examples of natural objects doing strange things. The prior probability matters. Extraordinary claims require extraordinary evidence. And right now the evidence is circumstantial, suggestive, intriguing, but not definitive. So where does that leave you? You watch, you wait, you gather more data, and you prepare for both possibilities. If 3i Atlas is natural, understanding it will revolutionize our knowledge of planetary formation, stellar system dynamics, and interstellar object composition. It is a messenger from the ancient universe, carrying information about conditions and processes that no longer exist in our modern cosmos. If 3i Atlas is artificial, well, everything changes. The Fermi paradox shifts from philosophical puzzle to solved mystery. You are not alone, you never were. The galaxy is populated, or was populated, by civilizations capable of reaching across the stars. And if they could do it, eventually so can we. But here is what troubles me most about the artificial hypothesis. If 3 Atlas is a probe, it is not interested in us. It passed Mars within 30 million kilometers. That is close. Close enough to image the surface at high resolution. Close enough to detect our rovers, our satellites, our infrastructure. If it wanted to investigate Earth, it could have. A small trajectory adjustment during the Mars flyby would have brought it much closer to our planet. Instead, it maintained course. It prioritized perihelion over Earth examination. What kind of probe does that? What would be more interesting to an alien intelligence than a planet with a technological civilization? Unless it already knew we were here, unless it had scanned us from a distance and determined we were not worth a closer look. Or perhaps we were not its mission priority. Perhaps it was surveying the sun, not the planets, gathering stellar data, not biological data. Or maybe, just maybe, it did investigate us. Maybe it deployed smaller probes during the Mars flyby, Subcraft 2SM. All to detect. Miniature observers now in orbit around Earth, watching, recording, waiting. Pure speculation, science fiction territory, but the universe has proven itself stranger than fiction repeatedly. Black holes exist. Neutron stars exist. Galaxies collide and merge. Reality keeps surprising us with phenomena we could not have predicted. So why not this? Why not ancient probes traversing the galaxy? The answer might be coming. December will tell us more. February of 2026, when JUICE's data downloads will tell us even more. And the observations between now and then might reveal something unexpected or confirm that 3i Atlas is exactly what it appears to be. A very old, very strange comet with properties you do not fully understand yet. But either way, you have learned something profound. The universe delivers mysteries to our doorstep. Objects from beyond our solar system, carrying signatures of alien environments, reminding us that the cosmos is vast and our understanding incomplete. Whether 3I Atlas is natural or artificial, it is teaching us, forcing us to question assumptions, pushing the boundaries of what we think is possible. And maybe that is the real value, not the answer but the question, not the certainty but the wonder, because that is what drives science forward. That is what propels humanity to explore. The possibility that something extraordinary might be real, that the universe might be stranger, more populated, more alive than we dared imagine. So you point our telescopes, you collect photons from objects 10 billion years old, you analyze spectra, you measure velocities, you build models and test hypotheses, and sometimes, just sometimes, the data refuses to fit our comfortable boxes. That is when things get interesting. Right now, as of the 31st of October, 2025, 3I Atlas is moving away from the Sun at 210,000 kilometers per hour. Every hour, it travels farther from the warmth that briefly illuminated it. Every day, it gets colder, darker, more distant. It is currently within the orbit of Mars, but that will not last long. By mid-November, it will cross Mars' orbital path and continue outward. By December, it will be approaching the asteroid belt's outer edge. By the end of 2026, it will pass Jupiter's orbit and begin the long journey back to interstellar space, and you will be watching every moment of that departure. The viewing conditions are improving for Earth-based observers. During perihelion, 3I Atlas was lost in the Sun's glare, observable only by specialized space-based coronagraphs. Now, as the angular separation between the comet and the Sun increases, conventional telescopes can see it. Starting this weekend, amateur astronomers with decent equipment will be able to spot 3I Atlas in the pre-dawn sky. It will appear near Venus, rising before the Sun, not bright enough to see with naked eyes, but visible through telescopes. A fuzzy patch of light, a visitor from another star system close enough to photograph from your backyard. That is remarkable when you think about it. How many people throughout human history have looked at the stars and wondered what lies beyond? How many civilizations dreamed of touching something from another world? And now you can point a telescope at 3I Atlas and observe directly an object that formed in another stellar system. You are collecting photons that bounced off material created under alien conditions. You are witnessing in real time a fragment of a different cosmic environment. Professional observatories are coordinating their efforts. The European Southern Observatory, with its array of telescopes in Chile, will track 3 Atlas throughout November and December. The Keck Observatory in Hawaii will observe it. The Very Large Telescope will observe it. Subaru, Gemini, Magellan, every major facility will contribute data. They are looking for specific signatures, changes in brightness that might indicate outgassing events, variations in the spectrum that could reveal compositional differences across the surface, polarization patterns that might tell us about particle sizes in the coma. And they are looking for anything unusual, any deviation from expected behavior, any sign that 3 Atlas is more than it appears. The Hubble Space Telescope has already observed 3I Atlas multiple times. Back in July, Hubble captured the famous image showing the sunward jet. That single photograph revealed the anti-tail that sparked so much scientific debate. In December, Hubble will observe again. Multiple sessions, multiple filters, maximum resolution. The images will show surface features if any exist. They will map the dust distribution. They will measure the rotation period with precision. And crucially, they will look for changes. Compare the December images to the July images. Has the surface altered? Have new vents opened? Has the activity pattern shifted? The James Webb Space Telescope will join the observation campaign. Webb operates in infrared, detecting heat rather than visible light. That is perfect for studying comets. Infrared reveals temperatures, compositional details, subsurface structure. Webb will map the temperature distribution across 3I Atlas's surface. It will identify hot spots, cold spots, regions that are emitting more heat than solar radiation alone can explain. If there is an internal heat source, Webb will find it. The Spherex Space Observatory already detected the carbon dioxide plume back in August. That observation showed the gas cloud extending outward, measuring its composition and velocity. In December, SphereX will observe again, looking for changes in the plume's characteristics. Has the carbon dioxide production increased or decreased? Has the nickel emission continued? What about water vapor? Is it still present at 4% or has the concentration changed? These are not trivial questions. They tell us about the object's interior. How deep do the volatiles extend? What is driving the outgassing? Is it purely solar heating or is something else contributing? Radio observatories are listening. The Very Large Array in New Mexico, the Arecibo replacement facilities, the Square Kilometer Array, even SETI Institute instruments are pointing at 3 Atlas. They are scanning across the electromagnetic spectrum, looking for narrow-band signals, broadband transmissions, repetitive patterns, anything that does not match natural emission. Avi Loeb specifically requested this after noting the WOW signal connection. He argued that ruling out artificial signals is essential. If 3I Atlas is transmitting even weakly, we should be able to detect it at its current distance. So far, silence. Just the natural radio emission you would expect from a comet's interaction with the solar wind. No coherent signals, no patterns, no obvious technology, but absence of detection does not equal absence of signal. Maybe it is transmitting on frequencies you are not monitoring. Maybe it is using directional beams aimed away from Earth. Maybe it is not transmitting at all, operating in receive-only mode, passively collecting data. Or maybe it is just a comet and there is nothing to detect. The Chinese space program, despite going silent after the Mars flyby, has resources in position. The Chang'e 7 lunar mission is preparing for launch, but China's deep space network remains active. Their radio dishes can observe 3I Atlas if they choose to. Whether they are sharing that data is another question. This brings up an uncomfortable truth about modern astronomy. It is increasingly politicized. Nations compete for discovery priority. Data becomes strategic. Transparency suffers when national interests are at stake. If China did detect something unusual during their September observations, would they release it publicly, or would they classify it, analyze it internally, and only release information after securing whatever advantage it provides? Same question applies to the United States. Those Mars Reconnaissance Orbiter images, why have they not been released? Is it really just bureaucratic delay, or is there a reason NASA wants to review them privately first? Congresswoman Luna's involvement suggests political pressure is mounting. Scientists want the data. The public wants the data, but institutions move slowly, especially when the implications might be significant. And make no mistake, the implications are significant. If those high-rise images show anything anomalous, surface features that look artificial, geometric patterns, structures inconsistent with natural formation, the revelation would be historic, but it would also be destabilizing. How do you tell the world that an alien probe passed through the solar system? How do you manage the reaction, the questions, the fear and excitement and confusion? Maybe you do not release it all at once. Maybe you prepare the narrative. Maybe you wait until you have enough data to provide context, explanation, reassurance. Or maybe the images show nothing unusual and the delay is exactly what NASA said. Scheduling conflicts, data processing backlogs, normal bureaucratic friction. You will find out eventually. Data has a way of leaking. Someone on one of those teams will talk. An astronomer will share images at a conference. A researcher will post preliminary findings online. The truth, whatever it is, will emerge. While you wait for that truth, the observations continue. Every telescope, every instrument, every wavelength, building the most comprehensive data set ever collected for an interstellar object. By the time 3 Atlas leaves the inner solar system, you will know more about it than we know about most comets that formed in our own neighborhood. You will have spectroscopy, photometry, polarimetry, radio data, thermal imaging, optical imaging, and compositional analysis. And from all that data, patterns will emerge, answers will crystallize, the anomalies will either resolve into natural explanations or persist as genuine mysteries. The 19th of December is the keystone date, closest approach to Earth, optimal viewing geometry, maximum instrument time allocated. If something is going to be revealed, that is when it happens. Imagine the scenario. The 20th of December, news breaks. Webb telescope detected anomalous heat signatures, or Hubble imaged geometric surface features, or radio telescopes picked up a signal. The headlines write themselves, the world stops. Confirmation that you are not alone, that intelligence exists beyond Earth, that the universe is populated. Or imagine the alternative. The 20th of December, news breaks. all observations consistent with natural comet, anomalies explained by unusual but non-artificial processes. 3i Atlas is interesting, ancient, valuable for science, but not technological. The world shrugs, moves on, forgets about the interstellar visitor that almost was. Which outcome would you prefer? Which outcome do you expect? I will be honest, I do not know what I hope for. The romantic part of me wants 3i Atlas to be artificial, wants confirmation that we are part of a cosmic community, wants to know that intelligence is common, that the universe is alive with civilizations building and exploring and reaching across the stars. But the rational part of me recognizes the complications. Contact, even passive contact through discovering an artifact, changes everything. Our place in the universe shifts, our priorities reorganize, questions about meaning and purpose and future acquire new dimensions. And there is fear too. If they are out there, why have they not made contact? Where is everyone? If probes are common, if 3i Atlas is just one of many, why the silence? Maybe you are being observed, studied, catalogued, filed away in some vast database of emerging civilizations, waiting to see if we survive long enough to matter. Or maybe 3 Atlas is a relic, a ghost ship from a civilization that died billions of years ago, alone now, eternal, witnessing the universe on autopilot, reporting to masters that no longer exist. That is almost sadder than being alone. Knowing they existed, knowing they built wonders, knowing they are gone now, and all that remains are their probes wandering the galaxy forever. But these are emotional reactions, not scientific analysis. What matters is the data, the observations, the measurements, and those are coming week by week, instrument by instrument. You are collecting the evidence that will answer the question, so I will make a prediction. By February of 2026, when JUICE's data downloads complete, when the December observations are fully analyzed, when all the instruments have reported their findings, you will have a consensus, not proof, not certainty, but a scientific consensus about what 3i most likely is. My guess, it is natural. A weird, ancient, compositionally unusual fragment of a disrupted planetary system ejected into interstellar space billions of years ago, now passing through our solar system by chance. But I could be wrong. The universe has surprised us before. And would it not be something if this time the surprise was intelligence? Let us zoom out for a moment, away from 3 Atlas, away from the specific measurements and anomalies. Let us look at the bigger context. You have now detected 3 confirmed interstellar objects passing through our solar system. Oumuamua in 2017, Borisov in 2019, Atlas in 2025, 3 objects in 8 years. Statistical models suggest these detections represent a tiny fraction of the actual population. For every interstellar object you spot, hundreds or thousands pass through unnoticed. Too small, too dark, wrong trajectory, bad timing. The galaxy might be thick with interstellar debris, fragments of disrupted planetary systems, ejected comets, wandering asteroids, materials scattered across the spiral arms, drifting between stars, occasionally falling into a solar system's gravity well. You are only now developing the technology to see them. Better telescopes, automated survey systems, sophisticated tracking algorithms. As our detection capabilities improve, you will find more. And every one of them will be a time capsule, a sample of another star's environment, a piece of stellar history delivered to our doorstep. But here is the interesting thing. Oumuamua was strange. Anomalous acceleration, cigar-shaped or pancake-shaped, depending on interpretation. Bright surface inconsistent with typical asteroidal composition. Borisov was normal, a textbook comet. Water ice, carbon compounds, typical outgassing, predictable behavior. Exactly what we expected an interstellar comet to look like. And now, Atlas, strange again, multiple anomalies, behaviors that do not fit comfortable models. 2 out of 3 interstellar. Our visitors have been weird. That is either bad luck in our sampling or weirdness is more common than you assumed. If weirdness is common, why? What makes interstellar objects different from solar system objects? Is it the environments they formed in, the processes that ejected them, the effects of traveling through interstellar space for billions of years? Or is it something else? Could some fraction of interstellar objects be artificial? Not all of them, not even most of them, but some. If civilizations arise commonly throughout the galaxy, and if those civilizations build probes to explore their stellar neighborhood, then over billions of years, the cumulative number of probes would be enormous. Think about it. One civilization sends out 10,000 probes. Those probes travel for millions of years, mapping nearby stars. That civilization dies out, but the probes continue. Another civilization arises, sends out their probes. They die out too, probes keep going. Over galactic history, millions of civilizations could have existed and vanished, each one potentially contributing probes to the interstellar environment. By now, ancient probes might outnumber natural interstellar objects in some regions. This is the hypothesis Avi Loeb keeps returning to, not because he is committed to it being true, but because it is testable. You can look for signatures. You can analyze anomalies. You can accumulate evidence that either supports or contradicts the possibility. And if even one interstellar object turns out to be artificial, everything changes. The Fermi paradox collapses. The Great Filter becomes less terrifying because at least one civilization survived long enough to build interstellar probes. You are not necessarily alone. You are not necessarily doomed. The universe has proven that intelligence can emerge, develop technology, and reach for the stars. That is worth investigating. That is worth the telescope time, the analysis effort, the scientific scrutiny, because the payoff, if positive, is incalculable. But even if 3I Atlas is natural, its value is immense. You are learning about planetary formation in other stellar systems. You are studying material that experienced different chemical processes, different thermal histories, different evolutionary pathways. Every measurement refines our models. Every spectrum adds data points. Every observation teaches us something about the diversity of cosmic environments, and that knowledge is practical. Understanding how planetary systems form and evolve helps us predict which exoplanets might harbor life. Understanding cometary compositions helps us trace the origin of Earth's water and organic compounds. Understanding interstellar dynamics helps us map the galaxy's structure and history. Science builds incrementally, brick by brick, observation by observation. 3I Atlas is one more brick in that edifice. Unusual, yes, anomalous certainly, but still part of the larger construction of human knowledge. So what should you take away from this story? What is the message? First, pay attention to the anomalies. When data does not fit expectations, that is where discovery happens. That is where our models get refined or replaced. Easy answers are satisfying, but nature does not care about our comfort. Second, remain skeptical but open. Extraordinary claims require extraordinary evidence, but evidence can be extraordinary if you collect enough of it. Do not dismiss possibilities just because they seem unlikely. Calculate probabilities, test hypotheses, follow where the data leads. Third, the universe is stranger than we imagine. Black holes sounded like science fiction until we detected them. Exoplanets were theoretical until we found them. Gravitational waves were mathematical predictions until LIGO heard them. Reality keeps surprising us. What sounds impossible today might be textbook material tomorrow. And fourth, you are living through a golden age of astronomy. More telescopes, better instruments, faster data processing, international collaboration. For the first time in history, you can study interstellar objects in real time. You can track asteroids from other star systems. You can analyze their composition, measure their properties, test hypotheses about their origin. Our grandparents could not do this. Our ancestors could not even dream of this. But you can right now today, and 3 Atlas is just the beginning. More interstellar objects are coming. Better detection systems are coming online. Within a decade, you might be tracking dozens of visitors. Within a century, you might be sending our own probes to intercept and study them up close. The galaxy is opening to us slowly, gradually, but inexorably. Every year you see farther, understand more, discover wonders you could not have anticipated. So when 3I Atlas fades from view, disappearing back into the darkness between stars, it will not be the end. It will be a chapter, one story in an expanded library of cosmic encounters. And maybe, just maybe, one of those encounters will be the one that changes everything. The one that proves you are not alone. The one that answers the oldest question humanity has ever asked. Are we the only intelligence in the universe? The answer might be coming. Not today, not this year, but soon, within our lifetimes, potentially. As we explore more, detect more, analyze more, the probability of discovering evidence of other civilizations increases. And when that discovery happens, if it happens, I hope you are ready. Ready for the implications, ready for the questions, ready for the transformation of perspective that comes with knowing, truly knowing that intelligence exists beyond Earth. But until then, you watch the skies. You point out telescopes, you collect data, you analyze, you debate, you wonder. Because that is what humans do. You are curious, you are explorers, You are builders of instruments that extend our senses across the cosmos. You are creatures who look at points of light in the night sky and ask, "What's out there?" 3 Atlas gave us a glimpse, a tantalizing, confusing, anomalous glimpse, not enough to answer definitively, but enough to keep asking. And sometimes the questions matter more than the answers. The questions drive us forward, push us to build better telescopes, develop smarter algorithms, collaborate across borders and disciplines. Questions remind us that we do not know everything, that the universe still holds secrets, that discovery is possible if you are willing to look. So look up. This weekend, if you have access to a telescope, point it near Venus in the pre-dawn sky. Find that fuzzy patch of light, that visitor from another star, that 10-billion-year-old mystery. You will be observing directly an object that formed before the sun existed. You will be collecting photons that traveled across interstellar space. You will be participating in a small way in one of the greatest scientific investigations of our time. And maybe as you watch that fuzzy patch drift across the field of view, you will feel what I feel. A sense of connection to the cosmos, to the deep history of the universe, to the possibility that somewhere, sometime, other minds have looked at the stars and wondered the same things you wonder. Are you alone? 3 Atlas does not answer that question. Not yet. Maybe not ever. But it reminds us to keep asking. And as long as you keep asking, keep observing, keep analyzing, keep wondering, you are moving toward the answer. However long it takes, however many interstellar visitors you must study, however many anomalies you must investigate, the answer is out there somewhere, waiting to be discovered. And the next fuzzy patch of light you spot in our telescopes, the next interstellar wanderer that drifts through our solar system, that might be the one that finally tells us the truth. So stay curious, stay skeptical, stay open, and keep watching the skies because there is something very strange happening right now. A signal is being transmitted through space. You have been receiving it for weeks, and it is coming from the interstellar object that you probably already know. 3I Atlas, the comet. You do not know exactly what this signal means or why it is being sent. You cannot even confirm with absolute certainty that it is real. But if it is, then this would be the first time in human history that you have detected a deliberate transmission from an object entering our solar system. And that transmission is happening right now, at this very moment, on a frequency that every astronomer in the world recognizes, 1420 megahertz. Stay with me. On the 21st of October, 2025, a research team monitoring 3I Atlas reported something unexpected. They had detected a stable pulse sequence coming from the object's position in space. The pattern was clear, 6 numbers repeating. The signal was picked up simultaneously across multiple observation stations separated by more than 15,000 kilometers. That ruled out instrument error. It ruled out interference. It ruled out coincidence. What it did not rule out was the possibility that you were looking at the most significant discovery in the history of astronomy. The team shared their findings cautiously. They posted the data to a restricted astronomy server. They labeled it as anomalous, not as proof of anything. They waited for confirmation. Within 48 hours, confirmation arrived. Independent observatories in Chile, Australia, and South Africa all reported the same thing. A repeating pulse at 1420 megahertz emanating from the exact coordinates of 3I Atlas. The sequence was stable, it was precise, and it was deliberate. Now, before you go any further, you need to establish what 1420 megahertz actually means. This frequency sits at the boundary of the micro. Ave spectrum, it is the natural emission line of neutral hydrogen, the most abundant element in the universe. When hydrogen atoms transition between energy states, they emit radiation at exactly this frequency. In 1959, physicists Giuseppe Cacconi and Philip Morrison proposed that any intelligent civilization attempting to communicate across interstellar distances would likely choose this frequency. Why? Because it is universal. Any species capable of radio astronomy would recognize it immediately. It became known as the water hole because it sits between the spectral lines of hydrogen and hydroxyl, the 2 components of water. A quiet region of the radio spectrum relatively free from cosmic noise. For decades, SETI, the search for extraterrestrial intelligence, has been scanning this frequency range, listening for signals. So far, they found nothing conclusive. Until now. Let us be clear about what this signal is not. It is not a message in human language. It is not a series of images or mathematical proofs. It is not a greeting or a warning. It is a pattern, 6 numbers repeating at regular intervals, 8, 13, 8, 5, 13, 8, and those numbers are not random. They follow a very specific mathematical sequence, one that appears throughout nature, throughout mathematics, throughout the structure of galaxies and DNA. They follow the Fibonacci sequence. The Fibonacci sequence is simple. You start with 0 and 1. Every number after that is the sum of the 2 preceding numbers. It is a pattern that shows up in the spiral of a nautilus shell, in the arrangement of seeds in a sunflower, in the branching of trees, in the structure of galaxies. It is a mathematical signature that describes growth, efficiency, and natural design. And it is exactly what you are seeing in the signal from 3I Atlas. The numbers 5, 8, and 13 are consecutive Fibonacci numbers. The pattern 8, 13, 8, 5, 13, 8 is not a random scramble. It is a deliberate arrangement, a structure that any mathematician would recognize immediately. This is important because if you are trying to send a signal across interstellar space and you want to prove that the signal is not natural, you encode it with something unmistakable. You use mathematics. So here is what you know so far. 1. The signal is real. Multiple observatories have confirmed it. 2. The signal is stable. It repeats at consistent intervals, unaffected by the object's rotation or trajectory. 3. The signal is intelligent. It follows a mathematical pattern found throughout nature and advanced algorithms. 4. The signal is coming from 3I Atlas. The source coordinates match the object's position with extreme precision. Now, there are a few ways to interpret this. One interpretation is that the signal is a natural phenomenon, something you do not yet understand but ultimately explainable through physics. Another interpretation is that the signal is deliberate, that it was designed, that someone or something is trying to communicate. And there is a third interpretation, one that researchers are being very careful not to dismiss, that the signal is a transmission from the object itself. That 3I Atlas is not just a comet, that it might be something else entirely. Let us rewind for a moment and talk about what 3 Atlas actually is. On the 1st of July, 2025, the Atlas Survey Telescope in Chile detected a new object moving through the solar system. Its velocity was extreme, its trajectory was hyperbolic, and within a few days, astronomers confirmed what they had suspected from the beginning. This was an interstellar visitor. 3 Atlas became the third confirmed interstellar object to enter our solar system. The first was Oumuamua in 2017. The second was 2I Borisov in 2019. But 3 Atlas is different. It is larger, it is faster, and it is far more active than either of its predecessors. From the very beginning, 3I Atlas displayed unusual behavior. When Oumuamua passed through the solar system, it was inert. No coma, no tail, no outgassing. It was a dark, elongated object that tumbled through space and then vanished. 2I Borisov, on the other hand, behaved like a normal comet. It had a bright coma and a long tail. It released gas and dust as it approached the sun. It was predictable. 3I Atlas is neither. It has a coma, it has a tail, but the composition of that coma is strange. The behavior of that tail is wrong, and the object itself is emitting materials that you have never seen before in a natural comet. Let us go through the data point by point. Early estimates suggested that 3I Atlas was about 5 kilometers in diameter. That would make it significantly larger than Oumuamua, which was maybe 400 meters across, and larger than Borisov, about 1 kilometer. But as observations continued, that number kept changing. Some measurements suggested the nucleus could be as large as 5.6 kilometers. Others suggested it could be as small as 320 meters. The variation is unusual. Typically, when you observe a comet over weeks or months, our measurements converge. The uncertainty shrinks. With 3I Atlas, the uncertainty grew. Why? Because the object's brightness kept changing in ways that did not match standard comet behavior. It was not just getting brighter as it approached the sun. It was fluctuating in unpredictable patterns. That suggested something more complex than a simple icy nucleus reflecting sunlight. In August of 2025, the James Webb Space Telescope turned its instruments toward 3I Atlas. What it found was surprising. The coma, that glowing cloud of gas and dust surrounding the nucleus, was dominated by carbon dioxide, not water vapor, not methane, carbon dioxide. Now, comets do contain carbon dioxide. But in most comets, water is the dominant volatile. The ratio is usually about 8 parts water to 1 part carbon dioxide. In 3I Atlas, that ratio is reversed. It is about 8 parts carbon dioxide to 1 part water. That is extremely unusual. It suggests that Atlas formed in a very cold, carbon-rich environment, possibly in the outer regions of a protoplanetary disk, around a star very different from our Sun. But there is something else in the coma that is even stranger. Nickel. In September of 2025, the Very Large Telescope in Chile detected spectral lines corresponding to nickel vapor in the coma of Atlas. Nickel vapor is not unheard of in comets. In fact, a 2021 study found trace amounts of nickel and iron in the comas of several comets in our solar system. But here is the thing, nickel and iron almost always appear together. They form in the same stellar processes. They condense in the same regions of protoplanetary disks. They stick together. In 3 Atlas, astronomers detected significant amounts of nickel, roughly 4 grams per second, being released into space. But they detected no iron. 0. That is unprecedented. There is no known natural process that would produce nickel without iron in a cometary environment. Unless, of course, the nickel is not coming from natural processes at all. Let us pause here and talk about what nickel means in an industrial context. On Earth, nickel is used extensively in manufacturing. It is a key component of stainless steel. It is used in batteries. It is used in high-temperature alloys for aerospace applications. And there is one particular nickel compound that is especially relevant: nickel tetracarbonyl or nickel quarter. This is a volatile, toxic gas used in the refining of nickel. It is produced by reacting nickel metal with carbon monoxide under specific conditions. It is used in industrial processes to create high-purity nickel coatings, and it has never been observed in nature until now because spectroscopic analysis of the 3I Atlas coma suggests the presence of nickel tetracarbonyl. Now, to be absolutely clear, the detection of nickel tetracarbonyl is not definitive. The spectral lines are faint. The analysis is ongoing. Multiple research teams are working to confirm or refute the finding. But if confirmed, this would be extraordinary because nickel tetracarbonyl does not form naturally in space. It requires specific temperatures, specific pressures, and specific chemical precursors that simply do not exist in the environment of a comet. So how did it get there? One possibility is that you are misinterpreting the data, that the spectral lines you are seeing are actually from some other molecule that happens to look similar. Another possibility is that there is a natural chemical process occurring in the coma of 3I Atlas that you do not yet understand, something involving the interaction between nickel-bearing dust, carbon monoxide, and solar radiation. And then there is the third possibility, the one that is harder to dismiss than it should be, that the nickel tetracarbonyl is there because something manufactured it. Let us talk about the tail. In July and August of 2025, astronomers observing 3 Atlas noticed something strange. The object had a tail. Yes, but that tail was pointing in the wrong direction. Normally, a comet's tail points away from the sun. That is because the tail is formed by solar wind, a stream of charged particles flowing outward from the sun, pushing gas and dust away from the comet's nucleus. The tail always points away from the sun, always except on 3 Atlas. For weeks, the tail pointed toward the sun. This phenomenon is called an anti-tail, and it is not entirely unknown. A few comets in history have displayed anti-tails, usually as an optical illusion caused by the geometry of observation. But the anti-tail of 3I Atlas was not an illusion. It was a real jet of material, gas, and dust streaming from the nucleus toward the sun. The jet was narrow, focused, and persistent. By September, something had changed. The anti-tail disappeared. In its place, a conventional tail emerged, pointing away from the sun as expected. What happened? One explanation is that the anti-tail was caused by the early sublimation of carbon dioxide ice on the sun-facing side of the nucleus. As the comet warmed, pockets of frozen carbon dioxide beneath the surface expanded and burst outward, creating a directed jet. That jet would naturally point toward the sun because that is where the heating is most intense. Over time, as the object approached perihelion and the heating became more uniform, the jet activity shifted. The coma expanded, a conventional dust tail formed. That is the natural explanation, and it is consistent with what you know about cometary physics. But there is another explanation, one that researchers are reluctant to state publicly, but that keeps appearing in the margins of scientific papers and private communications. What if the antitail was not outgassing at all? What if it was thrust? Here is why that idea is difficult to dismiss entirely. 1. The antitail was stable. It did not fluctuate with the object's rotation, as you would expect from asymmetric outgassing. It remained pointed in the same direction relative to the Sun for weeks. 2. The antitail was narrow. Typical cometary jets spread out as they leave the nucleus. This one remained focused, more like a directed stream than a diffuse plume. 3. The transition from antitail to normal tail was abrupt. In most comets, the transition is gradual as activity increases. In 3I Atlas, the change happened over the course of just a few days in mid-September. 4. No corresponding increase in activity was observed elsewhere on the nucleus. If the antitail had been caused by a vent or active region on the Sun-facing side, you would expect to see changes in brightness or coma structure. You did not. These observations do not prove that the antitail was artificial, but they do suggest that something unusual was happening. And then on the 15th of September, something else happened. The antitail disappeared completely. No gradual fade, no transition to a different orientation. It simply stopped. And at that exact moment, within hours, astronomers detected the first pulse at 1,420 MHz. Let us talk about 1,420 MHz. This is not just any radio frequency. This is the frequency, the one that every SETI researcher on Earth has been monitoring for decades. Why? Because it is the natural emission line of hydrogen, and hydrogen is the most common element in the universe. If an intelligent civilization wanted to send a signal that would be recognized by any other technological species, they would choose a frequency that everyone would be listening to. 1,420 MHz is that frequency. The signal from 3I Atlas was first detected on the 15th of September, 2025 by a radio observatory in Australia. The detection was weak, barely above the noise threshold, but it was persistent. Over the next 48 hours, additional observatories confirmed the signal. By the 18th of September, at least 7 independent stations had logged the same pattern, 813, 8513, 8. The intervals between pulses were consistent, approximately 142 seconds. The frequency was precise. 1,420.4058 MHz is the exact center of the hydrogen line, and the signal's strength was stable. It did not fade in and out. It did not drift. It repeated with mechanical regularity. Now let us talk about what this signal is not. It is not a natural radio emission. Comets do not emit coherent radio signals. They reflect sunlight. They emit thermal radiation, and they release plasma when they interact with the solar wind, but they do not generate narrowband radio pulses at specific frequencies. It is not interference from Earth-based transmitters. The signal was detected at multiple observatories simultaneously with time delays consistent with the light travel distance between stations. That rules out local sources. It is not a reflection or echo. The signal's Doppler shift matches the motion of 3I Atlas relative to the Sun. It is coming from the object itself, not bouncing off it. So what is it? One possibility is that the signal is being generated by some kind of electrical discharge within the coma. Plasma interactions between charged dust particles and the solar wind could in theory produce radio emissions, but those emissions would be broadband, spread across a wide range of frequencies. They would not be concentrated at a single narrow bandwidth like 1,420 MHz, and they certainly would not follow a mathematical pattern. Another possibility is that you are seeing a technological artifact. Not necessarily from 3I Atlas itself, but from something inside 3I Atlas. This is where the conversation gets uncomfortable for many scientists, because once you start talking about artifacts and technology, you are implicitly talking about intelligence. And intelligence means intent. And intent means someone is trying to communicate, or worse, someone is trying to deceive. Let us explore that idea for a moment. If 3 Atlas is not a comet, or not only a comet, then what is it? One hypothesis proposed by Harvard astrophysicist Avi Loeb is that the object could be a probe, a spacecraft, a technological artifact sent by an extraterrestrial intelligence to study our solar system. Loeb has been careful to emphasize that this is a low-probability scenario, but he has also argued that the anomalies surrounding 3I Atlas are significant enough to warrant serious consideration. The signal at 1,420 MHz adds weight to that argument, because if you were designing a probe to travel between star systems and you wanted to announce your presence once you arrived, what would you do? You would send a signal on a frequency that everyone would recognize, and you would encode that signal with a mathematical pattern that could not possibly be mistaken for noise. You would use something like the Fibonacci sequence. Let us break down the pattern itself. 8 13 8 5 13 8. At first glance, it looks random. 6 numbers, no obvious structure, but look closer. The numbers 5, 8, and 13 are consecutive Fibonacci numbers. The sequence appears twice. 8 13 8 and 5 13 8. Why that specific arrangement? Some researchers have suggested that the pattern might be a compressed message. Each number could represent a symbol, a coordinate, or an instruction. Others have proposed that the pattern is simply a beacon, a way of saying, "We are here, we are intelligent, pay attention." Here is where things get speculative. On the 13th of October, 2025, exactly 108 years to the day after the famous Miracle of the Sun event at Fatima, Portugal, filmmaker David Sereda reported observing unusual light emissions from 3 Atlas. Sereda, who has a background in nuclear fusion research and works with MIT physicist Bogdan C. Maglik, claimed that the emissions followed a rhythmic pattern consistent with the Fibonacci sequence. He did not claim that this was definitive proof of intelligence, but he did note the timing of the observation and suggested that the coincidence was worth documenting. Now, it is important to state clearly, Sereda's observation has not been independently verified. No peer-reviewed paper has been published. No other observatory has confirmed the light pattern, but the data is interesting and the pattern is consistent with what you have been seeing in the radio signal. So, let us talk about what the Fibonacci sequence might mean in this context. In mathematics, the Fibonacci sequence describes a specific kind of growth, exponential but controlled. It appears in systems that balance efficiency with complexity. In biology, it governs the spiral patterns of shells, the branching of blood vessels, the arrangement of leaves on a stem. In astrophysics, it describes the distribution of matter in spiral galaxies. In computer science, it is used in algorithms for data compression, encryption, and error correction. It is a universal pattern, one that any sufficiently advanced civilization would recognize immediately. If you wanted to prove that your signal was not natural, you would use the Fibonacci sequence. And there is something else. The interval between pulses, 142 seconds, is not arbitrary. 142 is a Fibonacci adjacent number. It is close to 144, which is a Fibonacci number, the 12th in the sequence, but it is not exact. Why? One possibility is that 142 seconds represents a deliberate choice. A number that is recognizable, but not perfectly aligned with the sequence, a way of adding a second layer of meaning to the signal. Another possibility is that 142 seconds is related to the object's rotation period. But here is the problem. 3I Atlas does not appear to have a consistent rotation period. Its brightness fluctuates irregularly, which suggests either a complex shape or a tumbling motion. So the 142 interval does not match the object's physical behavior, which means the interval is not driven by rotation. It is driven by something else. On the 20th of October, 2025, a team of researchers at the SETI Institute attempted to decode the signal. They used standard cryptanalysis techniques, looking for patterns within patterns, testing different interpretations of the numbers, searching for hidden structure. What they found was both encouraging and frustrating. The signal is structured, but it is not a message in the traditional sense. It is not a sequence of words or images. It is not a mathematical proof or a star map. It is a pointer. Let me explain. In computer science, a pointer is a reference to a location in memory. It does not contain data itself. It tells you where to find the data. The signal from 3 Atlas might be functioning in a similar way. The Fibonacci pattern might not be the message. It might be instructions for how to interpret the message. Here is one possibility. The numbers 8, 13, 8, 5, 13, 8 could represent ratios, angles, or frequencies. They could describe a geometric structure, a way of organizing information in 3-dimensional space. If that is the case, then the message itself might not be in the radio signal at all. It might be encoded in the object's physical structure, its trajectory, or its emissions across other wavelengths. And that brings us to the suggestion that has been circulating quietly among researchers for the past few weeks. The suggestion that the true message is not in the signal, it is in what the signal points to. Observe, prepare. Understand, the gate awaits. This phrase did not appear in any official scientific paper. It did not come from NASA or ESA. It appeared on social media, attributed to an unnamed, decoded message from the signal. Let us be very clear, there is no evidence that this phrase was transmitted by 3I Atlas. There is no verifiable source for the claim, but the phrase has taken on a life of its own. It has been repeated, analyzed, and debated across forums and comment sections. Why? Because it feels deliberate, because it implies something specific, because it suggests that the signal is not just a beacon, it is a warning or an invitation. Let us break down the phrase. Observe. This could mean pay attention. Look carefully, study what is happening, prepare. This could mean get ready, something is coming, take action, understand. This could mean comprehend the situation, grasp the significance, do not react blindly, the gate awaits. This could mean there is an opportunity, there is a threshold, there is a transition point. Now again, this phrase did not come from the signal itself, but the fact that it emerged and the fact that it resonates with so many people tells us something important. It tells us that the signal has already changed how you think about 3I Atlas. It has shifted the object from a scientific curiosity to a potential harbinger. Now, let us talk about where 3I Atlas is going. On the 29th of October, 2025, the object reached perihelion, its closest approach to the Sun. It passed within 1.4 astronomical units of our star, just inside the orbit of Mars. At that point, it was traveling at approximately 68 kilometers per second, and then it was obscured by the Sun. For the next several weeks, Earth-based telescopes could not observe the object. It was too close to the Sun's glare. This is the period you are in right now, the eclipse, the gap in observation, and this is the period when everything changes. Here is what you know about 3 Atlas's trajectory post-perihelion. 1. It will reappear in early December 2025. By mid-November, the object should emerge from behind the Sun and become visible again to ground-based telescopes. 2. It will make its closest approach to Earth on the 19th of December 2025. At that point, it will be approximately 1.8 astronomical units away, about 270 million kilometers. Far enough to pose no threat, close enough to observe in detail. 3. It will pass Jupiter in March of 2026. The flyby distance will be about 0.36 astronomical units, roughly 54 million kilometers. That is close enough for detailed observation by NASA's Juno spacecraft. 4. After Jupiter, it will exit the solar system. Its hyperbolic trajectory means it is not bound to the Sun. It will continue outward, eventually crossing the heliopause and returning to interstellar space. That is the natural trajectory, the path dictated by gravity and orbital mechanics. But there is a problem. The signal suggests that the trajectory might not be natural. Let us talk about the Oberth maneuver. In orbital mechanics, the Oberth effect describes how a spacecraft can maximize its change in velocity by firing its engines at the moment when it is moving fastest, typically at perihelion, the closest point to the Sun. By adding velocity at perihelion, the spacecraft gains far more kinetic energy than it would by firing its engines in deep space. Now there is a variant of this maneuver called a reverse Oberth maneuver. Instead of accelerating, you decelerate. You fire your engines in the opposite direction of your motion, using the Sun's gravity well to amplify the braking effect. This is an extremely efficient way to slow down from interstellar speeds and enter a bound orbit around the Sun. And it is exactly what 3I Atlas could do during perihelion, while hidden from our view behind the Sun. If 3I Atlas performed a reverse Oberth maneuver on the 29th of October, you would not know until December when the object re-emerges from behind the Sun. If its trajectory has changed, if it is moving slower than expected, or if its orbital parameters have shifted, then you will know that something happened. And if that something was deliberate, then you will know that 3I Atlas is not a comet. It is a spacecraft. Now let us be very careful here. This is speculation. There is no direct evidence that 3I Atlas has performed a maneuver. The signal at 1420 MHz does not prove propulsion. The antitail does not prove artificial thrust. What you have is a collection of anomalies, and those anomalies, taken together, form a pattern that could be explained by natural processes, but also a pattern that could be explained by technology. Let us assume for a moment that the signal is real, that it is deliberate, that it is coming from something intelligent. What would that mean? Scenario 1, it is a probe. The most optimistic interpretation is that 3I Atlas is an automated probe sent by an extraterrestrial civilization to study our solar system. The probe enters the system on a hyperbolic trajectory. It observes, it collects data, it transmits a signal to announce its presence. The signal is not a message in the traditional sense. It is a handshake, a way of saying, we are here, we are peaceful, we are curious. If this is the case, then humanity's response should be measured and scientific. You should continue observing. You should attempt to send a reply. You should prepare for the possibility of further contact. This is the scenario that SETI has been planning for since its inception. Scenario 2, it is a warning. A less optimistic interpretation is that the signal is a warning, not from 3 Atlas itself, but from whoever sent it. The message is encoded in the trajectory and the timing. The object enters the solar system, broadcasts on a universal frequency, and then leaves. The signal is not an invitation. It is a notification, a way of saying, we know you're here, we are watching. This is the dark forest scenario. The idea that the universe is populated by civilizations that remain silent to avoid detection by potential predators. If this is the case, then the signal is not meant to initiate contact. It is meant to establish presence, to mark territory, to remind us that we are not alone and that we should be cautious. Scenario 3, it is a test. The third interpretation is that the signal is a test, a way of measuring our technological and intellectual development. The signal is deliberately ambiguous. It is structured enough to attract attention, but vague enough to avoid clear communication. The test is not in the signal itself. It is in how you respond. Do you panic? Do you ignore it? Do you attempt to decode it? Do you send a reply? Our response will tell the sender, whoever or whatever that is, what kind of civilization we are. And based on that response, they will decide whether to continue communication or to move on. Scenario 4, it is a Trojan horse. The darkest interpretation is that 3I Atlas is not a probe at all. It is a weapon. The signal is a distraction, a way of drawing our attention while something else happens. If the object performed a reverse Oberth maneuver at perihelion, it could now be on a trajectory that brings it back toward Earth. Or it could have deployed smaller payloads, probes, sensors, or something worse, that are now moving independently through the solar system. The signal stops. The object disappears behind the sun, and when it re-emerges, it is no longer following the path you expected. This is the scenario that no one wants to talk about. But it is the scenario that statistically you cannot rule out, because if the signal is deliberate, then someone sent it, and if someone sent it, then they had a reason, and you do not know what that reason is. As of today, the 30th of October, 2025, the signal has stopped. The last confirmed pulse was detected on the 28th of October, approximately 18 hours before perihelion. Since then, silence. Multiple observatories are still monitoring the 1420 MHz band. They are listening for any resumption of the signal. They are scanning adjacent frequencies for variations or secondary transmissions. So far, nothing. The silence is not necessarily significant. The object is currently obscured by the sun. Radio signals would be absorbed or scattered by the solar corona. You would not be able to detect them even if they were being transmitted. But the timing is notable. The signal began on the 15th of September. It continued for Roman 9 weeks, and then it stopped precisely at the moment when 3I Atlas reached perihelion. Was that intentional or coincidental? You will not know until the object re-emerges in early December. Right now, 3I Atlas is on the far side of the sun, hidden from view, moving at 68 kilometers per second on a path that will carry it past Jupiter and out of the solar system. Unless it is not, unless something changed at perihelion, unless the trajectory shifted, unless the object is no longer following the path you predicted, you will not know for another month. And that is the hard part, because right now, in this moment, all you can do is wait. NASA has stated publicly that 3I Atlas poses no threat to Earth. The object will come no closer than 270 million kilometers. Its trajectory is well understood. Its composition is consistent with a comet, but NASA has also acknowledged the anomalies, the unusual chemistry, the anti-tail, the nickel emissions, the signal, and in private communications, some scientists are more cautious. We don't know what we're looking at, one astronomer told me recently. We have data. We have observations, but we don't have an explanation that fits all of the data, and until we do, we can't rule anything out. The European Space Agency's JUICE spacecraft will attempt to observe 3I Atlas in November, shortly after the object re-emerges from solar conjunction. JUICE is currently en route to Jupiter, and the comet will pass through its field of view. NASA's Juno spacecraft will have an even better opportunity in March of 2026, when 3I Atlas passes within 54 million kilometers of Jupiter. Both spacecraft carry instruments capable of detecting radio emissions, measuring chemical composition, and capturing high-resolution imagery. If there is anything unusual about 3I Atlas, if it has changed course, if it is still transmitting, if there are structures or features that ground-based telescopes could not resolve, these spacecraft will be our best chance to find out. But that is months away. For now, you wait. Let us talk about how the scientific community is responding to all of this. Publicly, the tone is cautious, measured, professional. Astronomers emphasize the natural explanation. They point to cometary outgassing, plasma interactions, and observational uncertainties. They remind us that extraordinary claims require extraordinary evidence. And they are right. The signal at 1420 MHz could be instrumental noise. The Fibonacci pattern could be a coincidence. The nickel emissions could be explained by some chemical process you do not yet understand. All of these explanations are possible, and until you have definitive proof otherwise, they remain the most likely scenarios. But privately, the conversation is different. In emails and conference calls, in hallway discussions and late-night research sessions, scientists are asking questions that would have seemed absurd 6 months ago. What if it is not a comet? What if the signal is real? What if someone is trying to communicate? These questions are not being asked lightly. They are being asked by people who have spent their entire careers studying the natural universe, people who understand the difference between speculation and evidence, and they are asking these questions because the data is compelling, not conclusive, but compelling. On the 25th of October, 2025, the International Astronomical Union held a closed-door meeting to discuss 3I Atlas. The meeting was attended by representatives from NASA, ESA, the SETI Institute, and several major observatories around the world. No official statement was released following the meeting, but sources familiar with the discussion say that the conversation focused on two main topics. 1. The need for coordinated observation. Multiple spacecraft and ground-based telescopes need to be aligned to track the object when it re-emerges in December. This requires international cooperation and careful scheduling. 2. The need for a response protocol. If the signal resumes, or if new evidence emerges suggesting artificial origin, the scientific community needs to have a plan in place. Who speaks for humanity? What do you say? How do you respond? These are not easy questions, and they are questions that you have never had to answer before. The SETI Institute has been preparing for this moment for decades. They have protocols, they have guidelines, they have contingency plans, but those protocols were designed for a very specific scenario. The detection of a radio signal from a distant star system, a signal that would take years or decades to reach us, a signal that would give us time to prepare, to verify, to decide how to respond. 3 Atlas is different. It is not light years away. It is here, in our solar system, moving through our planetary neighborhood, and if the signal is real, and the sender is close enough to observe us, close enough to respond, that changes everything. Outside the scientific community, the response has been varied. On social media, the story of the signal has spread rapidly. Millions of people around the world are following the updates, sharing theories, debating interpretations. Some see it as proof of extraterrestrial intelligence. Others dismiss it as mass hysteria or misinterpretation of natural phenomena. And then there are those who see something darker, who view the signal not as an invitation, but as a warning, who believe that 3I Atlas is not here to communicate, but to observe or to threaten. Conspiracy theories have proliferated. Some claim that governments are hiding critical information about the object. Others suggest that the signal contains hidden instructions or encoded threats. One particularly persistent theory is that the phrase, "the gate awaits," refers to a physical structure, a portal or gateway that will be activated when the object completes its trajectory. There is no evidence for this, none whatsoever, but the theory persists, and in some corners of the internet, it has taken on a life of its own. Mainstream media has been more circumspect. Major news outlets have covered the signal, but most have emphasized the lack of definitive proof. They have quoted astronomers who caution against jumping to conclusions. They have presented the natural explanation alongside the more exotic possibilities. But the story is everywhere. It is on the front page of newspapers. It is trending on social platforms. It is being discussed in classrooms and coffee shops and living rooms around the world. Because regardless of what 3i Atlas actually is, the fact that you are even asking these questions represents a fundamental shift in how you think about our place in the universe. For the first time in human history, you have an object in our solar system that you cannot definitively explain, and that object is broadcasting a signal that you cannot definitively dismiss. This is not the first time you have thought you detected a signal from space. In 1967, astronomers at Cambridge University detected a series of radio pulses coming from a fixed point in the sky. The pulses were so regular, so precise that the research team briefly considered the possibility that they were artificial. They nicknamed the source LGM-1, Little Green Men 1. It turned out to be a pulsar, a rapidly rotating neutron star, a natural phenomenon, not a signal from an alien civilization. In 1977, astronomer Jerry Amon was analyzing data from the Big Ear radio telescope at Ohio State University when he noticed a strong narrowband radio signal coming from the direction of the constellation Sagittarius. The signal lasted for 72 seconds. It was so unusual, so perfectly aligned with what SETI had been searching for that Amon circled it on the printout and wrote "WOW" in the margin. It became known as the WOW signal. Despite decades of searching, the signal was never detected again. Its origin remains unknown. Some believe it was a natural astronomical phenomenon. Others believe it was a one-time transmission from an extraterrestrial source. We still do not know. And in 2017, you detected Oumuamua, the first confirmed interstellar object to pass through our solar system. Its elongated shape, its unusual acceleration, and its lack of cometary activity led some researchers, most notably Avi Loeb of Harvard, to suggest that it might be artificial, a probe, a light sail, something designed by an intelligent civilization. Most astronomers disagreed. They argued that Oumuamua could be explained as a natural object, albeit an unusual one. The debate continues to this day. The point is this: you have been here before. You have detected anomalies. You have asked questions. You have wondered if you are finally making contact. And every time the answer has been no. Every time you have found a natural explanation. But that does not mean the answer will always be no. Statistically, we know that we are not alone in the universe. There are billions of stars in our galaxy, billions of planets. The laws of probability suggest that life should be common. And if life is common, then intelligence should be possible. And if intelligence is possible, then technology should be inevitable. The question is not whether intelligent life exists. The question is whether you will ever detect it. And right now with 3i Atlas, you might be closer to that answer than you have ever been before. Let us step back for a moment and ask a broader question. If the signal is real, if 3i Atlas is artificial, if it was sent by an intelligent civilization, what does that mean for us? Not scientifically, not technologically, but philosophically, existentially. What does it mean for humanity to know that you are not alone? For thousands of years, humans We looked up at the night sky and wondered. You have told stories about gods and spirits living in the heavens. You have imagined other worlds, other beings, other civilizations. But for all of that time, it was just imagination, speculation, hope, or fear projected onto the darkness. If 3i Atlas is real, then it is not imagination anymore. It is confirmation. You are not alone. You have never been alone. And the universe is far stranger, far more populated, far more complex than you ever imagined. But there is another side to this realization. If you are not alone, then you are not special. You are not unique. You are not the center of anything. You are just one civilization among many. One species on one planet orbiting one star in one galaxy out of billions. That realization can be humbling or it can be terrifying, because if there are other civilizations out there, then some of them will be more advanced than us, more powerful, more capable, and you have no way of knowing their intentions. This is the core of the dark forest hypothesis. The idea popularized by science fiction author Liu Cixin is that the universe is like a dark forest. Every civilization is a hunter moving silently through the trees, and the first rule of survival is stay quiet. Because if you make noise, if you reveal your position, you might attract the attention of something stronger, something that sees you as a threat. In this view, the silence of the universe is not because intelligent life is rare. It is because intelligent life is cautious. Everyone is hiding, waiting, watching. And if 3i Atlas is broadcasting a signal, then whoever sent it is not hiding, which means either they are not afraid of being detected or they want to be detected, and you do not know which. Let us return to the signal itself and examine it more carefully. The pattern is 8, 13, 8, 5, 13, 8, 6 numbers, a specific sequence. You have established that these are Fibonacci numbers, but why this particular arrangement? One possibility is that the arrangement itself contains information not in what the numbers are, but in how they are ordered. If you treat the sequence as a code where each number represents a position or a ratio, you can start to extract a structure. For example, 8 appears 3 times, 13 appears twice, 5 appears once. That gives us a ratio of 3:1. Now 3:1 is not a Fibonacci ratio, but it is close to the golden ratio, approximately 1.618, which is the limit of the ratio between consecutive Fibonacci numbers. In other words, the frequency distribution of the numbers approximates a fundamental mathematical constant. That is not random. Now 5, 3, and 8 are all Fibonacci numbers, and the pattern of increases and decreases might represent a wave function, a way of encoding oscillation or modulation. But what is being modulated? What is the wave describing? You do not know yet. A third approach is to treat the sequence as coordinates. If each number represents a spatial dimension or a directional vector, then the pattern might describe a path through 3-dimensional space. Start at position 8, 13, 8. Move to 5, 13, 8. That is a movement along one axis. The first coordinate changes from 8 to 5, a shift of 3 units. If you map this out, the sequence describes a specific trajectory, a path, a set of instructions. But instructions for what and relative to what origin point? Again, you do not know. What you do know is that the pattern is not random. It contains structure, and that structure is mathematical, which means it is universal. Any civilization with an understanding of mathematics could decode it, and that is the point. That is why you would use mathematics to encode a signal, because mathematics is the one language that transcends culture, biology, and technology. 2 + 2 = 4, regardless of whether you are a human, a dolphin, or a silicon-based intelligence orbiting a red dwarf star. Mathematics is universal, and the Fibonacci sequence is one of the most universal patterns in mathematics. Let us talk about when the signal appeared. The first pulse was detected on the 15th of September, 2025. That was 44 days before perihelion. The last pulse was detected on the 28th of October, 2025. That was approximately 18 hours before perihelion. The signal was active for a total of 43 days. Now 43 is not a Fibonacci number, but it is close to 34, the 9th Fibonacci number, and 55, the 10th Fibonacci number. Is that significant? Maybe, maybe not. But here is what is significant. The signal started on the 15th of September, the exact date when the anti-tail disappeared. For weeks, astronomers had been observing a jet of material pointing toward the sun. Then on the 15th of September, that jet vanished, and at the same moment the signal began. It is as if the object switched modes, from physical emission to electromagnetic transmission, from showing us something to telling us something, and the signal ended on the 28th of October, just before the object reached perihelion and disappeared behind the sun. It is as if the transmission was timed to end at the precise moment when you would lose visual contact. Now, is it possible that this is just coincidence, that the signal happened to start and stop at these specific moments by chance? Yes, it is possible, but it would be an extraordinary coincidence. There is another detail worth noting. The interval between pulses, 142 seconds, translates to approximately 2.37 minutes. If you divide 24 hours by 142 seconds, you get roughly 608 pulses per day. Now 608 is not a Fibonacci number, but if you factor it, you get 608 equals 2 to the 5th power times 19. And 19 is a prime number. In fact, it is the 8th prime number, and 8 is a Fibonacci number. Is this meaningful? It is hard to say, but it suggests that the interval was chosen deliberately, not based on the object's rotation or orbital period, but based on mathematical principles. On the 27th of October, 2025, the United Nations held an emergency session to discuss 3i Atlas. The session was closed to the public, but a brief statement was released afterward. It read in part, "The international community acknowledges the ongoing observations of the interstellar object designated 3I Atlas. While the nature of the recent radio emissions remains under investigation, all member states are urged to maintain open channels of communication and to avoid unilateral action that could be misinterpreted or escalate tensions." The statement was carefully worded. It acknowledged the signal without confirming its significance. It called for cooperation without suggesting that cooperation was urgent, but the subtext was clear. This is serious, and you need to be prepared. Several governments have quietly activated their deep space tracking networks. Radar installations in Australia, Russia, and the United States have been retasked to monitor the region of space where 3I Atlas will re-emerge in December. Military satellites with infrared and optical sensors have been repositioned, not because anyone expects a threat, but because the possibility of a threat cannot be completely ruled out, and several space agencies, including NASA, ESA, and China's CNSA, have begun preliminary discussions about the feasibility of sending a probe to intercept 3 Atlas. Not now, not with current technology, but in the future, if another object like this enters the solar system, could you reach it? Could you study it up close? The answer, according to most experts, is maybe if we have enough warning. If we have the funding, if we have the political will. Right now, you have none of those things. While governments and space agencies debate protocols and response strategies, a different kind of response is happening at ground level. Amateur astronomers around the world have been pointing their telescopes at 3I Atlas since the moment it was discovered. They have been tracking its position, measuring its brightness, photographing its coma, and in the weeks since the signal was first detected, they have been listening. Several amateur radio enthusiasts have built or adapted receivers capable of monitoring the 1420 MHz band. They are listening for any resumption of the signal. They are scanning adjacent frequencies. They are recording everything, and they are sharing their data online. There is a growing community, a loose network of observers spread across every continent dedicated to tracking 3I Atlas and documenting its behavior. They call themselves the Atlas Watch. On forums and chat groups, members of the Atlas Watch share their observations, their theories, and their concerns. Some are skeptical. They believe the signal is instrumental noise or misinterpreted data. They are watching because they want to see the natural explanation unfold. Others are believers. They are convinced that the signal is real, that 3I Atlas is artificial, and that you are witnessing the most important event in human history. And then there are those in the middle, the ones who do not know what to believe, but who feel compelled to watch, who sense that something significant is happening, even if they cannot articulate what it is. On the 29th of October, as 3I Atlas reached perihelion, members of the Atlas Watch held a vigil, not in person. They are scattered across the globe, but online, a continuous live stream running for 24 hours where people could gather virtually to mark the moment. Thousands participated. Some left messages of hope, others left warnings, a few left jokes. One message stood out. It was posted at the exact moment of perihelion, and it read, "Whatever happens next, we were here, we saw it, we witnessed this moment. And that matters. Let us talk about the position that scientists find themselves in right now. On one hand, they have a responsibility to follow the data, to pursue evidence wherever it leads, to ask uncomfortable questions, and to consider unlikely possibilities. On the other hand, they have a responsibility to avoid speculation, to remain skeptical, to not jump to conclusions based on incomplete information. And right now with 3I Atlas, those two responsibilities are in conflict. The data is compelling. The signal is real. Multiple observatories have confirmed it. The pattern is structured. It follows the Fibonacci sequence. The timing is precise. It started and stopped at specific, significant moments, but the data is also incomplete. You do not have high-resolution images of the nucleus. You do not have direct measurements of the object's composition. You do not have a confirmed explanation for the nickel emissions or the anti-tail. And without that information, any conclusion is premature. So scientists are caught between two extremes. If they declare that the signal is definitely artificial, they risk being wrong. They risk destroying their credibility. They risk causing panic or false hope. But if they dismiss the signal as insignificant, they risk missing the most important discovery in human history. They risk looking foolish when the truth emerges. It is a no-win situation. And that is why most scientists are choosing a middle path. They are saying you do not know, but you are watching and you will share what you learn. It is not a satisfying answer, but it is the honest one, because the truth is you do not know what 3i Atlas is. Not yet. You have data. You have observations, you have anomalies, but you do not have answers. And until you do, all you can do is keep watching, keep listening, keep asking questions. As of today, the 30th of October, 2025, 3i Atlas is on the far side of the Sun. In 35 days, it will re-emerge. By early December, ground-based telescopes will be able to observe it again. And at that moment, you will know if the object's trajectory has changed. If it is slower than expected, or if its path has shifted, then you will know that something happened at perihelion, that the object performed a maneuver, that it is not following a purely gravitational path. If the signal resumes, if you detect new transmissions, new patterns, new frequencies, then you will know that the first transmission was not a fluke, that it was deliberate, that someone is trying to communicate. If new anomalies appear, if the object displays behavior that cannot be explained by cometary physics, then you will know that our understanding of 3i Atlas is fundamentally incomplete, or you might find that nothing has changed. The object might re-emerge exactly where you expect it to be, moving exactly as fast as you predicted. The signal might remain silent. The anomalies might resolve into natural explanations. And if that happens, then 3i Atlas will remain what it has always been, an unusual comet from another star system. Interesting? Yes. Important certainly, but not revolutionary, not world-changing. 35 days, that is how long you have to wait. And in those 35 days, the world will continue to watch, to speculate, to hope or fear or dismiss or believe. Because regardless of what 3i Atlas actually is, it has already changed us. It has forced us to ask questions that you have been avoiding, to confront possibilities that you have been denying, to admit that you do not know everything, that you might never know everything, and that the universe is far stranger than you ever imagined. Let me tell you what I think, not as a narrator, not as a researcher, but as someone who has spent months studying this object, analyzing the data, talking to scientists and skeptics and believers. Here is what I think. I think the signal is real. I do not know if it is artificial. I do not know if it represents intelligence. I do not know if it is a message or a beacon or a warning, but I think the signal is real. I think the pattern is deliberate. I think the timing is significant, and I think you are only beginning to understand what 3i Atlas actually is. I also think that you need to be careful not to jump to conclusions, careful not to let fear or excitement override rational analysis. Careful not to mistake our hopes or fears for evidence, because the truth is you do not know enough yet. You do not have enough data. You do not have enough observations, and until you do, any definitive claim, whether it is, this is definitely a comet, or this is definitely a spacecraft, is premature. But I also think you need to be honest about what you are seeing. The anomalies are real, the signal is real. The possibility that 3i Atlas is something other than a natural comet is real. That does not mean it is likely, but it means it is possible. And possibility in science is everything, because every discovery begins with a possibility. Every breakthrough starts with a question that someone was brave enough to ask even when the answer seemed impossible. So here is my question: what if you are wrong? Not about the data, not about the observations, but about our assumptions. What if the universe is not as empty as you think? What if intelligence is not as rare as you hope? What if you have been alone, not because you are unique, but because you have been too primitive to notice the signals that have been there all along? What if 3i Atlas is not the first visitor? What if it is just the first one you were advanced enough to detect? These are uncomfortable questions. They challenge our understanding of ourselves and our place in the cosmos. But they are questions worth asking, because if the signal is real, if 3i Atlas is artificial, if someone sent it, if you are being observed or contacted or tested, then everything changes. Not just for science, not just for technology, but for philosophy, for religion, for politics, for every aspect of human civilization. The question, are you alone, is not just an astronomical question, it is an existential one. And right now you might be closer to answering it than you have ever been before. 35 days from now you will know more, not everything but more. You will see where 3i Atlas is. You will measure its trajectory. You will listen for signals. You will analyze its composition. And based on that information you will update our understanding. You will refine our models. You will revise our conclusions. That is how science works, not through sudden revelation, but through patient observation. through the slow accumulation of evidence, through the willingness to change our minds when the data demands it. For now, all you can do is wait and watch and wonder. There is a very strange object moving through our solar system. You have been watching it for months. You have given it a name. You have studied its trajectory, analyzed its composition, listened to its signal, and you still do not know what it is. Maybe it is a comet, an unusual one, yes, a rare one, certainly. But ultimately, a natural object, ice and rock and dust, cast out from another star system and passing briefly through ours. Or maybe it is something else, something designed, something deliberate, something sent. You will not know for certain until December, but in the meantime, the signal has changed something fundamental in how you think about the universe. It has reminded us that you are small, that you are curious, that you are capable of asking questions even when you are afraid of the answers. And it has shown us that the universe is vast and strange and full of possibilities that you are only beginning to explore. The gate, if there is one, awaits. But first you watch, you listen, you learn, and you prepare for whatever comes next. Let us talk about who is watching 3 Atlas right now, not just the professional astronomers with their multi-million-dollar telescopes, not just the space agencies with their orbital observatories and deep space tracking networks. Let us talk about everyone else, because in the months since 3I Atlas was discovered, it has captured the attention of millions of people around the world. People who have never looked through a telescope before, people who could not tell you the difference between a comet and an asteroid 6 months ago. They are watching now in observatories from Hawaii to Chile, from South Africa to Australia. Astronomers are working around the clock. They are taking measurements, analyzing spectra, comparing data sets, but they are not the only ones watching. Amateur astronomers have set up telescopes in their backyards, on rooftops, in remote dark sky locations. They are photographing the sky, tracking the object's position, sharing their findings online. Radio enthusiasts have built receivers from scratch, tuning them to 1420 MHz, listening for any whisper of a signal. Students in classrooms are learning about orbital mechanics and spectroscopy and interstellar space by following the journey of 3 Atlas. And somewhere in living rooms and coffee shops and late-night conversations, ordinary people are asking extraordinary questions. One of those people is Dr. Sarah Chen, a high school physics teacher in Vancouver. She is not an astronomer, she is not a researcher, but when news of the signal first broke, she started following the story. She read the papers. She watched the interviews. She taught her students about the Fibonacci sequence and the hydrogen line. And then she did something remarkable. She organized a global observation event. Dr. Chen reached out to teachers around the world. She proposed a coordinated effort. On the night of the 1st of December, 2025, the first night when 3I Atlas would be visible again after solar conjunction, students in every time zone would observe the same patch of sky. They would not all have telescopes. Many would not see anything at all, but they would all be looking together. The response was overwhelming. Within a week, more than 5,000 schools in 120 countries had signed up. From elementary schools to universities, from urban classrooms to remote villages, millions of students would participate. They called it the Global Watch. This isn't about finding aliens, Dr. Chen said in an interview. This is about showing young people that they can be part of something bigger, that they can contribute to human knowledge, that they can look up at the sky and know that millions of other people are looking up at the same time. Maybe, she added, just maybe we'll see something interesting. The Global Watch is not the only grassroots initiative. In online communities, citizen scientists have been analyzing publicly available data, looking for patterns that professional astronomers might have missed. One group, calling themselves the Fibonacci Collective, has been studying the numerical pattern of the signal, testing different interpretations, comparing it to mathematical constants and physical laws. Another group, the Trajectory Trackers, has been modeling 3I Atlas's path through the solar system, looking for any deviations from predicted positions that might indicate a course correction. And a third group, the Quiet Listeners, has been monitoring the 1420 MHz frequency band continuously, recording everything, archiving the data for future analysis. These are not conspiracy theorists. These are not fringe believers. These are engineers and mathematicians and computer programmers, retired NASA employees and graduate students and software developers, people with the skills to analyze data, the knowledge to ask intelligent questions, and the time to devote to a mystery that fascinates them. And in some cases, they are finding things that professional astronomers missed. On the 15th of October, a programmer named Marcus Webb noticed something unusual in the timing of the signal pulses. The interval between pulses was listed as 142 seconds, consistent, regular. But when Marcus analyzed the raw data, the actual timestamps of each detected pulse, he found tiny variations, microsecond-level fluctuations that had been averaged out in the published reports. The variations were not random. They followed a pattern. And that pattern, Marcus discovered, corresponded to the motion of 3I Atlas relative to the solar system's barycenter, the center of mass of the Sun and all the planets combined. In other words, the signal was compensating for gravitational effects. It was maintaining a constant interval, not in absolute time, but in proper time, time as measured in the object's own reference frame. That is not something a natural phenomenon would do. That is something you do deliberately to ensure that your signal remains coherent across different gravitational potentials. Marcus shared his finding online. Within hours, professional astronomers had verified it. Within days, it had been incorporated into ongoing analyses, and within a week, Marcus had been invited to join a collaborative research project studying the signal. This is how science works now, not just in universities and research institutions, but in distributed networks of curious, skilled people around the world. The discovery of 3 Atlas belongs to professional astronomers, but the understanding of it, the slow, patient work of analyzing every detail, testing every hypothesis, following every lead, that belongs to everyone. Not everyone believes the signal is significant. In fact, the majority of astronomers remain skeptical that there is anything unusual about 3I Atlas at all. Let us be fair to them. Let us hear their arguments. Dr. Thomas Brennan is a planetary scientist at the University of Arizona. He has spent 30 years studying comets. He has analyzed data from dozens of cometary missions. He knows these objects intimately, and he thinks the excitement around 3 Atlas is overblown. Look, he said in a recent interview, I understand why people are excited. It's an interstellar object. That's rare, that's interesting, but everything we're seeing can be explained by normal cometary processes. The composition, it's unusual, yes, but not impossible. Different star systems have different chemical abundances. A comet that formed in a carbon-rich environment would naturally have high carbon dioxide and low water. The nickel emissions, again, unusual, but not unprecedented. There are chemical pathways involving nickel carbonyl that could produce those spectral lines under the right conditions and the signal. Dr. Brennan shook his head. Radio interference, instrumental artifacts, pattern-seeking behavior, we see what we want to see. Dr. Brennan is not alone. Several prominent astronomers have published papers arguing that 3I Atlas is a comet. Interesting, yes, but ultimately natural. They point to the object's behavior. It has a coma. It has a tail. It brightens as it approaches the sun. It shows outgassing activity. These are the hallmarks of a comet, and nothing about 3I Atlas's behavior contradicts that interpretation. The anomalies, the composition, the anti-tail, the nickel emissions can all be explained by variations in cometary chemistry and structure that you simply have not observed before. Because here is the thing. You have only seen 3 interstellar objects ever. You have no baseline, no standard model of what an interstellar comet should look like. When you see something unusual, is it because the object is artificial, or is it because our understanding of interstellar comets is incomplete? Extraordinary claims require extraordinary evidence, Dr. Brennan said, and so far we don't have extraordinary evidence. We have anomalies, we have curiosities, we have data points that don't fit our current models, but that doesn't mean aliens. That means we need better models. He paused. And yes, I know about the signal. I know about the Fibonacci pattern, but pattern recognition is a human cognitive bias. We're wired to see patterns even when they're not there. Show me a clear, unambiguous techno-signature, something that cannot possibly be natural, and then we'll talk. Until then, I'm going to assume that 3I Atlas is what it appears to be, a comet from another star system. This is a reasonable position. It is the position that most scientists take when confronted with unusual data. Skepticism is not the same as close-mindedness. It is the foundation of the scientific method. You do not accept a claim just because it is interesting. You accept it because the evidence compels you to, and for many astronomers, the evidence does not yet compel them. But here is the counter-argument. Dr. Rachel Kowalski is an astrobiologist at MIT. She studies the conditions necessary for life, the signatures of biological activity, and the methods we might use to detect extraterrestrial intelligence. And she thinks the skeptics are missing something important. The absence of evidence is not evidence of absence, she said. Just because we can't definitively prove that 3I Atlas is artificial doesn't mean we should assume it's natural. The null hypothesis, the default assumption should be that we don't know, not that it's a comet and not that it's a spacecraft. We don't know, and when we don't know, we should investigate. We should gather more data. We should test hypotheses. We should remain open to possibilities, even uncomfortable ones. Dr. Kowalski pointed to the history of scientific discovery. Think about pulsars, she said. When they were first detected, astronomers thought they might be artificial. They were so regular, so precise that they seemed designed. But we investigated, we gathered data, and we found a natural explanation. Or think about fast radio bursts. For years, we didn't know what they were. Some people speculated about alien technology, but we kept observing, kept analyzing, and now we know they're natural astrophysical phenomena. But here's the key. We only found those natural explanations because we investigated, because we took the possibilities seriously, even when it seemed unlikely. If we dismiss 3I Atlas as just a comet without thoroughly investigating, we might miss something extraordinary, and that would be a failure of science. This tension between skepticism and openness, between caution and curiosity, defines the current moment in the study of 3I Atlas. No one knows who is right. No one can know. Not yet. All you can do is continue observing, continue analyzing, and continue asking questions. Let us talk about the simulations. Over the past few weeks, multiple research teams have been building computer models of 3I Atlas. They are trying to predict where the object will be when it re-emerges in December, how bright it will be, and what its trajectory will look like. But they are also trying to answer a deeper question. If 3 Atlas performed an Obert maneuver at perihelion, what would that look like? Dr. James Liu is a computational astrophysicist at Caltech. His specialty is orbital mechanics, the mathematics of how objects move through space under the influence of gravity. In mid-October, he started running simulations. First, he modeled the natural scenario. No thrust, no maneuvers, just gravity. In this scenario, 3 Atlas follows a simple hyperbolic trajectory. It swings around the sun, picks up speed, and continues outward when it re-emerges from behind the sun. In December, it should be exactly where you expect it to be, moving exactly as fast as you predict. This is the baseline, the control case. Then Dr. Liu modeled the artificial scenario. He assumed that 3I Atlas is a spacecraft with a propulsion system. At perihelion, it fires its engines in a reverse Obert maneuver, bleeding off velocity to enter a bound orbit around the sun. How much thrust would be required? That depends on the object's mass. And that is where things get interesting. If 3 Atlas is a typical comet, ice and rock and dust, then its mass is probably around 10 billion tons based on its estimated size. To slow down from 68 kilometers per second to orbital velocity would require an enormous amount of energy, tens of terawatts sustained for hours. That is a lot, more than you could generate with solar panels or nuclear reactors. You would need something more exotic. Fusion engines perhaps, or matter-antimatter annihilation. Possible but difficult. But what if 3I Atlas is not solid? What if it is mostly hollow, a shell surrounding empty space? Then its mass could be much lower, maybe 1 billion tons, maybe even less. And if the mass is lower, the thrust requirement drops dramatically. Now you are talking about power levels that might be achievable with advanced nuclear or fusion technology. Still difficult, still beyond our current capabilities, but not impossible. Dr. Liu ran the simulations multiple times, varying the parameters, mass, thrust, duration, timing, and he found something unexpected. If you time the burn just right, if you start the maneuver a few hours before perihelion and sustain it for about 8 hours, you can enter a stable elliptical orbit with perihelion at Mars's distance and aphelion at Jupiter's distance. In other words, you can park the spacecraft in the habitable zone of the solar system, close enough to observe the inner planets, far enough to remain undetected by casual observation. It is the perfect surveillance orbit. Now, Dr. Liu was very careful to emphasize that this is speculation. He was not claiming that 3I Atlas actually performed this maneuver. He was simply exploring what would be possible if the object were artificial. My job, he said, is to model scenarios, to test hypotheses, to show what the data would look like under different assumptions. And what I can tell you is this. If 3I Atlas wanted to stay in the solar system, if it wanted to observe us without being obvious, then an Obeth maneuver at perihelion would be the most efficient way to do it. Whether that actually happened, whether the object is artificial at all, that's for the observers to determine. I'm just showing what's possible. Other research teams have run similar simulations and they found similar results. If 3I Atlas is artificial, if it performed a maneuver, then you should see specific changes when it re-emerges. 1. Position offset. The object should be slightly ahead of or behind its predicted position, depending on the timing and duration of the burn. 2. Velocity change. The object should be moving slower than expected. Not by much, maybe a few kilometers per second, but measurably. 3. Orbital modification. The object's trajectory should no longer be hyperbolic. It should be elliptical, bound to the sun. These are testable predictions, falsifiable hypotheses, and in December, you will know if they are correct. While scientists debate hypotheses and run simulations, the rest of the world has moved on to something more visceral: speculation. The media coverage of 3I Atlas has been intense. In the first few weeks after discovery, coverage was measured, scientific. News outlets reported the facts. An interstellar object had been detected. It was moving fast. It would pass through the solar system and leave. Then came the signal. The headlines changed. Is this a message from aliens? Scientists detect Fibonacci code in interstellar object. The signal from 3 Atlas, first contact or cosmic coincidence? Some outlets maintained their composure. They interviewed astronomers. They explained the uncertainty. They emphasized that no conclusions had been reached, but others leaned into the spectacle. They published breathless articles about alien motherships and interstellar probes. They quoted fringe researchers making bold claims. They presented speculation as fact, and the public, hungry for answers, consumed it all. On social media, the conversation fractured into camps. The believers, convinced that 3I Atlas is artificial, that the signal is real, that you are witnessing first contact. The skeptics, insisting that it is a comet, that the signal is noise, that you are letting your imaginations run wild. And the curious, unsure what to believe, but fascinated by the mystery, eager for more information. Each camp has its influencers, its thought leaders, its online communities, and they argue constantly. But underneath the noise, something interesting is happening. People are learning. They are learning about orbital mechanics and spectroscopy. They are learning about the Fibonacci sequence and the hydrogen line. They are learning about the scale of the universe, the possibility of life beyond Earth, and the methods we use to search for it. A month ago, most people could not tell you what an astronomical unit was. Now, millions of people around the world can explain the difference between perihelion and aphelion. A month ago, the phrase reverse Obeth maneuver meant nothing to anyone outside a small community of aerospace engineers. Now it is trending on social media. This is the power of a good mystery. It captures attention. It provokes curiosity. It makes people want to understand. And maybe that is the real significance of 3 Atlas, not what it is, but what it represents. A reminder that the universe is vast and strange, that there are questions you have not answered, that there are possibilities you have not explored, that you live in a cosmos full of mystery, and that is worth paying attention to. You are now entering the final phase of this story. In less than 35 days, 3 Atlas will re-emerge from behind the sun. Telescopes around the world will turn toward its expected position. Observers will measure its trajectory, its brightness, its composition, and you will know. Not everything, but enough. Already observatories are preparing. The European Southern Observatory's Very Large Telescope in Chile is allocating time for observations in early December. The Keck Observatory in Hawaii is coordinating with other facilities to ensure continuous coverage. NASA's Hubble Space Telescope has scheduled observation windows. Radio observatories are ready to scan the 1,420 MHz band. If the signal resumes, they will detect it within minutes. And spacecraft in the solar system, ESA's JUICE, NASA's Juno, and several Mars orbiters are positioning themselves for optimal observation angles. This is not a casual effort. This is a coordinated global campaign to observe a single object with unprecedented detail because everyone involved understands what is at stake. If 3I Atlas re-emerges exactly where you expect it, moving exactly as fast as predicted with no signal and no anomalies, then the story ends. It is a comet. Unusual, yes. Interesting, certainly, but natural. But if anything is different, if the trajectory has changed, if the signal resumes, if new anomalies appear, then the story is just beginning. Dr. Emily Rodriguez is the coordinator of the International Observation Campaign. She is a career astronomer, 25 years of experience, dozens of published papers, and she has never been more nervous. "This is it," she said during a recent planning meeting. "This is the moment. In a few weeks we'll have our answer, or at least we'll have more data, better data, data that will let us narrow down the possibilities. But whatever we find, it's going to be significant because 3I Atlas has already changed how we think about interstellar objects. It's already pushed the boundaries of what we thought was possible, and I suspect it's going to keep surprising us. Let us take a moment to acknowledge something important. This is not just a story about a comet or a signal or a scientific mystery. It is a story about people, people who spend their lives studying the stars, people who build telescopes and write software and analyze data. People who lie awake at night thinking about orbital mechanics and spectroscopy and the possibility of life beyond Earth. This is their passion, their calling, their life's work. And for many of them, 3I Atlas represents something profound. Dr. Alan Foster is 72 years old. He has been an astronomer for half a century. He has discovered comets, studied asteroids, contributed to our understanding of the solar system. When I spoke to him in early October, he was reflective. "You know," he said, "I've spent my entire career hoping for a moment like this, hoping that we'd find something, some sign, some evidence that we're not alone. And now here we are. Maybe, possibly, it might be nothing. It probably is nothing, but it might not be." He paused. "I'm an old man. This might be my last chance to see something extraordinary, to witness the most important discovery in human history. Or it might not. Maybe 3I Atlas is just a comet. Maybe I'll spend the rest of my career studying comets and asteroids and never knowing if we're alone. But I'm grateful that I get to be here right now in this moment of possibility, grateful that I get to watch and wonder and hope. That's what keeps us going, not certainty, hope." Dr. Foster is not alone in feeling this way. For many astronomers, 3I Atlas represents something more than a research project. It represents a dream, a lifetime of asking questions, a career spent searching for answers, and whether the answer is yes, it is artificial, or no, it is natural. The fact that you are asking the question, the fact that you are taking it seriously, that matters. Let us play a thought experiment. Let us assume just for a moment that the skeptics are wrong, that 3I Atlas is not a comet, that the signal is real, that the object is artificial. What happens next? First, there would be confirmation, multiple observations, multiple analyses, multiple independent verifications. The scientific community would need to be absolutely certain before making any public announcement. That process would take weeks, maybe months, but eventually the evidence would become overwhelming and someone, NASA, ESA, the UN would make a statement. "We have detected evidence of extraterrestrial technology in our solar system." And then everything changes. Not immediately, not dramatically, but fundamentally, because that statement would be the most important sentence ever spoken by a human being. It would rewrite our understanding of the universe. It would reshape our understanding of ourselves. It would answer the oldest question in human history. Are you alone? And the answer would be no. The implications would ripple outward in every direction. Scientifically, it would open entirely new fields of study. Astroarchaeology, xenotechnology, interstellar communication protocols. You would study 3I Atlas with every instrument you have. You would analyze its structure, its materials, its propulsion system. You would try to understand how it was built, where it came from, who sent it. And you would listen. You would search for more signals. You would scan the sky for other objects, other probes, other signs of intelligence. Philosophically, it would challenge our place in the cosmos. You are not unique. You are not special. You are one species among many. That realization would be humbling for some, terrifying for others, liberating for a few. Every religion would have to grapple with the implications. Every philosophy would need to adapt. Every political system would face questions about sovereignty, representation, and belonging. If there are other intelligences in the universe, do you have obligations to them, rights, responsibilities? These are not abstract questions. They are urgent, practical concerns. Politically, it would be complicated. Who speaks for humanity? The UN, individual nations, a new international body? How do you coordinate a response? How do you ensure that communication is handled carefully, ethically, transparently? And how do you prevent panic? How do you manage the transition from a universe where you thought you were alone to a universe where you know you are not? These are difficult questions, and there are no easy answers. But here is what I think would happen in the long term. You would adapt, you would learn, you would grow, because that is what humans do. You face the unknown, you ask questions, you find answers, and then you ask more questions. The discovery of extraterrestrial intelligence would not be the end of the story, it would be the beginning. The beginning of a new era of exploration, a new understanding of our place in the universe, a new relationship with the cosmos, and maybe, just maybe, a new hope for our future. But you are not there yet. Right now, on the 30th of October 2025, you are still in the waiting phase, the uncertainty phase, the phase where anything is possible. 3i Atlas is behind the sun, silent, invisible, unknown. And for the next 35 days, all you can do is wait. Across the world, people are watching the calendar, counting down the days until the 1st of December when the object re-emerges. Scientists are preparing their instruments. Students are organizing their global watch event. Amateur astronomers are clearing their schedules. And somewhere in quiet rooms and late-night conversations, people are wondering what you will find. Will the signal resume? Will the trajectory change? Will you see something new, something unexpected, something that finally gives us an answer? Or will 3i Atlas continue on its path, unchanged and unchanging? A comet from another star system passing briefly through ours? You do not know, but you are about to find out. And that is the most exciting part. Not the answer, but the moment before the answer, the anticipation, the possibility, the recognition that you are living through something significant. That you are witnesses to a mystery that might change everything. So here you are, the 31st of October 2025. 35 days until you know more. The signal has stopped. The object is hidden. The world is watching. And somewhere out there beyond the sun, beyond our ability to see or measure or understand, 3i Atlas continues its journey, moving at 68 kilometers per second, trailing a faint coma of gas and dust, silent, enigmatic. Indeed, utterly fascinating. For now, all you can do is watch the clock and prepare yourselves for whatever comes next. Because in 35 days, the mystery of 3i Atlas will take its next turn. And when it does, you will be ready, or at least you will try to be. Let us talk about the other trajectory. For weeks, the conversation has focused on one maneuver, the reverse orbit. The possibility that 3 Atlas would use its perihelion pass, hidden by the glare of the sun, to fire a thruster, slow itself down, and enter a new orbit. An orbit that could, as Avi Loeb's calculations suggested, bring it on an intercept course with Earth by late November or early December. This is the scenario that has held us in suspense. The Trojan horse, the Black Swan event, the possibility that this object is not just a probe, but a potential threat. But what if you are wrong? What if you have been looking at the wrong planet? What if the destination was never Earth? There is another hypothesis, another trajectory, one that is just as chilling, just as deliberate, and in many ways far more intelligent. The destination is not Earth, it is Jupiter. Let us talk about the logic. If 3 Atlas is an alien technological craft, a colonization force, or an advanced probe, what is its logical objective? Would it come straight to Earth? A planet with 8 billion inhabitants, a chaotic civilization, a robust immune system that would react with panic and hostility, a planet with a deep, heavy gravity well that makes landing and, more importantly, launching incredibly expensive and difficult. Or would it go somewhere else? Somewhere quiet, somewhere uncontested, somewhere with more resources, lower gravity, and a strategic position from which to observe and eventually control the entire solar system. If you are an interstellar colonizing group, you do not pick a fight you do not need. You do not land in the middle of a crowded, unpredictable city. You go to the high ground. In our solar system, the high ground is not Earth. It is Jupiter. Think about the trajectory. 3 Atlas is already on a path that takes it very close to Jupiter. A close flyby is scheduled for March of 2026. It would take only a very slight orbit maneuver at perihelion, a tiny burn, a small change in velocity to shift that trajectory from a flyby to a rendezvous. It would not need a massive reverse thrust burn to slow down and intercept Earth. It would just need a gentle nudge, a little acceleration using the sun's gravity to fling itself into a perfect capture orbit around the largest, most powerful planet in our solar system. It is a smarter move, a more patient move. It is a checkmate move. While you have been anxiously watching our own backyard, terrified of a direct threat, the real invasion might be happening somewhere else entirely. a quiet, uncontested colonization of the outer solar system, and by the time you even realize they are there, it will already be too late. Why Jupiter? To us, it is a distant, hostile giant, a ball of gas and radiation, a place you send hardened probes, not a place you would ever live. But to an advanced interstellar intelligence, Jupiter is not a planet. It is a resource hub, it is a fortress, it is the key to the entire solar system. Let us look at the assets. Jupiter is not just one planet. It is a system of its own with dozens and dozens of moons. 4 of them are massive, planet-sized worlds in their own right. The Galilean moons, Io, Europa, Ganymede, Callisto, and 3 of them, Europa, Ganymede, and Callisto, are water worlds. They are believed to have vast liquid water oceans buried beneath their kilometer-thick crusts of ice. Water, the universal solvent, the single most important resource for life and for industry. You can drink it, you can grow things with it, and you can split it into hydrogen and oxygen. Rocket fuel, the highest grade, most powerful rocket fuel in existence. An interstellar craft arriving after a long journey would be low on fuel. Its first priority would be to find a refueling station. The Jupiter system is not just a gas station, it is an entire strategic reserve. Now let us look at the real prize, Ganymede. Ganymede is the largest moon in the entire solar system. It is bigger than the planet Mercury. It is bigger than Pluto. It has a huge subterranean ocean of water. It has a low-density surface, easy to dig into, easy to build within. And it has 2 things that make it unbelievably unique. First, low gravity. Ganymede's surface gravity is just 1.4 milliseconds. Earth's is 9.8 square milliseconds. What does that mean? It means launching things into space from Ganymede is effortless. On Earth, you have to build monstrous rockets, burning millions of tons of fuel just to fight our way out of our own gravity well. On Ganymede, you could launch massive industrial payloads, colonization ships, or military craft with a fraction of the energy. It is the perfect launch point to the rest of the solar system. Second, a magnetic field. Ganymede is the only moon in our solar system known to have its own magnetic field, a geodynamo churning in its metallic core. That magnetic field, while weak, provides a shield, a first line of defense against the brutal radiation belts of Jupiter. It is a small protected bubble in the most hostile environment in the solar system. It is a perfect place to set up a base. And there is one more thing, an incredible coincidence. Ganymede has an atmosphere. It is thin, incredibly thin, but it contains something vital. Oxygen. A craft arriving at Ganymede could immediately begin harvesting oxygen from the atmosphere. It could have breathable air before it even drills down to the water ice. It could hit the ground running. Water, fuel, low gravity, a magnetic shield, oxygen. It is not just a good spot, it is the perfect spot. If you wanted to conquer a solar system, you would not go to Earth. You would go to Ganymede. You would set up your base. You would drill for water. You would manufacture fuel. You would build your industry. You would launch your ships. And you would do it all in complete secrecy, while the inhabitants of the 3rd planet were busy arguing about whether you were a comet or not. The colonization of Jupiter's moons is just the first step. It is the beachhead. From there, you have uncontested access to the single greatest source of industrial material in the solar system, the asteroid belt, and Jupiter conveniently controls it. You have our main asteroid belt, a band of trillions of rocks and metals orbiting between Mars and Jupiter. But Jupiter also has its own private collection, the Trojan asteroids. These are 2 massive clouds of asteroids, each containing millions of objects that are locked in Jupiter's orbit. They follow the planet around the Sun, trapped in a perfect gravitational resonance, 60 degrees ahead and 60 degrees behind the planet. If you have a base on Ganymede, you have an effectively unlimited supply of high-grade minerals and metals right on your doorstep. And here is the strategic genius, the gravity. If you launch from Earth to mine the asteroid belt, you have to fight your way out of Earth's gravity, fly millions of miles, lock onto a target that is also moving, mine it, and then fly all the way back. It is a logistical nightmare, but if you launch from Ganymede, the gravity is low. You can launch effortlessly. You fly a short hop to the Trojan asteroids, which are locked in a gravity-neutral zone between Jupiter and the Sun. You mine your resources. You fly back. You have all the water you need for fuel. You have all the metal and minerals you need for industry. You have low gravity for easy transport. You have a perfect self-sustaining industrial base from which to colonize the entire solar system. You could work your way outward, setting up colonies on Saturn's moons like Titan. You could work your way inward to the asteroid belt to Mars. You could establish a presence across the entire system uncontested. By the time humanity even figures out how to send a probe to chase you down, a mission that would take us decades to plan and launch, they would find you already established everywhere. This is the destination Jupiter hypothesis. It does not rely on a direct hostile confrontation. It relies on patience, strategy, and a perfect understanding of orbital mechanics and resource management. It is the move a truly intelligent, advanced civilization would make. And 3I Atlas's trajectory is already aligned for it. It flew by Mars, perhaps collecting data. It is using the Sun for a gravity assist, and its next stop is a close approach to Jupiter. All it needs is that one tiny push, that one hidden maneuver to turn a flyby into an arrival, a maneuver that would have happened yesterday hidden behind the Sun. If 3 Atlas is a craft, a colony ship, a probe, where did it come from? The universe is vast. Tracing a trajectory back through interstellar space is almost impossible. The object has been traveling for millions, maybe billions of years. It could have come from anywhere, but the calculations are not random. You know the direction it came from, the constellation Sagittarius, the heart of the Milky Way, and you can trace its path backward. Recently, astronomers did just that. They took the known velocity and trajectory of 3I Atlas and backtracked its journey over 10 million years, checking its path against the known movements of stars in our galactic neighborhood. They identified 93 stars that the object would have encountered over that period, and they found something deeply fascinating. Over the course of 10 million years, the closest 3I Atlas came to any of those 93 other stars was a distance of 0.3 light-years. That is 63,000 astronomical units. To put that in perspective, right now it is just 1.4 astronomical units. From our Sun, what does this mean? It means its journey here was not an accident. It was not just passing by another star and getting flung in our direction. Its trajectory toward our Sun is, in the context of its 10 million-year journey, an extreme statistical anomaly, a 1 in a million shot. It is almost as if it was aimed. But where could it have been aimed from? There is one candidate that is more likely than others. Barnard's star. It is the second closest star system to our own. Just 5.96 light-years away. It is a red dwarf, older and dimmer than our Sun, and we know it has planets. At least 4, maybe more, are orbiting that star. Here is the connection. Barnard's star is located in the constellation of Ophiuchus, the Serpent Bearer. This is right next to Sagittarius, the direction 3I Atlas came from. In the night sky, their origin points are incredibly close together. And then there is the math. If you traveled from Barnard's star, 5.96 light-years away, at the observed speed of 3I Atlas, around 60 kilometers per second, the journey would take approximately 30,000 years. In the grand scheme of interstellar travel, that is not a long time. It is a manageable journey, a journey you could plan, a journey you could survive. You are not saying 3I Atlas is from Barnard's star, but it is a candidate, a plausible origin point, a red dwarf system with its own planets headed toward our system. Perhaps this is what advanced civilizations do. They do not just explore, they move. They migrate from one star system to the next, using resources, setting up outposts, and continuing their journey. And 3I Atlas is just the latest arrival. Let us go back to the ante-tale. For weeks, you have discussed the two possibilities. Possibility A, it was a natural jet of carbon dioxide gas and dust pointing toward the Sun, which later dissipated as a normal tail formed. Possibility B, it was artificial thrust, a braking maneuver. Now there is new data, a new anomaly that complicates the natural explanation and gives chilling new weight to the artificial one. Recent measurements of 3I Atlas suggest its velocity has not been constant. Let me be clear. You expect its velocity to change. That is what gravity does. As it falls toward the Sun, it speeds up. That is normal, but the observed changes do not perfectly match the models. In the weeks before perihelion, several observatories recorded a slight reduction in its acceleration rate. A slowdown. It was too subtle to be a definitive braking maneuver, but it was too large to be a measurement error. So what could cause an object to slow down when gravity is telling it to speed up? The most common explanation for a comet is cometary drag, outgassing. As the comet heats up, jets of gas erupt from its surface. These jets act like tiny thrusters. If they happen to fire in the direction of the comet's motion, they can push against it, causing a tiny, measurable deceleration. This is known as non-gravitational acceleration, but here is the problem. To create the observed slowdown, 3 Atlas would need to be outgassing massively. You would need to see a huge coma, a brilliant tail, vast plumes of gas and dust. And you do not. Spectroscopic surveys from multiple observatories, including the European Southern Observatory and Pan-STARS, have revealed minimal volatile activity. In fact, the object has been described as lacking a typical cometary tail for most of its approach. There is no cometary tail or gas emissions strong enough to justify this deceleration. In short, the engine is firing, but there is no smoke. Astrophysicists rechecked all the models. They factored in solar tides, planetary perturbations, solar radiation pressure, and it is not enough. These natural forces can only account for a fraction of the observed slowdown. It's not enough to close the equation, one astronomer told Nature Astronomy. This brings us back to Avi Loeb. He points out that this is exactly what Oumuamua did. It also exhibited non-gravitational acceleration, but in the opposite direction. It sped up. Loeb argued that Oumuamua's acceleration was caused by sunlight pushing on a very thin, flat light sail. Now with 3I Atlas, you have the opposite, a non-gravitational deceleration with no visible cause. Loeb argues that controlled deceleration is a sign of mechanical or structural responsiveness, something not seen in nature. If 3I Atlas has a flat geometry, solar torque could be acting on it unevenly. Or if the antitail was thrust, this is the data that proves it. You have an object that is slowing down when it should be speeding up. You have an object that is firing thrusters with no visible exhaust. You have an object that is behaving exactly like Oumuamua, but in reverse. And you have an object that is now, today, hidden behind the sun at the perfect moment to perform its main final maneuver. The skeptics argue this could just be an instrumentation error, that the object's faintness and changing brightness make velocity calculations difficult, but the pattern is there. The equation does not close. Let us talk about a black swan. The term was popularized by the essayist Nassim Taleb. A black swan event is an event that is impossible to predict, comes as a complete surprise, and has a profound, game-changing impact on history. In hindsight, these events always look inevitable, but beforehand, they are unthinkable. The invention of the internet, the 2008 financial crisis, the 9/11 attacks. Avi Loeb has warned that 3I Atlas could be a black swan event, an event that looks natural at first, just another comet, but ends up being something else, a Trojan horse. This is why he has been so vocal, why he has been willing to risk his reputation by challenging the mainstream consensus. Because if there is even a 0.1% chance that this object is technological, the implications are 100%. If this object turns out to be artificial, Loeb said, it will redefine not just astronomy but civilization itself. This is the core of the dilemma. The scientific community is trained to dismiss low probability events, to favor the simplest explanation, the null hypothesis. And 99.9% of the time, that is the correct approach. But when the consequences of being wrong are total, the simplest explanation is not always the safest. If a doctor sees a strange shadow on an X-ray, they do not dismiss it as probably nothing. They investigate because if it is something, the consequences of ignoring it are catastrophic. 3I Atlas is a shadow on our solar system's X-ray. It has 8 documented anomalies that separate it from any natural comet you have ever seen. 1. Ecliptic alignment. Its trajectory is aligned almost perfectly within 5 degrees with the flat plane of our solar system. The odds of this for a random interstellar object are tiny. 2. The antitail, the sunward-pointing jet that defies typical comet physics. 3. Massive size. It is 1,000 times more massive than Borisov and 1,000,000 times more massive than Oumuamua. 4. Planetary flybys. A trajectory that coincidentally brings it close to Mars, Venus, and Jupiter. 5. Nickel-enriched coma, the industrial signature of nickel without iron. 6. Low water content, a composition of 4% water when 80% is typical for comets. 7. Extreme polarization. The light reflecting off it polarizes in an extreme negative way, unprecedented among comets. 8. The WOW signal. Its arrival direction is within 9 degrees of the 1977 WOW signal. Any one of these would be an interesting curiosity. All 8 of them together on the same object. This is what Loeb calls cumulative improbability. This is the definition of a black swan. An object that looks like a comet, acts mostly like a comet, but has a collection of features that when taken together point to something else entirely. And this black swan is currently hidden behind the sun at the exact moment it could be performing its most critical maneuver. Let us talk about the WOW signal. On the 15th of August, 1977, the Big Ear radio telescope at Ohio State University detected a powerful, unexplained narrowband radio signal. It lasted for 72 seconds. It was exactly the kind of signal that SETI, the search for extraterrestrial intelligence, was looking for. Astronomer Jerry Amon, who was reviewing the data, was so stunned he circled the sequence on the printout and wrote, "Wow," in the margin. The signal came from the direction of the constellation Sagittarius. It was never detected again. For 48 years, it has remained one of the greatest unsolved mysteries in astronomy, a single powerful burst of seemingly intelligent communication and then silence. It was dismissed by most as a one-off anomaly, a glitch, perhaps a reflection of an Earth-based signal. Until now, because you know where 3I Atlas came from, the direction of Sagittarius. Avi Loeb and his collaborators calculated the position of 3 Atlas back in 1977 when the WOW signal was detected. On that date, 3 Atlas was far out, still in deep interstellar space, but its position in the sky was just 9 degrees away from the origin point of the WOW signal, a 9-degree alignment. Is that a coincidence? The chance of 2 random directions in the sky aligning that closely is about 0.6%. It is possible, it is just unlikely. What if 3I Atlas or something with 3I Atlas emitted that signal as it passed through the outer solar system 48 years ago? A hello as it entered the neighborhood. And now, after 5 decades of travel, it has finally arrived. And it is broadcasting again, not a single WOW burst, but a deliberate repeating pulse on the hydrogen line. The Fibonacci. Sequence 813-8513-8. The connections are speculative, but they are piling up. A signal from 1977, an object from the same direction. A new signal in 2025 on the exact frequency SETI has been listening to for decades. How many once-in-a-lifetime coincidences are you allowed to have before you admit that something is going on? While the public debate between scientists like Avi and his skeptical colleagues has played out in the media, a darker, more secretive conversation has been happening. On a restricted dark web board, a document appeared. It claims to be a leaked internal memo from NASA. We cannot verify this document. We cannot confirm its authenticity. We are presenting it as it was found, as another piece of this baffling puzzle. The memo is dated the 2nd of August, 2025. Just 1 month after 3I Atlas was discovered. The subject line, see 2019 Y4 Atlas Anomalous Behavior and Classification Update. The clearance level, 5 clearance required. Do not distribute. The summary reads, the object exhibits accelerative properties inconsistent with Newtonian predictions. Preliminary analysis indicates non-gravitational influences of unknown origin. Surface scans suggest highly reflective composite material. Spectral anomalies recorded. This aligns perfectly with the deceleration anomaly. The spectral anomalies, the reflective composite material, could explain the high albedo and fluctuating brightness. Then the action items: suspend all public discussion outside scripted narrative, redirect external communications to standard Comet disintegration protocol, neutralize unauthorized dissemination on digital platforms. This is the official story you have been hearing. It is just a comet. It is breaking up. It is normal. But then the memo contains a final chilling confidential note. Confidential, object appears to be under active vector control. Maintain operational silence. Active vector control, that is not a term for a comet. That is a term for a guided missile, a spacecraft. The memo continues detailing a track ID and an anomaly summary. Unscheduled vector deviation detected. Object exhibited an instantaneous delta-v event of 0.0037 kilometers per second, inconsistent with expected gravitational influence. The magnitude and direction of course alteration suggest active propulsion or controlled maneuvering. It claims the object is not natural. This is the smoking gun that conspiracy theorists have been searching for. A document that proves NASA knows the truth and is actively hiding it. Is it real? It is almost certainly fake. A fabrication designed to sow panic and mistrust. But what if it is not? What if the most chilling part of the memo is the section titled Signal Data? Let us look at the Signal Data section of that leaked memo. Remember, this memo was supposedly written on the 2nd of August, 2025. The signal, the 813-85138 Fibonacci pulse, was not publicly reported until mid-September. But the memo dated the 2nd of August lists the following: bandwidth 1420.458 MHz hydrogen line, pattern repeating narrowband burst every 142 seconds, decoding attempts, failed non-terrestrial coding sequence suspected, the exact frequency, the exact interval. How could a memo, faked or real, from the 2nd of August contain the precise details of a signal that would not be discovered for another 6 weeks? There are only two possibilities. One, the memo is real, and NASA has been tracking this signal since at least August, hiding the data from the public under Level 5 clearance. The discovery in September was not a discovery at all. It was a controlled leak. Two, the memo is a retrofitted fake. Someone faked it after the signal was reported and simply backdated it to the 2nd of August to make it look more credible. The second option is by far the most logical, but the document was reportedly posted before the public reports of the signal. This is the heart of the mystery. The timeline does not add up, and the comments attached to the leak on the dark web board are even more disturbing. One user, DeepSignal88, wrote, "Op is not wrong. Object is not natural. We call it Class 7. Instructions were given to keep narrative contained. Public cannot know. Check DSN anomaly report." 17 days until first major orbital deviation. Don't ask how I know. This account will be gone soon. Another user added, "Signal analysis confirms megahertz. The intervals appear to follow non-random prime factor patterns, implying intentional encoding." And then this, more concerning, is the latest DSN report on trajectory modifications. The object is projected to enter a stable Lagrange region between Earth and the Sun. This is a new trajectory, a new hypothesis, not an Earth intercept. Not a Jupiter rendezvous, but a stable orbit parked perfectly in a Lagrange region, a gravity-neutral spot where it can sit and watch. Again, this is unverified. It is almost certainly disinformation, but it all comes back to the same terrifying core. The object is under active vector control. It is not a comet. It is a vessel, and it is making deliberate propulsive maneuvers. If that is true, then the 35-day wait is not just a period of observation. It is a countdown. While you are blind, hidden by the sun, 3i Atlas is not unobserved. You have probes and spacecraft scattered across the solar system, and many of them are in the right place at the right time to get a look. This is the ad hoc fleet, the missions that were not designed for this, but are being repurposed in real time to track our visitor. First, there was the Mars flyby. On the 3rd of October, 3i Atlas passed within 30 million kilometers of Mars. Mars Express and EXO-Mars Trace Gas Orbiter, TGO, both turned their instruments to observe it. The images they sent back were faint, challenging. The cameras were designed to look at a bright planet, not a dim comet 100,000 times fainter. But they saw it, a fuzzy white dot. NASA's rovers on the surface, Perseverance and Curiosity, also looked up. Perseverance, after stacking 20 images, found it. A faint smudge of light, exactly where it was predicted to be. And then there was the HiRISE camera, the most powerful telescope in the Mars system, aboard NASA's Mars Reconnaissance Orbiter. It did take a photograph, the highest resolution image you could possibly have of 3i Atlas. That image has not been released. Avi Loeb claimed on the Joe Rogan Experience that he personally requested the data from the principal investigator and never received a response. The official reason, the US government shutdown, a political stalemate that furloughed NASA's communications department at the exact moment the most important image in modern history was supposed to be released. A coincidence just like the 9-degree alignment with the WOW signal, just like the nickel without iron, just like the Fibonacci sequence. The coincidences are starting to pile up, but the Mars flyby is over. Now the object is at perihelion and there are other observers. JUICE mission, Jupiter Icy Moons Explorer, is perfectly positioned. It will observe 3i Atlas in November just as it emerges from the sun's glare, getting the best view of the comet in its most active state. NASA's Juno spacecraft will get its chance in March of 2026 during the Jupiter flyby. And then there is Europa Clipper. This might be the most important observation of all. A new prediction from European researchers has identified a rare and fortuitous alignment. NASA's Europa Clipper spacecraft, currently in cruise mode on its way to Jupiter, is about to fly directly through the tail of 3i Atlas. Let me say that again. You are not just going to look at the comet. You are going to sample it. Comets have two tails. The dust tail, which is bright and follows the comet's orbit, and the iron tail, which is fainter, made of charged particles and always points directly away from the sun, pushed by the solar wind. Between the 30th of October and the 6th of November, right now, Europa Clipper is aligned perfectly with the sun and 3I Atlas. It is in position to be pummeled by charged particles from the comet's iron tail. This is an opportunity beyond anything astronomers could have dreamed of. A direct sample of material from another star system. You can use Europa Clipper's instruments to taste the tail. You can measure its composition directly. You can see if it contains nickel, if it contains iron, if it contains complex organic molecules. You can finally get a definitive answer. This is the closest you can currently get to a direct sample of a different part of the galaxy. But there is a problem. Europa Clipper is in cruise mode. Not all of its instruments are activated. To make these measurements, scientists on Earth need to awaken the spacecraft. And they cannot because of the US government shutdown. The exact same shutdown that is preventing the release of the high-rise image from Mars. The alignment window is between the 30th of October and the 6th of November. If the shutdown is not resolved by then, if scientists cannot awaken Europa Clipper in time, the opportunity will be lost forever. The object passes. The tail dissipates, the alignment ends. You are at the brink of the most important scientific discovery in history, a direct sample of an interstellar object. And you are going to miss it because of paperwork. Unless this too is not a coincidence. What if the shutdown is the scripted narrative? What if the high-rise image is being withheld not because of a furloughed communications department, but because it shows something that cannot be explained? What if Europa Clipper is being kept asleep not because of a budget dispute, but because someone is afraid of what it might taste in that iron tail? What if the shutdown is the perfect excuse, the perfect operational silence? You are now in the eclipse. 3 Atlas is behind the sun. Silent, unseen, it has just passed perihelion, the moment of maximum velocity, the moment of maximum stress, the moment of maximum opportunity. When it emerges in a few weeks in early December, you will face one of two realities. Reality 1, the comet. The object will reappear exactly where the laws of gravity say it should be. It will continue on its hyperbolic path, fading as it heads toward Jupiter and then out into the void. The signal will not return. The anomalies will be explained away as unusual but natural cometary chemistry. Scientists will write papers. Skeptics will say, "I told you so." And 3I Atlas will become a fascinating footnote in the history of astronomy. Reality 2, the visitor. The object will not be where you expect it. It will have slowed down. Its trajectory will be different, changed. It will be on a new bound orbit. The signal will return, perhaps with a new message, perhaps on a new frequency. The high-rise image will be released or it will be buried forever, and you will be forced to accept the truth. You are not alone. The object in our solar system is not a rock. It is a vessel. It is under active, intelligent control. You do not know its intentions. You do not know its capabilities. You do not know if it is a scout, a colonist, or a hunter from the dark forest, but you will know definitively that humanity's place in the cosmos has changed forever. There is no middle ground. There is no maybe. The test is coming. For 35 days you wait. You listen to the silence, and you prepare for the moment when 3I Atlas emerges from the shadow of the sun. The countdown has begun. This exploration of 3I Atlas represents humanity's attempt to understand the unknown through observation, analysis, and open inquiry. The signal at 1420 MHz, the Fibonacci pattern, and the possibility of artificial origin remains a hypothesis, fascinating, worthy of investigation, but unconfirmed. What you have documented here, real observations of an interstellar object, reported anomalies in composition and behavior, claimed detection of structured radio emissions, multiple scientific interpretations from natural to artificial science. What you acknowledge, the extraordinary nature of these claims requires extraordinary evidence. Skepticism is not dismissal. It is responsible science. Pattern recognition can mislead as easily as it can illuminate. The truth may be simpler, stranger, or more profound than you imagine. In December of 2025, new observations will provide new data. That data will help us understand. But understanding is a process, not a destination. For now, you observe, you question, you remain open to evidence wherever it leads. The universe is vast. The possibilities are infinite. And the story of 3I Atlas, whatever that story ultimately reveals, is still being written. If you have not already heard, our solar system is currently host to a strange and intriguing visitor. Comet 3 I Atlas burst onto the astronomical scene in early July of 2025, when it was first identified by the NASA-funded Atlas Survey Telescope, or Asteroid Terrestrial Impact Last Alert System, operating in Rio Hurtado, Chile. Since then, scientists across the globe have assembled to collect every scrap of information they can get about this elusive entity, leading to a flurry of articles, alerts, papers, and controversies about the first interstellar object to enter our cosmic backyard in 6 years. But amid this media frenzy, what have you actually learned? What information about this comet is true, and what lies in the realms of science fiction? You are watching as we give you a much-needed update on 3I Atlas, piercing through the noise and getting to the heart of what makes this visitor so special, just in time for its 30th of October perihelion. If nothing else, the buzz around this comet proves how dynamic the world of science research can be. When my first video about 3I Atlas was made back in July, there were only around 4 published research papers naming it. Now, at the time of writing in September, there are nearly 70. That represents a huge number of new discoveries, verifications, and boosts in our collective knowledge about this object. But before I dive into the newest findings, let us do a quick recap of where you left off. Previously, I discussed the initial discovery of Comet 3I Atlas, named for its status as the third interstellar object to visit our solar system, and the Atlas Survey Telescope that identified it. I compared this comet to the famed Oumuamua, which made its way through our solar system in 2017, and Borisov, which was discovered in 2019. In contrast to its 2 interstellar predecessors, 3I Atlas is thought to be much faster, traveling at a whopping speed of 58 kilometers per second, and older, with estimates that it is somewhere between 3 and 11 billion years old. That was a speedy summary, so you should definitely check out my first video for more in-depth information. But since 3I Atlas made its debut, you have learned a lot more about it, thanks to countless hours of observation and measurements from astronomy facilities across the globe. So, what is the latest information to come from this researching spree? With the worldwide recognition that 3I Atlas has attracted since its discovery, it has managed to turn the heads of 2 very prestigious telescopes. It is famously difficult to schedule observation time with NASA's Hubble Space Telescope, with scientists having to submit proposals months in advance to argue their case for every minute of the telescope's time. But luckily for 3I Atlas, Hubble always reserves some time for so-called targets of opportunity, things that need to be observed before they move out of our reach, giving this unexpected interstellar visitor a free pass to skip the queue. And it was definitely worth it. Hubble captured this image of 3I Atlas on the 21st of July, when it was 446 million kilometers from Earth. You can get a sense of how fast the comet is traveling from the streaky stars in the background and see the teardrop shape of the dust coming off its icy nucleus. These observations also allowed Hubble scientists to make estimates for the size of 3I Atlas's nucleus, measuring it between 440 meters and 5.6 kilometers in diameter. That makes it a lot smaller than we originally thought, since original estimates of its size assumed that the comet's reflectance was coming entirely from the nucleus, not the coma. But now that the dust has cleared, you can see things in finer detail, and future observations may be able to pin down these measurements even more. The other major player that has turned its attention to 3I Atlas is the James Webb Space Telescope. On the 6th of August, scientists used JWST's near-infrared spectrograph in an attempt to determine the composition of this comet, in a study led by astrochemist Dr. Martin Cordner. They found a complex coma morphology, suggesting a range of different outgassing patterns depending on the elements and compounds being released. It seemed that carbon monoxide and carbon dioxide were sublimating more at this stage than water, but this is likely to change as the comet gets closer to the Sun. And while usually comet tails point away from the Sun, the researchers found a surprising amount of dust emanating from the comet in the direction of the Sun, caused by the dust grains fragmenting as they move further from the nucleus and in turn reflecting more light. This process might be exacerbated by gas production, as excessive carbon dioxide production could actually be launching the dust further away from the nucleus. Pretty dramatic for a feature that appears to us as nothing more than a hazy glow. Hubble and James Webb are not the only NASA telescopes getting in on the 3I Atlas fun. The Transiting Exoplanet Survey satellite, affectionately known as TESS, has spent more than 7 years conducting an all-sky survey to discover exoplanets orbiting around nearby, bright stars. It uses 4 identical wide-field cameras to map the sky in 90 by 24 degree strips, and has already discovered thousands of planetary candidates. But as it turns out, TESS is not just good at detecting exoplanets, but smaller objects too, objects like comets. In my previous video, I mentioned that the first official discovery of 3I Atlas was actually predated by observations going back to the 14th of June. However, astronomers working with NASA's TESS mission realized that they had observational data for this comet dated all the way back to May. The comet was captured by TESS from the 7th of May to the 2nd of June and was made visible in composite deep stack images. With this new data, astronomers had the chance to verify the earlier measurements made from 3I Atlas and make some new discoveries of their own. In a paper published on the 11th of September, Adina Feinstein, John Noonan and Darrell Seligman used data from TESS to measure the brightness of 3I Atlas. They found that the average visual magnitude recorded by one of the TESS detectors was in line with previous estimates made by other astronomers using the same data. But the comet was about to defy expectations in another way. Between the 7th of May and the 2nd of June, the distance between 3I Atlas and the TESS spacecraft decreased by 0.9 astronomical units. From this change alone, the authors expected the object to get brighter since it would be closer to the Sun and could reflect more of its light. They calculated that the comet's flux, or the amount of energy received from it, would increase by a factor of 1.5, corresponding to a magnitude of 20.5. But the object got much brighter than that. Its magnitude increased to 19.28. This shocking surge in brightness was the result of 3I Atlas increasing its flux by a factor of 5, not 1.5. Observations with the TRAPPIST North and South telescopes reported similar brightness values, confirming there was no miscalculation. With such a huge amount of energy radiating from this object, 3I Atlas is far more active than you originally thought, and may have been active for a long time. Combining their magnitude values with the Hubble estimates for nuclear size, the researchers found that 3I Atlas may have been active when it was still a whopping 6 astronomical units away from the Sun. That is near the outer limits of where comets usually start outgassing, suggesting that 3I Atlas might have been releasing something more exotic and hypervolatile at this time, like nitrogen or hydrogen. In my previous video, I said that 3I Atlas had a flatter light curve than Oumuamua, which suggests that it reflects light more evenly across its surface. Well, Feinstein and her colleagues came to a similar conclusion when they tried to extract a light curve for this comet using the TESS data. In fact, they struggled to find any patterns in the light curve at all, so they could not conclusively identify the comet's rotation period. They did identify some periodic signals, one every 29 hours and another every 16 hours, but the data was noisy, and TESS may not have been sensitive enough to measure this kind of parameter for a faint object like 3I Atlas. Luckily, other studies using specialized ground-based telescopes agree with the 16-hour spin period, so we can be more confident of the comet's shape and how it rotates. I have only covered space telescope discoveries so far, but discoveries about 3I Atlas have been made by telescopes back on Earth too. On the 27th of August, researchers working with the Gemini South Telescope in Chile used the Gemini Multi-Object Spectrograph to visualize 3I Atlas in multicolor. Amazingly, the images captured in this session showed not just the coma around the comet's nucleus, but its tail. The tail was measured to span about 1/120th of a degree in the sky, which is significantly longer than it appeared in previous images using the Gemini North Telescope back in July. This is further proof that 3I Atlas is becoming more active as it approaches perihelion, and hints at exciting developments to come. Who knows how much more the tail will grow before the comet reaches its perihelion on the 30th of October. The August session also collected the spectrum for 3I Atlas. In this recording, you can watch the moment when Bin Yang, assistant professor at Diego Portals University, identified an emission feature in the CN band for the comet, proving that it was releasing cyanide molecules. This happens when water sublimates upon exposure to sunlight, releasing hydrogen cyanide from the comet, which is then broken apart by sunlight into its constituent elements. You often start to see this when a comet is between 2.5 and 3 astronomical units from the Sun, which is exactly where 3I Atlas now finds itself. Other observatories have affirmed this finding, as the once weak CN signature is steadily strengthening over time. A paper published at the beginning of September inferred that the comet was releasing 800 sextillion, or 8 times 10 to the power of 23, cyanide molecules per second, when it was just over 3 astronomical units from the Sun, which is actually on the lower end of the scale for many comets in our solar system. By measuring the ratio of decarbon to cyanide in the coma, the authors placed 3I Atlas as one of the most carbon chain depleted comets we know of. But what does that mean? Carbon chain depletion occurs when a comet's coma or tail is lacking in longer chain carbon molecules like decarbon or tricarbon. This feature is used to classify comets found across the solar system and is thought to reflect the conditions in which they were first formed. So using an upper limit for the comet's decarbon production, scientists concluded that 3I Atlas produces less than 0.09 decarbon molecules for every CN molecule, and so it is carbon chain depleted. Interestingly, Borisov also shared this feature, so this may point to a pattern in the composition of these comets. However, it is important to note that the interstellar sample size is still very small, so you should try to avoid overgeneralizing. Either way, you should keep an eye on 3I Atlas as T approaches our Sun. As decarbon production could rise, the comet could start out gassing more water, or something even more dramatic could happen. As astronomer and comet expert Karen Meach has said, these comets are really very fragile, dirty snowballs and can often break apart. If that happens, you could see a renewed bout of emissions as the break exposes untouched water ice to the Sun's radiation. In recent days, researchers have analyzed not only how 3I Atlas emits light, but how it polarizes light. On the 5th of September, a paper was published by Zuri Gray and colleagues presenting the first ever polarimetric observations of 3I Atlas, and by extension, the second ever observations of this kind for an interstellar object, the first being Borisov. Polarimetry is used specifically to probe the physical properties of space objects, like the size of their dust grains, the structure of their surface regolith, and the shape of their coma, in a way that cannot easily be done with other techniques. Gray and her colleagues used data from telescopes across Chile, the Canary Islands, and Bulgaria, and managed to discover something about 3I Atlas that set it apart from any other interstellar object, asteroid, or comet you have seen before. They found that 3I Atlas has an exceptionally deep and narrow negative polarization branch. That may not sound like much, but it means that 3I Atlas is scattering light in such a way that has never been seen before for any other comet or asteroid in our solar system. This behavior sets it apart from even Borisov, which showed positive polarization of light and could place it in a distinct class of small planetary bodies that we know next to nothing about. To give some more context, particles in and around space objects, like dust or gas, can cause incoming light to scatter in specific directions. This is known as light polarization, and it can be measured by telescopes here on Earth. Experts look at the scattering plane, which is the line formed when looking from the observer to the comet to the Sun, and record whether the direction of polarization is perpendicular to the scattering plane, which is positive, or parallel to the scattering plane, which is negative. So, the deep and narrow negative polarization of light from 3I Atlas means that the light is being strongly polarized in a very localized, parallel direction to the scattering plane. This pattern of polarization is somewhat comparable to some trans-Neptunian objects and centaurs, but further research is needed to pin down exactly why this might be the case. If you thought the newsworthy observations of 3I Atlas were reserved for academics, you would be wrong. Science really is for everyone, and this next discovery proves why. From the 7th to the 8th of September, parts of the globe were treated to a stunning lunar eclipse, or blood moon, as it passed through the Earth's shadow. Naturally, this was a great opportunity for amateur astronomers to dust off their telescopes and have a look, but some space enthusiasts were not just looking at the moon. Michael Yeager and Gerald Remen were taking photos of the night sky over Namibia when they noticed our friend 3I Atlas, colored with a surprising yet beautiful green hue. Now, this finding has not been verified by scientists at the time of writing, but comets in our solar system can turn green when they begin to release diatomic carbon, which gets energized by sunlight and fluoresces near 518 nanometers. This behavior may be normal for other comets in our solar system, but as you will remember, 3I Atlas was recently found to be highly carbon depleted, so it should not really have much diatomic carbon to fluoresce. Maybe it is a sign that diatomic carbon production has ramped up in recent days, but again, you will need further research to confirm or deny this theory. Whatever the case, it is a beautiful image, and this latest mystery has captured the attention of amateur astronomers and scientists alike. At this point, there is still one major area of development in the news surrounding 3I Atlas that you have not touched on yet, but it is one I am sure you have heard about. The name Avi Loeb pops up a lot in the media coverage of this comet, and he has a lot to say about where or who it came from. Avi Loeb is a renowned astrophysicist and Harvard professor who has stirred up his fair share of controversy throughout his career. His most recent obsession with 3I Atlas has received mixed responses from his fellow scientists and the wider public. Back in July, Loeb was already publishing his comments on the discovery of 3I Atlas, and at first, it all seemed pretty astrophysical. One of the main points from this paper and from Loeb is that 3I Atlas is too large to be an asteroid. Early estimates of the comet's radius put it at around 10 kilometers. Loeb pointed out that this would give the comet a far greater mass than we would have thought possible. Given our current understanding of how much material there is in interstellar space, an object this large entering our solar system should be an extremely rare occurrence. In light of this argument, Loeb suggested that 3I Atlas may be smaller than we originally thought, but he also suggested a controversial alternative, that alien technology could be the explanation. Just days later, Loeb submitted another paper, along with two collaborators representing non-profit organizations for interstellar exploration. And the title of this paper is The Interstellar Object 3I Atlas Alien Technology. While Loeb's first paper only briefly floated the idea, this follow-up placed the alien speculation front and center. In it, the authors conducted an analysis of the astrodynamics of the comet, exploring whether it could be technological and possibly hostile. They referenced the dark forest resolution to the Fermi paradox. If you are not familiar, we have covered this in previous videos, but the Fermi paradox poses the question of why you have not found aliens yet, considering the size of the universe and the number of stars that share similarities with our sun. The dark forest idea suggests that perhaps aliens are out there, but are choosing to remain hidden, like prey would hide from a hunter. The authors stress that they are exploring this idea for educational purposes, and because it is fun to pursue, irrespective of its likely validity. So let us see what they had to say. Firstly, in this paper, Loeb still maintains that 3I Atlas is too large to be an asteroid. As Loeb and his colleagues should know, estimates for any newly discovered object are liable to change, especially as more independent measurements are taken and results are peer-reviewed. After all, the 10-kilometer value was estimated before you could properly measure 3I Atlas's coma, and as you now know, that coma is responsible for most of the reflectance you see. A press release from the Hubble team on the 7th of August said that 3I Atlas measured 5.6 kilometers across at most, but Loeb continues to use the outdated measurements in his alien hypothesis. In a Medium post on the 13th of August, Loeb directly mentions the Hubble images, but still bases his argument around the older estimates. My point is not that scientists should be banned from pursuing alternative lines of research, but they should at least make sure that the research uses credible data, especially for new discoveries like 3I Atlas, where the state of our knowledge is still a constant work in progress. As for Loeb's other points, well, they have been rebutted by other scientists, particularly in two papers by AKM Ihsanul Haq, a geoscientist working at Petronas University in Malaysia. He rebuffs Loeb's arguments for non-gravitational acceleration to achieve a non-coincidental flyby of Venus, Mars, and Jupiter, by referring to the most recent trajectory data for 3I Atlas, which can be explained far better with natural dynamics than engineered maneuvers. For many of Loeb's critics, this is a lesson against jumping to conclusions. As fun as it might be to cry aliens, you should at least wait for the dust to settle on each new discovery before you start looking for whether it could be a sign of intelligent extraterrestrial life. That way, you will be far more efficient at coordinating a response if and when the evidence truly points to an alien encounter. You have come to the end of our reunion with 3I Atlas, but as I have shown in this video, this research moves almost as fast as the comet itself, so you are by no means finished making new discoveries. On the 30th of October, the comet will reach perihelion around 1.4 astronomical units from the Sun, though sadly you will not be able to see it. At the time this video is released, it will be too close to the Sun to observe, but do not panic. It will re-emerge by early December, ready for a renewed bout of in-depth analysis. Missions that may be able to observe the comet include NASA's SOHO, SPHEREX and MAVEN, not to mention continued observations from Hubble, James Webb and the Gemini Observatory, so there will be plenty more to come. As 3I Atlas takes a bow and disappears behind the solar curtain, it leaves plenty of questions for us to ponder. How will its activity change as it reaches perihelion? Will it break apart? How long has it been traveling to get here? And can we trace its elusive origin? It is a race against time to answer these questions, but astronomers are showing no signs of slowing down, and I cannot wait to see what they discover next. Solving the mystery of Comet 3I Atlas is only possible by finding patterns in the data. It requires analyzing mountains of data, spotting subtle patterns, and testing ideas against the evidence. It might seem complex, but it is a skill set anyone can develop with help. There are online learning platforms with thousands of interactive lessons in math, science, data analysis, programming and AI, all created by experts from Stanford, MIT, Microsoft, and Google. They get you involved from the very beginning, then use hands-on practice to actively build your understanding. No wonder it is 6 times more effective than passively watching lectures. They have also added a bunch of new courses, like Thinking in Code or Probability and Chance. Each lesson is short, engaging, and designed to make daily learning a habit, so you can reach your goals faster. So why not give these platforms a go? You can get started for free, and some even offer a 20% discount off an annual premium subscription, which gives you unlimited daily access to everything on the platform. Well, today is the day, folks. Perihelion for 3 Atlas, as it is called. It is the weird interstellar object that is heading our way. Perihelion is its closest point to the Sun. That is what that means. Now, to be clear, this object will be behind the Sun to my understanding, you know, but I am no astronomer, so you will not be able to see it, but there are plenty of spacecraft that will be able to see it, and you will be able to get images of it and all of it. But why is NASA refusing to allow us to see these high-definition images? Why is NASA being so cagey about this thing? It is very bizarre. What is it? Is it just a comet, or is it some interstellar spacecraft? You do not know. Who knows? You do not. Why is NASA hiding all of this? We want to bring in Professor Simon Holland now, who is far more educated on this than I am. And Professor, I want you to treat me like I am a 5th grader today, because you know I hate all these people that pretend to know everything. I do not know everything about this at all, but I want you to educate us. So today is perihelion. First, can you talk about why this is so significant, and then we can get into all the why you are not seeing images and NASA, and what the EU is doing to maybe get some images. But what is perihelion, and why is this so important today? It is the closest it is going to get to the Sun, and of course when it comes around the other side, you will be able to see it again from Earth. But you are absolutely right. There are lots of satellites out there actually orbiting the Sun who are actually seeing it. Let us not forget that there are other countries with telescopes, as well as the US. Here in the EU, we have many satellites who are actually following it in telescopes, and you know it is an absolutely fascinating object. I think you cannot underestimate how brilliant it is that it has come into our solar system, and also how different it is, and it is this difference of its composition of its actual elements that make it up that is not like us. It is not like anything you have in our solar system. It is not made by our star. It has come from somewhere else, and it is behaving strangely and badly. It is not necessarily alien technology, but it is definitely extraterrestrial and not like us. You know it is an interstellar object. But Professor, when you say it is, sorry to interrupt you, when you say this is the key to, I mean, this is what is so intriguing to me and others, I think, is that when you say it is behaving badly or it is behaving differently, something out of the ordinary, how exactly is it behaving that you are not used to? Because it is made of weird stuff. I mean, you are used to every single comet that you see that comes towards the sun is trapped by the sun's gravity, a big gravity well. And this thing is moving so fast, it is not actually going to be trapped in our solar system, it is going to whiz right past because it is not from around here. So for example, a normal comet which is coming from our solar system, made of all the stuff that you and me and everything is made of, you know how they behave. They are mainly made up of water. So when they get near the sun, they evaporate and there is a big tail coming out the back. Now this crazy guy is probably made of different elements, and for example, it has had a tail coming out the front, and most of the gas coming out the back is probably a cyanide gas coming out of its metal structure. So when I say it is behaving badly, it is actually just behaving weirdly, and I think a lot of people are drawing conclusions from its weirdness. It does not mean that it is alien technology, it is just alien and not like us. Right, well, now that makes a lot of sense. Can you talk about like some of the images now? It passed by Mars just recently, and a lot of us in the United States were annoyed at NASA. Well, I know there is a government shutdown, etc. etc. You cannot release. You did manage to release low-res images, if I am not mistaken, but you could not release the high-res images that you know you have access to because of the spacecraft and other observation spacecraft on Mars that passed right by Mars. Can you talk about this? Yeah, I can. It was terrible. I mean, I was absolutely shocked. There were my little fingers going not to NASA, but directly to Jet Propulsion Lab, JPL, who are actually controlling satellites going round Mars, and you were expecting for a very close-up high-resolution image. The US, in that case, has much higher resolution cameras aboard their spacecraft than there are Chinese and EU satellites around Mars as well, but they were much lower resolution, and they were the only ones that were released, and to this day NASA through JPL have not released the high-resolution pictures. It does seem really strange. I know you have got this kind of closed down of the government, but come on. Non-government organizations, universities and people should be able to be free from this, and you should be able to get the actual images. I am shocked because that was a fantastic opportunity to get very close to this thing and actually, find out what it is made of and its size and how it is moving and its shape. But no, you are missing that. You are slightly struggling to get high-resolution pictures, and I find that very disappointing. Professor, in the EU, I know you guys are well, you are not in the middle of a government shutdown. The EU has its other major problems, totally separate from our mess that you have got here. But what are you guys doing differently to try to get some of these images of this that the United States is not being forthright with right now, just using EU assets? I mean, I think it is very disappointing. I mean, the astrophysics community is the one community in science that needs to and does share images and data. Other bits of science might keep it to their own country, but if you see something up there, you need to share it with Australia. You have to actually share astronomical data. And it is very disappointing that you are not getting probably some of the best assets from the United States that has seen it, especially on the Mars satellites. Yeah. I mean, the EU does not really have that kind of high-resolution camera stuff, but there is a lot of other people looking at it. I just heard today that it is now visible too, and it has been resolved by radar. This is not, not a picture, but actually made a three-dimensional radar image of it. It is spherical. It is moving incredibly fast. The amount of energy it has is incredible. I am so pleased that it did not hit anything. I was very concerned that when it went between Jupiter and Mars is where all our asteroids are, and it could have played, a game of billiards with things. If it hit anything, it would have upset the apple cart because of its speed. How big are you talking here? So because I think a lot of people, they have been sharing images of it looking sort of like Oumuamua, which is like a long cylinder almost, but this is spherical. How big is this sphere? I cannot remember the exact size, but I do know the one statistic is it is bigger than both Oumuamua and Borisov, the other interstellar object. You have seen 3. This is why it is 3I Atlas, and it is very heavy, very big. Somebody has worked out the actual mass. I do not have it in my head right now, but it is much bigger than the other 2. And I think it is spherical. You are absolutely right. So are you talking asteroid size here? Are you talking, moon size? Oh no, large asteroid size. But that is brilliant that you raised that, because it was actually my friends at Hawaii at the university who run the Atlas project, and why it is called 3I Atlas is it is the third object. It is interstellar, and it was found by these Atlas people, and Atlas was funded by NASA to find, as you have just said, asteroids. Almost every asteroid over a kilometer, about just under a mile in diameter, has already been tracked, but the ones that are 999 meters were not tracked. So Atlas, that is their mission, is to find the smaller ones which could still be country or city killers, and because they have this incredible way of scanning the night sky in places other people do not look. They have got 4 telescopes in the northern hemisphere and 2 in the southern hemisphere, and they can map the whole world. They do it by joining dots. Every morning they come to work. They take out all the stars which are set and look for anything that moves, and anything that moves they can work out an orbit. And that is how they found the 3I object that was named after them, Atlas, and it was incredibly good that they found it. It was right in the middle of the Milky Way where nobody else was looking, but they saw it because it was moving. And that is what is very clever about the Atlas project. Good on them. That was very clever. One thing we covered here the other day on the show, Professor, is THAR. NASA has basically launched their Earth Defense Force, or went on basically, you could call it high alert among all of these astronomers, and it raised a lot of eyebrows. What is so concerning now to NASA during a government shutdown? They cannot give us high-definition images, but they can certainly go on this. They can go on this alert to bring people an awareness about what is going on. I do not know that they think that they could stop this if it was a threat to their threat to Earth or something else large, maybe a psychological operation. I do not know. What do you make of their moves recently? I do not know. But what I do know is that the Atlas team needs to give points out of 10 whether an object is trivial or non-trivial, whether it is a country killer or a city killer. And that data goes all the way, goes through to Boston to the Minor Planet Center, and they can work out from very little orbit data if it is going to impact Earth in the future. And then, of course, if it is going to impact Earth, the 2 big things you can do: warn people to get out of the way. Certainly, if it is a localized event, be hard for a country, but for a city could maybe. And of course now you have the possibility, if you have enough time, to actually divert an object by kinetic impact and actually slightly move it away. Move it just a little bit 10 years before it hits Earth. It would miss Earth by miles. You have a lot of great films and a lot of great videos on. I have been watching you for quite a while, so I am thrilled that you are on the show. You said at the outset, you really do not believe this is alien technology, or of alien origin, but you have quite a history of covering alien-related technologies, and Salvata pies and others, and UFO patents, and things like that, maybe from reverse engineering of craft. So if people wanted to go down that rabbit hole, what would you say to them about some of the patents that might exist about this reverse engineering of alien technology that you have in our possession that I am 100% certain, I would bet my life on it, that our government is using and has used, and as is with all these black project off-the-books projects? Oh, what a fantastic question, and thank you very much. All right, so first of all, aliens and UAPs are real, and they are also global. They are everywhere. There is just as much in Namibia as there are in Nebraska. So, yeah, no. Many governments throughout the world have actually officially said that UFOs and non-human intelligence exist here on this planet. And as you clearly say, the more information you have about them, it is possible to use the weaponization of UAP is the term. You look at those so-called 5 observables because those are defense companies who are actually studying how they move, and could we match them with our technology? Have they done that? Almost definitely, I would say. I think ever since World War II, physics, killing people with advanced physics, is how we run wars. And of course, we want to hit people with things that they do not know. So if we can get non-human intelligence technology and actually turn it into weapon systems, your enemy will not know what hit them. The question is, what have we in the West and NATO actually got, and what have our enemies got flying in the sky? It is hard to know. I think a lot of the things that people see could well be human technology which is secret, and that is what really interests me. I know non-human intelligence lives on this Earth. People see it all the time. UAPs are real, but what have you really done to turn it into some piece of technology that you can fly around, And that is my quest. It is a good thing to try and investigate, right? No, I think you are right about that. I think probably 90, maybe 95% of everything you are seeing in the night sky that is questionable is our own. But that technology came from somewhere else that you have reverse engineered and now are using it for our own purposes. I have spoken to plenty of whistleblowers who have been and witnessed this up close, and personally who have been a part of the secret space program, who have been to the moon base, for instance. Members of the United States Air Force who have been to the moon base. Right, yeah, hopefully people are waking up. I think you are dead right. There are multiple moon bases. I mean, the moon is the high frontier. Think about it. You have got something not that far away from Earth looking at Earth constantly. Do you think that we do not use the moon? Do you like we would not use that as the perfect observatory? Yes. And what is also hilarious, it is perfect for lots of things. It is, military observatory and communication. A friend of mine was applying for a massive science foundation budget, and he was openly told just last year that the budget has been enclosed because the US is putting Wi-Fi and the internet onto the moon. Why would you want the internet on the moon? I asked, there is nobody there. So you can stream Netflix on the moon right now. Well, I remember hearing a few years ago how fast the internet was on the space shuttle, and it was like 1,000 times faster than you had on Earth. Like, it is just, unbelievable. So yeah, the moon base thing is particularly interesting to me, and the individuals who have been there, or the multiple moon bases that of course you know about. Professor, I would love to have you back on. I know it is after 10 o'clock in the evening there in France right now. It is, so thank you so much for staying up for us. I really appreciate it. And our whole staff is thrilled that you are here, so thank you so much. Great to have you on the show, and we look forward to talking with you again soon. Yeah, and let us keep our eyes on the skies and watch that 3 Atlas. Yes, absolutely. And NASA, please release some HD images. You have them. Professor, great to see you. Thank you so much. All eyes are on 3I Atlas right now for one reason. In the space of 48 hours, telescopes worldwide pivoted to a third interstellar visitor, triggered by a 1.4 magnitude brightness jump amateur astronomers caught and professionals could not explain. Mars orbiters burned precious fuel for unscheduled maneuvers. Deep Space Network antennas abandoned regular missions. And the International Astronomical Union convened an emergency session just as scientists abruptly went silent online. Never before have so many independent anomalies converged so quickly on a single object. Is it raw cosmic coincidence, technical error, or evidence of something no one expected? This is a hypothetical scenario. No unprecedented events are currently occurring with 3I Atlas. It is a speculative analysis of a coordinated global response. The clock is ticking. Here is what the world would do next. Maria Schulz, an amateur astronomer in Jena, Germany, spent her night tracking 3I Atlas with a 12-inch telescope. At 0114 Coordinated Universal Time, her photometry software flagged something wrong. A sudden 1.4 magnitude spike in brightness over just 6 minutes. That is a 4-fold increase in light, far beyond what a comet or asteroid usually delivers in such a short window. Schulz checked her calibration stars, reran her data, and posted the raw light curve to a global amateur forum, asking if anyone else saw the same. Within half an hour, observers in New Zealand and Arizona uploaded matching results. The pattern was clear: a sharp, non-periodic jump, no sign of gradual buildup or decay, and critically, no return to baseline. In comet science, brightness changes usually trace the object's rotation. As a nucleus spins, fresh ice or dust comes into sunlight, then fades away, creating a predictable rhythmic curve. But Schulz's plot looked nothing like a rotation model. The spike did not repeat. There was no periodicity, no echo in the following hours. Just a step function, flat, then a vertical leap, then flat again at the new level. For comparison, the famous 17P Holmes outburst in 2007 produced a 14-magnitude surge, but that took nearly 2 days, not minutes. Even Oumuamua, the first interstellar visitor, never showed anything like this. Photometry basics demand skepticism. Small telescopes can be fooled by passing clouds, camera glitches, or misaligned tracking. But Schulz's data was clean. Multiple exposures, consistent comparison stars, and no atmospheric distortion. When 3 other amateurs using different equipment confirmed the same curve, the odds of instrument error shrank. Professional survey telescopes, including Atlas and Pan-STARS, quickly checked their own archives. Their automated logs showed a matching jump timestamp to the minute. A 1.4 magnitude leap in 6 minutes with no periodicity leaves few natural explanations. Outgassing can cause sudden brightening, but not this fast or this cleanly. Fragmentation events produce debris clouds, but those usually show a gradual ramp-up, not a vertical wall on the graph. The only comparable event, Holmes, had a much slower rise, and even then the cause was a rare shell fracture, not a routine process. Schultz's post spread across social media, drawing the attention of professional astronomers who monitor these forums for early warnings. The raw data, now confirmed by 4 independent observers, presented a technical mystery. An interstellar object behaving in a way no model predicted. The light curve, simple and stark, became the first undeniable anomaly. It was enough to trigger the next phase, a global relay of the data, and a scramble to understand what could possibly cause such a leap. This is a hypothetical scenario. No unprecedented events are currently occurring. NG with 3I Atlas. It is a speculative analysis of a coordinated global response. Within minutes of Schultz's post, the rhythm of the night changed. Amateur astronomers across continents refreshed their dashboards, watching as the 3I Atlas thread rocketed to the top of every major observing forum. A timestamped light curve from Oakland, posted at 0121 Coordinated Universal Time, matched Schultz's Spike 2 within a fraction of a minute. In Tucson, a group streaming live photometry saw their chat explode as viewers noticed the same vertical jump in real time. Screenshots of the anomaly flooded Discord servers and Telegram groups, each carrying fresh coordinates and exposure logs. The story did not stay within the amateur community for long. By 0200 Coordinated Universal Time, the largest citizen science aggregator, Skywatch Collective, displayed a flashing alert on its homepage. Non-periodic 1.4 magnitude jump in 3I Atlas confirmed by 4 continents. Their distributed dashboard lit up with green check marks as new observers uploaded raw FITS files and unfiltered plots. The site's analytics showed a 10-fold surge in traffic, peaking at over 120,000 simultaneous viewers, shattering its previous record set during the 2024 Perseid meteor storm. Hashtags like #AtlasAnomaly and #InterstellarSpike trended on X and Mastodon, drawing in not just astronomers, but science journalists and data sleuths. Live streams switched from routine sky tour to focused coverage of the unfolding event, some staying online for hours as new data points rolled in. Global queue times for robotic telescope networks like Lars Kumbers and iTelescope ballooned from minutes to hours as users scrambled to book slots on 3I Atlas. Every new confirmation added weight. A Hungarian observer uploaded a synchronized video overlaying Schultz's and his own light curves, their spikes lining up with uncanny precision. In Sao Paulo, an undergraduate team posted a pre-processed data set with calibration notes, inviting anyone to check for artifacts. The crowdsourced nature of the response meant errors were caught quickly, but none appeared. The anomaly held up under every test. By sunrise in Europe, a mosaic of independent confirmations stretched from amateur backyards to university observatories. The common thread, each data set, regardless of equipment or hemisphere, showed the same abrupt, persistent brightness leap. The sheer volume of corroboration, all time-stamped and public, left little room for doubt. Within 12 hours, the world's largest distributed science platforms had archived terabytes of raw photometry, generated thousands of reposts, and pushed the anomaly into trending status across multiple languages. This was not just a blip. It was a global relay with every node in the network amplifying the urgency. The data torrent and social propagation made it impossible for professional astronomers to ignore. The grassroots campaign, driven by speed and transparency, set the stage for the next step. Institutional action on a worldwide scale. This is a hypothetical scenario. No unprecedented events are currently occurring with 3I Atlas. It is a speculative analysis of a coordinated global response. At the Jet Propulsion Laboratory's Deep Space Operations Center, the overnight shift usually runs like clockwork. The Deep Space Network's global antennas, California, Madrid, Canberra, cycle through a schedule set months in advance, every minute allotted to Mars rovers, Voyager, and planetary probes. Tonight, the script is torn up. At 0307 Coordinated Universal Time, an urgent alert lands in the Deep Space Network scheduling channel. Request immediate radar tracking of 3I Atlas justified by a verified non-periodic brightness anomaly. The message is tagged as an emergency. Within 5 minutes, the operations manager convenes a digital meeting. Mission leads, schedulers, and NASA headquarters representatives. The stakes are spelled out. To redirect antenna time for radar pings on 3I Atlas, at least 22 hours of Mars rover telemetry will be lost. Data from Perseverance, Curiosity, and the Maven orbiter will stack up in onboard memory, risking overflow. The last time a science target forced this kind of override, it was an asteroid flyby with a potential for impact. The boardroom clock ticks. Each mission lead argues their case. Mars operations warn that missing a downlink window could mean permanent loss of atmospheric readings or surface images. Voyager's team reminds everyone that the 46-year-old spacecraft cannot store data for long, but the science leads for 3I Atlas point to the anomaly. A four-fold brightness jump independently confirmed with no natural explanation. The window for radar observation is closing fast. At 0324 Coordinated Universal Time, a vote is called. 7. Minutes later, the result is unanimous. Override approved. The schedule is rewritten live. The Deep Space Network's 70-meter dishes pivot away from Mars, locking onto the coordinates of 3I Atlas. Engineers initiate the new sequence while mission teams scramble to replan their data dumps. The decision is logged, time-stamped, and broadcast to every affected project. For the next 22 hours, the world's most valuable deep space antennas will chase a single unexplained object, accepting the cost of lost science elsewhere. The institutional domino has fallen. Every minute of antenna time now carries the weight of something never seen before. This is a hypothetical scenario. No unprecedented events are currently occurring with 3I Atlas. It is a speculative analysis of a coordinated global response. The Mars Orbiter Operations team faces a decision that cannot be undone. For most missions, every gram of hydrazine is measured and budgeted years in advance with strict reserves for emergencies and end-of-life disposal burns. But this morning, the Flight Dynamics console shows a new command in the queue. A Delta V maneuver of 1.2 meters per second set to begin at 0515 Coordinated Universal Time. The justification: extend the orbiter's view of 3I Atlas by 2 extra hours, catching whatever unfolds after the brightness anomaly. The math is simple but sobering. To achieve the new pointing and maintain stability, the spacecraft must fire its thrusters for a full 2 minutes, consuming just over 5 kilograms of hydrazine. That may sound trivial, but for a mission already years past its prime, it is a tenth of the remaining fuel, months of margin gone in a single morning. Engineers trade spreadsheets and risk assessments, running simulations to confirm the orbiter will still have enough propellant for safe disposal at mission's end. The science team argues the case. No other assets can provide this geometry, and the chance to catch a non-repeating event from Mars orbit may never come again. The program manager signs off with a note that this is a one-way door. Once the fuel is burned, the orbiter's operational life is permanently shortened. The maneuver proceeds as scheduled. Telemetry shows the thrusters firing, the attitude shifting, the instruments coming online for an unplanned high-priority campaign. In the mission log, the fuel expenditure is recorded in red, flagged as an exceptional event. For the engineers, it is a hard-earned sacrifice, a piece of the mission's future, traded for a shot at understanding a mystery that will not wait. The irreversible commitment is made, and the cost is real. Measured in kilograms, seconds, and the silent approval of those who keep the spacecraft flying. This is a hypothetical scenario. No unprecedented events are currently occurring with 3I Atlas. It is a speculative analysis of a coordinated global response. At the Cerro Paranal control room, the night's observing roster is in chaos. The European Southern Observatory's flagship, the Very Large Telescope, was set to chase a rare exoplanet transit. Months of planning now wiped from the board. The override order comes through at 0610 Coordinated Universal Time. Drop all scheduled targets. Pivot every instrument to 3I Atlas. 2 minutes later, Gemini North in Hawaii receives a parallel directive. The principal investigator's protest is logged, but the override stands. A third flagship, China's fast radio telescope, interrupts a pulsar timing campaign, its array slewing toward the coordinates relayed from the amateur network. These decisions do not happen in isolation. Each observatory's allocation committee, staffed by astronomers from half a dozen countries, scrambles into emergency session. The cost is clear. Hundreds of hours of lost science, grant-funded projects delayed, and international collaborations thrown into uncertainty. The override protocol is rarely invoked. Once for Shoemaker Levy 9, again for Oumuamua. Never for a comet already ruled out as a threat to Earth. Tonight, the justification is different. Not planetary defense, but a consensus that something fundamentally new may be unfolding. 2-minute override windows become the new currency. Schedulers juggle requests from Japan, South Africa, and Chile, trading precious time in a relay across longitudes. The Keck Observatory's night manager negotiates with colleagues in La Palma to hand off the target at dawn. The International Astronomical Union's coordination channel fills with real-time updates. Each observatory logging its handover, exposure times, and instrument settings. For the first time in memory, national boundaries and institutional rivalries give way to a single shared goal: capture every possible photon from an object that defies explanation. The pain is collective. Researchers whose proposals are bumped vent their frustration in private threads, but the consensus holds. Allocation boards, usually divided by competition, now act as a global committee. Every lost hour is a deliberate sacrifice recorded in the official logs as evidence that the world's leading facilities have set aside their own ambitions to chase a mystery that belongs to all of science. This is a hypothetical scenario. No unprecedented events are currently occurring with 3I Atlas. It is a speculative analysis of a coordinated global response. At 7 hours and 30 minutes in the morning, Coordinated Universal Time, a secure channel lit up with a summons. The International Astronomical Union's Executive Committee was to convene in emergency session, bypassing the planned agenda and triggering a rarely used statute. 11 voting members joined the encrypted call: president, vice presidents, secretaries, each representing a continent's worth of scientific infrastructure. The chair confirmed quorum. 8 present, 2 remote, 1 abstention. The agenda was stark: authorize global asset coordination for 3I Atlas or risk losing the window for unprecedented observations. Debate was brisk but weighted. Some pressed for immediate open data sharing. Others warned of premature conclusions and institutional overreach. The statutes required an absolute majority, more than half of votes cast. When the roll call reached its end, the tally stood at 8 in favor, 2 opposed, a formal mandate. The president read the motion aloud. All member observatories were advised to prioritize 3I Atlas, share data in real time, and withhold public statements until verification. The decision was logged, time-stamped, and circulated as official guidance. With that, the world's largest scientific union had thrown its authority behind a single urgent cause, an act reserved for moments when the regular machinery of science is not enough. This is a hypothetical scenario. No unprecedented events are currently occurring with 3I Atlas. It is a speculative analysis of a coordinated global response. The usual chatter from professional astronomers vanished in the first hours after the International Astronomical Union's emergency directive. Timelines and Mastodon feeds that had been crowded with comet updates went quiet. Social media analytics tracked a 70% drop in 3I Atlas-related posts from verified researchers. Preprint servers, often the first place for raw data and speculative models, saw no new uploads tagged to the object. Even private group chats, normally busy with cross-institutional banter, slowed to a trickle. For those watching, the silence was a signal as clear as any press release. In past discovery cycles, excitement spilled out in real time. Plots, spectra, even inside jokes about late-night coffee. Now only a handful of automated telescope logs and institutional retweets broke the pattern. The hush did not just blanket a few big names, it stretched across continents and specialties. Graduate students, postdocs, senior faculty, everyone who had been part of the global relay now held back. The effect was palpable, a collective holding of breath as if the scientific community itself had gone off the air. Radar teams at Goldstone and Arecibo began logging trajectory data every hour, watching for any sign of non-gravitational motion. Within 3 observation cycles, the numbers refused to settle. The calculated path showed a persistent acceleration 4 times higher than predicted from solar heating or known outgassing. Each new data point tightened the error bars, but the deviation remained. Simultaneously, the James Webb Space Telescope's mid-infrared spectrometer reported a thermal plateau. The surface temperature held steady at 30 Kelvin above the expected value for a body at this distance from the Sun. No known dust or gas process could sustain that much excess heat. Infrared specialists double-checked their calibrations, ruling out background contamination and instrument drift. Meanwhile, the Fermi and Swift gamma-ray teams flagged a burst of high-energy photons originating from 3I Atlas's coordinates. The signal was faint, but statistically significant. No other solar system object had ever triggered targeted gamma scans from multiple space telescopes. Each anomaly on its own could be dismissed as a glitch or rare event. Together, confirmed across independent platforms, they formed a stack of evidence that defied coincidence. The world's most advanced sensors working in parallel now pointed to a single urgent conclusion. Something extraordinary was unfolding, and no one could yet explain it. This is a hypothetical scenario. No unprecedented events are currently occurring with 3I Atlas. It is a speculative analysis of a coordinated global response. Within just 48 hours, observatories worldwide hypothetically redirected resources to 3I Atlas, resulting in a 70% drop in public communications from professional astronomers and an 8-2 emergency vote by the International Astronomical Union. The costly decisions: 22 hours of deep space network time cancelled, 5 kilograms of Mars orbiter fuel spent, 3 flagship observatories bumped, underscore the gravity of simultaneous independently confirmed anomalies, a 1.4 magnitude brightness jump, trajectory deviations, and a 30 Kelvin thermal excess. Yet even as data converged, the underlying cause remained unverified, and much of the analysis stayed behind institutional walls. Historically, such rapid, coordinated responses documented during events like the Shoemaker, Levy 9 impacts, and Oumuamua have marked moments when scientific understanding stood on the edge of change. This scenario shows when multiple systems respond in unison, something significant is unfolding, even if the final answers are not yet public. This is a hypothetical scenario. No unprecedented events are currently occurring with 3I Atlas. It is a speculative analysis of a coordinated global response. It is difficult for us humans to fully comprehend the enormity of space. You are comfortable in our own cosmic neighborhood, the solar system, and are used to familiar faces like Jupiter, Mars, and of course, Earth. But out there, over 18 billion kilometers away from the Sun and beyond the heliopause, is the cold oblivion of interstellar space. The 2 Voyager probes are the only man-made objects ever to cross this threshold to this day. And until recently, only 2 known objects have ever made the opposite journey, passing from interstellar space into the solar system. These were the famous Oumuamua in 2017 and Borisov in 2019, which brought with them the thrill and perhaps even fear of being visited by something from the depths of space that humans cannot hope to reach in our lifetimes. In the 6 years since these visits, you have been enjoying some respite, but a recent observation has forced us to sit up and pay attention once more. You are watching as we explore all there is to know about NASA's latest observations of Comet 3I Atlas, the 3rd interstellar object ever observed, which will make its closest approach to 3I Atlas has had a few different names in the short time you have been aware of it, but recent revelations about where this object came from and where it is heading turned this otherwise indistinguishable space rock into something worth taking note of. On the 1st of July this year, the NASA-funded Atlas Survey Telescope was performing its usual task of scanning the skies above for moving objects. The Atlas Project, or Asteroid Terrestrial Impact Last Alert System, consists of 4 telescopes across Chile, South Africa, and Hawaii. These telescopes each take around 800 images every night. And at the time of writing, they have registered 1,212 near-Earth objects that will pass within 1.3 astronomical units of our planet at perihelion. But on this particular night, the telescope in Rio Hurtado, Chile, reported some newsworthy observations. The Atlas telescopes are rather unique for their ability to survey the galactic plane, the bright disk-shaped region of our galaxy where most of its mass lies. See, other surveys like PAN-STARRS and the Catalina Sky Survey are often too sensitive to photograph this area without facing overexposure, so they tend to avoid it altogether. From the direction of the Sagittarius constellation, the Atlas telescope took 4 30-second survey images and found an object that was making a beeline towards our solar system. The object was initially named a 11PL3Z and quickly caught the attention of the Minor Planet Center in Cambridge, Massachusetts. As the designated authority in charge of labeling and tracking minor bodies in the solar system, the MPC quickly put out an electronic circular about this new visitor, detailing all of its previous observations and providing information about its trajectory. In doing so, astronomers realized that in fact this object was no stranger to us. As it turned out, the Zwicky Transient Facility in California and the other 3 Atlas telescopes had all made pre-discovery observations of this object dating back as far as the 14th of June. With all of this data, the MPC deduced that the object had a hyperbolic and highly eccentric orbit, so much so that it had originated from interstellar space. This realization earned the object the name of 3 Atlas, as it is the 3rd interstellar object to infiltrate our solar system. At first, the MPC could not be certain whether this object was an asteroid or a comet until the combined data revealed that it had a coma, a diffused halo of dust and gas produced when ice is exposed to solar radiation and sublimates. This feature is far more typical of comets, which gave this object yet another name, see 2025 N1. The MPC has called for additional observations of this comet to help constrain its trajectory, so you can expect a flurry of new data in the upcoming months, and astronomers are naturally very excited. Michelle Bannister, an astronomer at the University of Canterbury in New Zealand, explained that working on the 2 previous visits from interstellar objects were transformational opportunities science-wise. So, it is likely that this visitor will encourage the same. But what do you already know about this latest interstellar visitor? And what do scientists hope it can teach us in the near future? Firstly, do not worry, because this comet will pose no threat to Earth. At its closest approach to our planet, it will still be around 1.6 astronomical units away. That is over 600 times further than the Moon is from Earth. So, since you are able to watch from a safe distance, what kind of journey will this comet take? As I mentioned, 3 Atlas has a highly eccentric orbit, currently measuring at an E-value of around 6. For reference, an eccentricity of 0 represents a perfect circle, and anything above 1 is great enough for the object to escape the gravitational pull of the body it is orbiting and will move more freely through space. So with an eccentricity of 6, this comet has one of the most extreme hyperbolic orbits yet measured, which may explain how it is able to travel so far through space to reach us. What is more surprising is the speed with which this comet is traveling. Its current incoming velocity is a rapid 58 kilometers per second. That is like running the length of 580 football pitches every second. This breakneck speed makes 3 Atlas the fastest traveling interstellar comet you have ever seen. Oumuamua and Borisov had velocities of just 26 and 32 kilometers per second, respectively, resulting from their differently shaped orbits. With such a rapid approach, astronomers were keen to work out exactly where 3 Atlas was headed. The current orbit is heliocentric, or centered around the Sun, meaning it is possible for astronomers to infer its incoming trajectory before it reaches us. On its closest approach to the Sun on the 30th of October, the comet will be at a distance of 1.4 astronomical units, placing it just inside the orbit of Mars. In this graph of the comet's orbit, you can see the asymptotic shape of its approach as it veers past Mars and shoots back out into space. As the graph shows, 3I Atlas will not pass as close to the Sun as the famous Oumuamua did in 2017 and will follow a trajectory more similar to Borisov's. Once the interstellar nature of this comet was clear, astronomers employed the use of other globally distributed telescopes to better understand it. In particular, the telescopes from Lars Kumba's observatory are purpose-built to observe transient astronomical events, which can include events like comet outbursts and other changes in brightness. Using two 0.36-meter LCO telescopes based in Hawaii, astronomers scheduled a 1-hour observation sequence for 3 Atlas. Their goal was to identify a light curve for the comet and to see whether it exhibited any rotational variability. Rotational variability means any kind of variation in brightness caused by the comet spinning on its rotational axis. Maybe it has an irregular shape and reflects light differently across its surface, or it has active regions that appear brighter to us when they face towards Earth. But by monitoring the changes in brightness over time, astronomers can identify repeating patterns which show that the comet has completed one cycle of rotation. Using the LCO telescopes, astronomers identified that the comet has a rotation period of around 29 hours. Though like much of the information about 3 Atlas, further observations are needed to constrain this. In a surprise to astronomers, 3I Atlas had a much flatter light curve than Oumuamua and exhibited only 0.2 magnitude of brightness variation throughout the 29-hour period. But despite this minimal variation in brightness, 3I Atlas is bright. In fact, it is the brightest interstellar object you have seen yet. This comet was pretty faint right up until the end of May this year, when it reached a magnitude of around 20. But between then and the comet's discovery by Atlas, it has promptly increased to between 17.7 and 17.8 magnitude in the Atlas O band, which records light wavelengths between 560 and 820 nanometers. Not only is the comet bright, but it is large. From assumed albedo values, the diameter of its nucleus is estimated at 10 kilometers. This makes it an order of magnitude larger than Oumuamua and even larger than Borisov, which measured between 1 to 2 kilometers in diameter. Further observations have also revealed that 3I Atlas shows faint levels of activity. As I mentioned, the comet has a marginal coma, which constitutes the fuzzy glowing halo of dust and gas that is produced when a cometary ice sublimates upon exposure to the sun. You can make it out in the center of this image shown here as a diffused circle around the nucleus. The image is tracking the moving comet, which is why the surrounding stars appear blurred. But as well as a coma, 3I Atlas has a tail. The MPC reported a tail spanning 3 arcseconds across the sky at an angle of around 280 degrees. This is pretty short, so the tail is often lost amongst the coma in images of the comet. As with many modern scientific discoveries, the advances in technology and communication mean that people from around the world can get in on the excitement. And that is exactly what is happening for 3I Atlas. Amateur astronomers and experts alike are contributing their own observations of the comet, so our state of knowledge is constantly being updated. For example, the Astronomer's Telegram is a forum for space enthusiasts to post their findings and is being updated daily with new revelations. Miguel Alarcon and colleagues have helped to constrain the tail measurements for the 3I Atlas, reporting that it extends across more than 25,000 kilometers. From this post and others, you can see some really exciting images of our new visitor. Just look at these. You have covered brightness, rotation, and activity on the comet, but what about its surface? Well, in this respect, 3I Atlas is similar to its predecessors. Just like Oumuamua and Borisov, 3I Atlas is significantly redder than the Sun and slightly redder than D-type asteroids like those from the outer asteroid belt. Since it is active, some of this reflected light must be coming from 3I Atlas's coma. The same was observed for Borisov, where the reflectance of the coma was drowning out the signal from the nucleus itself. You should be able to confirm this as the comet gets closer to us and new measurements can be made. For example, back in 2020, astronomers found that Borisov was producing dust at a rate of 50 kilograms per second, which helped to explain the drowned nucleus signal. Finally, the discovery of 3 Atlas has allowed astronomers to make another estimate for just how many interstellar objects there are out there. In a paper published shortly after the comet's discovery, scientists inferred a density of just 0.001 interstellar objects per cubic astronomical unit of space. That is far smaller than the previous estimates made when we discovered Oumuamua and Borisov. This density value is based on the fact that Atlas has been scanning our skies for the past 3 years and has only found one interstellar object so far. But of course, the density is liable to change and depends on many other factors. It could be that Atlas has let some objects smaller than 3 Atlas pass by undetected, or that there is a particular signal emitted by these objects that it fails to detect. You are not really sure, but estimates like these are no less useful to us, and we should try to update them whenever you are given the opportunity. So you have explored the information that you have managed to gather about this comet so far. As you have seen, science is anything but stagnant, especially when there is a brand new toy to play with. So what are you hoping to learn from this comet in the near future? And how can you learn from our previous interstellar visitors? Luckily for astronomers studying 3I Atlas, there are two fairly recent case studies to draw from. We have covered both Borisov and Oumuamua before, so definitely check out our previous videos if you have not already for everything you need to know. You have already discussed some of the similarities and differences between these objects, but how can these comparisons be explained, and what do they tell us about the origins of these visitors? You have touched on one of the major differences already, and that is that 3I Atlas appears to be less active than Borisov was. 2I Borisov displayed significant cometary activity as its dust coma increased in size by around 1% per day, which indicated that it had been active for around 100 days prior to its first observations. It also had a longer tail spanning 140,000 kilometers into space. Now it could be that 3I Atlas has not been exposed to the sun enough to begin water ice sublimation, which would raise activity levels, but Borisov entered a period of strong activity when it was still 4.5 astronomical units away from the sun, and 3 Atlas is already much closer than that. So this looks unlikely. Regardless, Oumuamua did not exhibit high activity levels either. It was a dense, rocky body with no ice to sublimate in the glare of the sun, and it had no coma or tail. Astronomers are still trying to explain this lack of activity too. This day, with recent hypotheses that it may have been outgassing volatiles with a low level of dust production, so it was not picked up in the observations. But 3 Atlas does have a coma, so this explanation is not a one-size-fits-all for both interstellar objects. With such differing compositions and activity levels, what does this tell us about the origins of interstellar objects? Well, this is still a major subject of scientific exploration. The famous oblong shape of Oumuamua generated a buzz around its origins, and theories emerged that it may be a primordial object shaped by tidal forces, or the fragment of a planet, or the aggregation of several smaller objects. Borisov also caused speculation of its own, as its composition was different from those typically seen in solar system comets. It had a higher abundance of hypervolatile carbon monoxide relative to water, suggesting that it may have formed in a carbon-rich environment. In line with this observation, it was suggested that Borisov formed in a red dwarf star system with cooler average temperatures, cool enough for carbon monoxide to condense and be incorporated into the comet. At the moment, it is probably still too soon to say what you will be able to infer about 3I Atlas's origins, but it is active like Borisov, and as it starts to be heated by our sun, perhaps you will detect similar levels of carbon monoxide, hinting at a shared interstellar origin. Speculation aside, it is clear that 3I Atlas is a unique interstellar visitor worthy of our close attention. Wherever it may be comparable to Borisov or Oumuamua, 3I Atlas has other characteristics that place it in a different class of object altogether. As a result, you can view this comet as an exciting opportunity for new discoveries and eagerly anticipate the scientific insights it may reveal. After all, the estimated density for interstellar objects is low, so who knows how long you may have to wait to be visited again. Now that you have learned a bit about 3I Atlas, it is over to you. You can keep an eye out for this comet using ground-based telescopes from around September until it disappears behind the sun. After the 30th of October perihelion, the comet will re-emerge from behind the sun in early December, ready for another round of viewing from Earth. But if you do not have a telescope, do not worry. You can still get involved in the comet action, as the JPL Horizons website has a handy tool to track its position in space. When I checked back on the 4th of July, this was its heliocentric position. So why not check for yourself and see how far it has traveled in the time it took us to release this video? What do you think this object is, and what does its trajectory reveal about its possible origins? Let me know what you find in the comments. In the meantime, I cannot wait to see what else you can learn from this plucky interstellar traveler. It has come an awfully long way, beating the odds to reach us, and I am sure it. Thanks for watching. Making this video required some long-term planning and work, which we were only able to do thanks to the consistency and sustainability of your memberships. A huge thank you to everyone who has signed up. And if you would like us to make more videos like this, you can join with the link down below. When you join, you will be able to watch the whole video ad-free, see your name in the credits, and submit questions to our team. There is a very strange object flying past our sun. You do not exactly know what this thing is or what it is doing. You cannot even see it anymore. But you have been watching this object very closely for months. You have given it a name, 3I Atlas, and you have given it a title, Interstellar Comet. There is a lot that you know about this new visitor to our solar system. In just 4 months, there have been nearly 100 research papers published on 3I Atlas, and there is plenty of other information out there that does not appear on the official record. Some of it can sound pretty insane. So today you are going to cut through the noise, and you are getting to the bottom of everything you actually need to know about 3 Atlas. Let us talk about the journey of this interstellar object. Right now 3I Atlas is making its closest approach to the Sun. You call this phase perihelion, and the peak occurs on the 29th of October when the object will pass within about 210 million kilometers of our star. Although in space, you typically use a larger form of measurement, that is the astronomical unit, or AU. 1 AU represents the average distance between the Earth and the Sun, which helps us to bring a familiar sense of scale to the vastness of the solar system. So the perihelion of 3I Atlas occurs at 1.4 astronomical units away from the Sun, which means it does not actually get that close. It is somewhere just inside the orbit of Mars, but this will be the T. We have peak activity for 3I Atlas. This is the hottest that it will get, which means that a lot of material from the surface of the object is going to get blasted out into space. Now, that is normal for a comet. You call this process sublimation. It is what happens when a solid material transitions directly into a gas because there is no liquid in the vacuum of space. And sublimation is what gives a comet its distinct look with a fuzzy halo and a long tail. The halo is made of all the gas and dust being ejected from the hard surface of the object. It is technically known as the coma. The tail is created by solar wind. That is a name for the waves of radiation that constantly flow from the surface of the Sun. This wind blows back all of the lightest bits of dust and gas from the coma and pushes it away from the comet. It is a spectacular piece of cosmic ballet. And unfortunately, you do not get to see this happening to 3 Atlas as it flies through its peak exposure to the Sun because you are on the wrong side. Call it fate or call it something else. Our view of the perihelion is completely blocked out by the glare of the Sun. Okay, so you know where 3I Atlas is right now, and you have a pretty good idea of what it is doing. So while you wait for it to reappear on the other side, that gives us an opportunity to investigate how it got here in the first place. And this is a deeply fascinating story. You have been tracking 3I Atlas since July of 2025. It was officially spotted by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is actually a bunch of telescopes all around the world in places like Hawaii, Chile, and South Africa. What they do is stare at the night sky and look for moving objects, and that is what they saw on the night of the 1st of July, just another moving object. So they classify it as a new asteroid and they are ready to move on. But then they notice something weird about this one. It is moving too fast. Everything in space is constantly in motion, and every object in the solar system rotates around the Sun because you are all trapped by its force of gravity. The fact that you are moving is what keeps us from falling into the well of gravity, and the closer you get to the Sun, the faster you have to move in order to stay afloat. But if you start to move fast enough, then you actually start to rise up out of the well. And if you reach a certain velocity, then you break free completely of the Sun's gravity and you can fly out into interstellar space. You enter the void of nothingness that exists between stars. And when astronomers clocked the velocity of this new asteroid, they were shocked. This was the fastest moving object ever detected in our solar system. Let us establish some scale here. The planet Earth orbits the Sun at a speed of 30 kilometers per second. That is us. You are moving pretty fast and you are pretty close to the Sun, but there are planets that are a lot closer. Here is Mercury, 0.4 astronomical units from the surface of the Sun. It gets cooked, and to avoid falling into the gravity well, Mercury has to orbit at a velocity of around 48 kilometers per second. The new object discovered by ATLAS was moving at 58 kilometers per second, and at the time, it was still way out there just inside the orbit of Jupiter. That is about 4.5 astronomical units away from the Sun. And at that speed, it was clear that this object was going to blow straight past the Sun and just keep on going. You call this a hyperbolic trajectory, meaning that this thing had come from the void, from interstellar space, and that is where it was going to return after completing its grand tour of our solar system. This is when the name 3I Atlas came to be, third interstellar object, which means there were two before it. You probably know this one, Oumuamua, the first ever identified interstellar visitor. And it was also pretty weird, although it was weird in a totally different way than Atlas is, and you will get deeper into that very soon. But you also have a second interstellar object, the often overlooked middle child 2I Borisov, which was actually not that weird. Aside from the fact that it was interstellar, it basically just acted like a normal comet. So if anything, it was weirdly not weird. There are three big differences between 3 Atlas and its interstellar siblings. One is size. It is literally much bigger. Oumuamua was up to 400 meters across. Borisov was as wide as 1 kilometer, but 3I Atlas could be up to 5.6 kilometers in width. 2 is speed. Atlas travels at about double the velocity of Oumuamua and Borisov, and 3 is the direction that the object came from, and this is the really weird one. Oumuamua came in from above, from the northern sky, which is the general direction that the solar system is moving. So you are all orbiting the Sun, but the Sun itself is orbiting around the center of the Milky Way galaxy, and it is dragging us along with it. So as much as Oumuamua hit us, you also kind of ran into it. 2I Borisov did mostly the same thing. It came in at more of a diagonal angle than straight on, but from the same general direction. Now 3 Atlas is not another head-on collision. This one is a T-bone, and it is coming in on that side angle in almost perfect alignment with all of the planets. Our solar system is like a disk of stuff that all formed around the Sun. Over time, all of that stuff kept smashing into each other and forming into planets and moons and asteroids and things, but it all remained in a relatively flat disk shape. You call that disk the plane of the ecliptic. There are only a few things that are a little bit offset from that plane. The most recognizable one would be Pluto. Its orbit is tilted by 17 degrees. So sometimes it is a little above the plane of the ecliptic, and sometimes it is below. It is important to know that so you can appreciate how well aligned 3I Atlas actually is. The interstellar object is only 3 degrees off from that ecliptic plane. It hit our solar system in perfect alignment with the disk. Space is 3-dimensional, and that object could have come from any direction. So to have something hit us almost perfectly side-on, it is a very big coincidence. But that leads us into an even bigger question. Where did 3 Atlas come from? Well, you know that it came from the direction of the galactic core. So, if you look at the Milky Way galaxy from this usual top-down perspective, you are here in this kind of outer half of the galaxy located in a spiral arm. When you see the Milky Way in the night sky, that is the next spiral arm over. Anyway, 3I Atlas came from the direction of this bright core in the middle. It is bright because it is full of stars, and they are packed together much more tightly than the ones in our neighborhood. But again, space is 3-dimensional. So to really understand where 3I Atlas originated, you need to flip the galaxy over to a side view. And just like our solar system, most of the stuff in the Milky Way is concentrated in a thin disk around the core. But also like our solar system, there are a few things that kind of hang out above and below the thin disk. In the galaxy, you call that area the thick disk. It is a lot less crowded in the thick disk, so you do not get nearly as many giant collisions and supernova explosions and black holes and stuff. So things in this region tend to just hang out undisturbed for very long periods of time, and that is where astronomers believe 3I Atlas came from. This ancient region of space, which could make it as old as 7.6 billion years, nearly twice the age of our own planet. Now, you will probably never be able to trace the journey of 3I Atlas all the way back to its point of origin, but astronomers have recently managed to backtrack over 10 million years, and they have identified 93 stars that the object would have encountered over that period. But what is deeply fascinating is that over the course of that 10 million years, the closest it would have come to any of those 93 other stars was a distance of 0.3 light years. That is 63,000 astronomical units. And right now, 3I Atlas is just 1.4 astronomical units away from our own sun. Now, let us talk a little bit more about how 3I Atlas approached the Sun and what you learned about it along the way. Even though 3I Atlas was officially discovered on the 1st of July, it was actually spotted for the first time on the 7th of May, 2025. It showed up in images captured by the Transiting Exoplanet Survey Satellite, or TESS. It is an observatory that orbits the Earth and looks deep into the galaxy, trying to identify new planets in other star systems. And for a period of about 1 month, TESS just happened to be looking in the direction of 3 Atlas. This gave us the opportunity to track the object as it moved through the orbit of Jupiter. The first thing that astronomers wanted to measure was the object's brightness and how it changed over time. That is going to tell us about what this thing is made of. You know that in the 1-month period that 3I Atlas was observed by TESS, it traveled about 1 astronomical unit in the direction of the Sun. So you would expect it to get brighter over that time. Astronomers use a term called flux to describe the perceived brightness of an object in space. Here is an example of how this works. Think about how bright the Sun appears from your location at noon on a clear day. Now, imagine you are transporting to the surface of Mercury. That same Sun is going to suddenly appear a whole lot brighter, bright enough to incinerate you. Now, the actual brightness of the Sun did not change, only your perception of it. That is flux. So, astron. Ohmers had a hypothesis that the flux of 3I Atlas would increase by a factor of 1.5 between May and June. But data from TESS showed that the flux actually increased by a factor of 5. So there was a massive increase in the amount of light being reflected by this object. And that is how you know that this is not an asteroid. So it must be a comet that is beginning to form its coma of gas and dust, which is what is reflecting all of that excess light. Only there are 2 weird things about this observation. One has to do with the polarization of light. Now, this is a tough one to explain, so you are going to oversimplify here. When light from the Sun hits that cloud of gas and dust around 3 Atlas, it is going to scatter in different directions. But the direction that the light bounces is not random. It can tell us a lot about the material that the light is hitting. If the light scatters off to the side at a right angle or perpendicular, then you call that positive polarization. If the light bounces straight back in a parallel direction, then you call that negative polarization. Most objects in space have a mostly positive polarization, even interstellar objects. 2I Borisov was positive, but 3I Atlas is negative. And not only that, it has the most extreme negative polarization of any object ever discovered. That is pretty weird. And it is just one of the many oddities about 3 Atlas that tells us not all solar systems are the same. What you think is normal here would be weird somewhere else. And what is normal in a different star system is considered weird around here. And then the second surprising thing about the coma of 3I Atlas was the fact that it even existed at all. Remember, you are looking at this period between May and June, and 3I Atlas is still way out there beyond the orbit of Jupiter. This is over 5 astronomical units away from the Sun. It is cold out there. It is so cold that you do not typically spot comets at 5 astronomical units because they typically have not begun to form their coma yet. They are still frozen solid. It is not usually until somewhere between 3 and 4 astronomical units that the sublimation process really kicks in. And that is because typical comets from our solar system are typically made of water ice, which needs a lot of energy to melt. But as you continued to observe 3 Atlas and you started pointing our most powerful telescopes directly at it, you learned that the coma was actually dominated by carbon dioxide gas. It did have some water vapor, but the ratio of carbon dioxide was much higher at around 8:1. That is basically the opposite or inverse of what you are used to finding in comets. If you have ever seen dry ice before, it is typically used to create a smoky effect for live performances. That is frozen carbon dioxide. It has to be created and stored at incredibly cold temperatures. And as soon as it is removed from the deep freeze, dry ice will instantly begin to sublimate, making that signature cloud of gas. That is what 3I Atlas was doing way out there in space. And that is why its coma formed so early, because carbon dioxide ice melts at a much lower temperature than water ice. And you have continued to observe 3 Atlas on its approach to the Sun. You have seen that ratio of carbon dioxide and water begin to flip. By late in September, as it was passing through the orbit of Mars at just over 1.5 astronomical units, The object had actually begun to release a massive amount of water vapor, about the equivalent of a fire hose running at full blast, which is actually more water than you would expect, even from a normal comet at this distance. You have never seen so much water vapor appear so suddenly. The same thing can be said for metal in the coma of 3I Atlas. When it was observed over the summer, astronomers detected a small amount of nickel in the surrounding cloud, but they did not detect any iron. So, a couple of things to note here. One is that nickel and iron are pretty common in the universe because they are formed inside the core of a dying star. Then that star goes supernova and blasts these metals out into the surrounding area of space, where it gets pulled in by new stars that are beginning to form their own planetary disk. And then the process repeats. So because nickel and iron come from the same place, they are typically found together in planets, moons, asteroids, and comets. So when you see a lot of nickel but no iron, you wonder where the iron went. What process separated them? And thing number two, it is weird to see any metal at all sublimating from 3I Atlas given its distance to the Sun when this observation was made. It is still way out beyond Mars in the region of the asteroid belt, which is still very cold, and the process of sublimation is driven by heat. Now, when it comes to carbon dioxide, you know that it does not need much heat in order to melt. But when you are talking about metal, there is something else going on. Likely the massive release of carbon dioxide is dragging nickel atoms along with it, but that still does not account for the iron deficiency. Now, just like water vapor made a very sudden appearance in the coma of 3I Atlas, the same thing did eventually happen with iron. By late into September, astronomers had started to detect iron for the first time in the coma. And then very quickly, the ratio of nickel to iron changed to a more normal combination of the two. So 3I Atlas is becoming more normal over time, but it is getting there in a very strange way. Now, let us talk about tails. This is another area where 3I Atlas has behaved a little different from your average comet, and that is mostly because the first time you saw a tail forming around 3I Atlas back in the summer, it was pointing in the wrong direction. This object initially formed a sun-facing tail. This is unusual because the tail is considered to be an effect of the solar wind interacting with the coma. The solar wind blows away from the sun, so therefore, you expect the tail to flow in that direction. In this case, it did not, which could be related to the early formation of the coma, which was due to the high carbon dioxide concentration. Because the object began sublimating at a very long distance from the sun, it is possible that the solar wind just was not strong enough yet to push the cloud of gas and dust away. So, what you saw was more of that cloud accumulating on the warm side of the object, the sun-facing side, before it encountered a strong enough wind to form a conventional tail, which is what 3I Atlas eventually did. By September, a short fan-shaped tail facing away from the sun had developed, which is pretty normal. Not all comets have long streaking tails like what you are used to seeing in illustrations. The length of the tail varies according to what the comet is made of and its distance to the sun. For example, Hale-Bopp is pretty famous for having a gigantic tail when it was observed in 1997. But it was also very close to the sun at that time, about 0.9 astronomical units, 1/2 of an astronomical unit closer than 3I Atlas will ever get to the sun. So of course, it experienced more sublimation and solar wind, which shaped that tail. And it is around this time that you actually get our closest possible observation of 3I Atlas, but the view does not come from the Earth, it comes from Mars. On the 3rd of October, the object passes within 0.19 astronomical units of the planet Mars, the closest it will come to any planet in the solar system. And this is lucky for us because you have a lot of cameras on and around the red planet, which means you were able to use them to image 3 Atlas. Here is a photograph taken by the Perseverance rover from the surface of Mars. This is how the object would have appeared in the night sky. It is not a great picture. This is not what the rover's camera was designed for, and in order to see this much light, the camera had to take 30-second-long exposures. Then several of those images were stacked on top of each other, so what you end up with is more like a streak than a defined object. And here is another image of 3 Atlas taken by the European Space Agency's ExoMars probe, which hangs out in orbit around Mars. You can see the object a little more clearly now, but there is still not enough resolution to distinguish between the bright coma and the surface of the object itself. In order to get that fine detail, you would need to take a photo with NASA's Mars Reconnaissance Orbiter, which has the most powerful telescope in the Mars system. Unfortunately, at the time you are making this video, that image has not been released, if it was even taken at all. Basically, there has been a shutdown of the US government, and people at NASA are not going to work until some political stuff gets resolved, which unfortunately could take some time. But time is something that you have right now, because the sun is going to continue blocking our view of 3 Atlas until early December, at which point you will be able to study the effect that the sun had on the object. Although the closest that you will get is still 1.8 astronomical units, that happens on the 19th of December. At this point 3I Atlas will be well on its way out of the solar system, but there is just one more close encounter still to come. On the 16th of March, 2026,